pop, it froze. It's frozen pop. It's not really pouring. I left it in the freezer too long. So I'm gonna add another tick to my unconventional prison cell countdown. When does the countdown end? When it does. And it's not yet. But it will end. Probably when I run out of room to make more ticks. So I'm writing a JavaScript engine, whatever. The mouse isn't working. Oh no, momento. So I'm writing a JavaScript engine. It's still not working. Why is it not working? There it goes. I'm gonna meet the 2009 standard first because it's smaller, a smaller standard. This is the wrong one. This is a 2024 standard. But this is why I'm doing the 2009 standard first, because the 2024 standard has 804 pages to the standard, while the 2009 standard has only 241 pages. So I'm gonna meet the older standard first, and then I'll do the new 100 standard. Because it'll be easier to get all the mechanisms, whatever, that are related to the JavaScript engine that are needed to meet the standard if I do the 200 page first, and then do apply that to the 800 page, because then I'll kind of have things in place and ready. It'll be easier to go through the 800 pages and just like adjust whatever was met in the 2009 standard. So today I have assembly, whatever. In Windows, being Windows, because that's what Windows does, it screwed up on my desktop. Everything moved. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's like 10 windows on my desktop. It pisses me the fuck off. So I gotta like figure out like which 2 windows go to which desktop, and then like 2 of these other windows were also flipped around. Everything's shuffled around on my fucking desktop, so I'm gonna need a couple minutes to reshuffle things back, and it's really fucking annoying. It's 2025 in Windows. They can't even do like anything. Just annoying as fuck. So I gotta like organize my desktop or whatever, and then wherever the assembly is. Where's assembly? Is it even on the desktop? Oh, here it is. So like I have assembly here, whatever. It's 16-bit assembly. I'm gonna speed test it against the modern standard 2022 Visual Studio compiler. I want to like test if I can still write code faster than the compiler with 32-bit code on x86 at least. I don't know about ARM. I've written in ARM, but I haven't like optimized ARM instruction set, whatever. I'm pretty sure I can though, whatever. It's the same exact thing, just different instructions, different architecture. You just apply whatever, it's all the same. So, the standard C compiler. When I say standard, I literally mean standard, because standards are shit in the modern C compiler, especially when it comes to Visual Studio, Microsoft Visual Studio. It's an absolute piece of shit. You write code, you make a living off writing code in C language, and Visual Studio is shit. It just wastes your time, or it wastes my time at least. I don't know, maybe everybody else finds it acceptable to make something and have Windows shit all over it. Or maybe people find it acceptable for an operating system to just not function operationally at like a fundamental level. For fuck's sake. Windows is a joke. It's a big joke. And the customer's punchline. And JavaScript is also a joke. So I'm going to make it not a joke. I'm going to highly optimize JavaScript to the point that nobody has seen. And everybody will be like, what the fuck? There's me nobody competing because it sucks having to optimize JavaScript. So this is like C language, whatever. And this is what I had to type in to get the most optimal output from Visual Studio, which is still slow as fuck. This is Visual Studio, its output for that C assembly. Because the C compiler takes what you give it based on the syntax and the rules of C language. It takes this whatever and it converts it into machine code, assembly language, whatever you want to call it. Monomics, operations, passed in to the CPU, in memory, it doesn't matter what you call it. So this is what Visual Studio makes, and this is what GCC, GNU, whatever the compiler is called, G++, GCC, I don't know, it's something like that. This is what it makes. As you can see by the size of the code itself, Visual Studio is about twice as large, a little under. That's why it's so slow. And I had to I wrote this up a whole bunch of different ways to try to optimize it. In Visual Studio, it refuses to optimize bit setting operations. It thinks intentional. They want to avoid people doing bit operations and stuff, so they don't optimize that stuff. Because this is an absolute joke. Why the hell would they negate EAX, EDX, ECX, and RD8? R8? What is that? Is D the 32-bit register? I don't know. This is I don't know. When it comes to out-of-order execution stuff, it seems like Visual Studio is intentionally making a bottleneck. And it might be on purpose too, because newer CPUs have more ports, they have a bigger instruction cache line, pipeline and stuff, so maybe Visual Studio writes code like this on purpose, so newer processors get the advantage, while the older processors kind of get phased out, and they become noticeably slower. So I don't know. This is just odd that Visual Studio does such a poor job at optimizing, quote, specific things. but GCC whatever, it makes much better code for this here whatever. This is what I was expecting. I was expecting Visual Studio to make something like this. So like the routine that I came up with, is like I think one instruction more than what GCC whatever you called came up with. So I don't know. I'm like try to speed test this now. I have a loop. I gotta open up stuff again. Alright, so I got like a loop whatever in assembly. I got it to like make a Windows alert box or something. Makes this box. And I got it to like loop through whatever, and then it puts a question mark to the text, the string whatever that's passed into this box, and then it logs it or outputs it here. I guess I can't select it, the text. So now I gotta take the assembly, whatever, that I wrote here whatever, but there's also another part up here. So I don't know, I gotta paste the full routine so like it gets of the bit position of the highest bit, the position of it in a 16-bit number. I'll update this to 64-bit after I just test make sure this works. So there's like another part to this operation. I gotta like paste it back into the disassembler to get the output again. I don't know. Then I'll be able to have like the full routine. So I gotta like first I'm gonna finish writing my routine. I gotta like run it now. And then build it, and I gotta check the log out here, make sure it works correctly, like it's like getting the right bit position. So I got a loop, it'll set a bit, it'll iterate, it'll log it, then I'll get the time for it, that takes elapse. And then after that, I'll get the disassembly for the same C code, see what the C compiler interprets it to, as in machine code whatever. And then I'll speed test, well I also gotta like check to make sure it works correctly. Sometimes the disassembler doesn't output valid code, so I gotta like check it. So I gotta check my code first, make sure it works, then I'll check after I disassemble the C code to assembly, I'll pass that in, and then I'll check it here whatever, the same way, make sure it works, make sure the timer works and stuff. And then I'm going to compare the Visual Studio versus GCC versus my assembly to see whichever is faster. And this is my first attempt to here whatever. And I'm like using a technique, whatever, to get the pin, whatever. I explained it last time. I don't know. I'll explain later. I'm tired of talking. I gotta like organize my desktop because as you can see, everything's everywhere. It's really annoying. So I don't know. I'll be right. I gotta organize my desktop. I'll get everything open and running. I'm just gonna like speed test stuff. See if this is faster. If it's not, I'm gonna optimize it. And I'll do 64-bit. But I'm doing this because the JavaScript engine I'm writing whenever I get to the 2021 standard, I'm going to be optimizing the code. I'm going to go to assembly level. So like if I can like optimize this faster than the C compiler, then when I write my JavaScript engine, it's going to be like that much faster, like for certain. And then there's also the MMX, the SIMD instructions, the simultaneous instruction, whatever it's called, multiple data, blah blah blah. So I can like write assembly and optimize JavaScript to the extent that no one has ever seen. It'll be like extremely fast, like fast enough to like use for making video games and stuff. Kind of like Unity tried to do when they wanted to make C# into like JavaScript or something. They made like a syntax where they acted like C# as JavaScript, and they had to like bail because they couldn't do it. I don't know why they would try to make like C# is terrible. I'm gonna like look that up really quick. I actually asked Chatbot because Chatbot knows everything apparently. So here's what Chatbot says.
Mingwa GCC compiler download. Google search. Online ASM syntax. Google search. ChatGPT. Skip to content. ChatGPT. You said. Did Unity try to make a JavaScript syntax for C# and then give up on it, and why?
Unity is a game engine. A very, you know what, I'm not gonna get into it.
Yes, Unity did support JavaScript-like syntax, But it wasn't actually JavaScript and it wasn't an attempt to change C# syntax. Let's clear it up.
Oh, I guess chatbot's gonna correct me. Okay. I guess I was wrong. Kind of. Or not. Who knows? Chatbot knows. So I was gonna say.
Yellow square. What Unity actually did. Unity supported a language called ECMAScript, which looked a lot like JavaScript, but was not true JavaScript. It was one of the 3 scripting languages Unity supported early on.
What the hell is boo?
Boo?
Oh my god, that's so sad.
C. ECMAScript. JavaScript like boo. Python like. ECMAScript was meant to make the engine more approachable to web developers or those familiar with JavaScript. Crossmark Unity didn't try to make C# look like JavaScript. No, Unity never tried to make C# use JavaScript syntax. ECMAScript and C# were separate languages. C# always remained the primary and officially supported language with its standard .NET-based syntax.
I'm gonna ask chatbot if ECMAScript is .NET based, and if it is, then it's the same thing as C#. If it's not a different language. That's so stupid.
Was ECMAScript .NET based? Yes. Or no? No BS. ChatGPT said, yes. ECMAScript was .NET based. Yes.
Which means that it was C#. Duh. So here's why they dropped ECMAScript, their attempt to make JavaScript in C#, though technically speaking a different language, but it's still fucking.
ChatGPT said, yes. ECMAScript was .NET based. No BS.
So no bullshit. It's the same fucking thing. It's C# basically. So I don't know, whatever.
Crossmark Unity didn't try to make C# look like JavaScript. No, Unity never tried to make C# use JavaScript syntax. ECMAScript and C# were separate languages. C# always remained the primary and officially supported language with its standard .NET-based syntax.
Standards are a joke.
Octagonal sign. Why Unity dropped ECMAScript. Unity officially deprecated ECMAScript and Boo in 2017, and here's why. 1. Fragmentation and confusion. Supporting multiple languages caused confusion, especially since ECMAScript and C# had different APIs and quirks. Documentation and tutorials were often inconsistent or language-specific.
Imagine that. It's the year 2025, and they can't make new languages because they have different APIs and quirks. What the fuck is a quirk? You mean a bug? Like a memory leak? Or like shit that just doesn't work? The wording, the context, it's great. C# is not dominant. C# is a joke.
2. C# became dominant. C# matured rapidly, gained more features, linq, async await, etc., and was tightly integrated with Unity's engine and editor. The Unity community overwhelmingly adopted C#. 3. Maintenance burden. Maintaining compilers, tooling, and support for multiple languages increased development overhead. Focus shifted to improving the C# experience with features like the new X entity components system and Unity's job system.
Okay, so basically, JavaScript is a really difficult thing to optimize. And I'm gonna do it the best. So anyways. I'm gonna have Siri read one of these standards.
It is a syntax error if any source text is matched by this production. ECMA International.
And I'll put up the BRB screen. And I will be back after I reorganize my desktops. Because everything like moved, as you can see, to the first desktop. And it's really frustrating. All the windows also, they like resized. So I have to reorganize everything on my desktop again. And then I'll BRB. So when I get back, I'm gonna like write an assembly, speed test some stuff, compare the modern compilers and stuff or whatever. I don't know. I'll BRB.
Call expression. Expression. The dot notation is explained by the following syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name 3, 3, 2, 1 runtime semantics, evaluation, member expression, expression, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict, 60, ECMA International 2024, member expression, identifier name, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, member expression, private identifier, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E R T Y, capital A C C E S S, capital W I T H, capital E X P R, base value, expression, strict, call expression, identifier name, let base reference be, evaluation of call expression, let base value be, get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict, call expression, private identifier, let base reference be, evaluation of call expression, let base value be, get value, base reference, let field name string be the string value of private identifier, return make private reference, base value, field name string, 3, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, base value, expression, strict, the abstract operation, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 4, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict, the abstract operation, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261 133 5. The new operator 3 5 1. Runtime semantics. Evaluation, new expression, new expression. Return, evaluate new expression, empty. Member expression, New member expression arguments 1. Return. Evaluate new member expression arguments 3, 3, 5, 1. 1. Evaluate new construct expr arguments. The abstract operation evaluate new takes arguments construct expr, a new expression parse node or remember expression parse node, and arguments empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expr. Let constructor be. Get value ref. If arguments is empty, then a let arglist be new empty list for. Else a let arglist be. Argument list evaluation of arguments. If this constructor is false, throw a type error exception. Return. Construct. Constructor. Arglist. 3, 3, 6 function calls. 3, 3, 6. 1 runtime semantics. Evaluation. Call expression. Capital C, O, V, E, R. Capital C, A, L, L. Capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let expr be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let member expr be the member expression of expr. Let arguments be the arguments of expr. Let ref be. Evaluation of member expr. Let func be. Get value ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func, %eval % is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value ref. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call. 62. ECMA International 2024 133 2. Evaluate call, func, ref, arguments, tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then
I said I was gonna get up
then I let this value be get this value.
and then organize my desktop. But I got up and I did everything except organize the desktop. So now I'm gonna organize the desktop anyways and try to get to assembly. I don't know, I'm a little distracted today.
Throw a type error exception.
So I'm gonna try to I'll just throw everything to another desktop. I'll do organizing later because everything's just gonna move around again anyways. That's the way of Windows. how it works.
Property. Super.
Everything sucks.
B get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key. Property name value. If the source text matched by the super property is strict mode code.
So I don't know. I'm organized. Not organized. I'm just gonna keep the couple windows that I need open and just move the rest to another window. I'm gonna like listen to music, try to like get the assembly routine running. Gotta check it, make sure it works, and then I'll reassemble the other compiler's output, type them in, run stuff, compare it. So I gotta get to that point, so that's what I'm gonna do. I can't talk through every single step because I did that yesterday and I got nothing done. It took so long to get anything done. So I'm gonna try to just get something done today. I have to get back to parsing on the engine. I can't just mess around with assembly all day. I have to get back to the engine stuff.
Arg list. New target. Let the SER get this environment.
So I don't know, so I'll do whatever.
Result. Let F be the SER 0. A SER
Define some music.
script function object 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 133 to get superconstructor. The abstract operation get superconstructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec be get this environment. Assert. Envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 3 7 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. Env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 8 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024 3. Let arg be. Get value. Ref. Return the list.
I don't know. If you ever want to write in assembly, because you should like not be watching this stream. And if you want to program, you should go program. So don't watch this stream. Go live your life and do something with your life. Because there's no point in watching someone else live their life. I'm just documenting this because no one's gonna believe me. So I have to like, I don't know. I don't want to go over the whole thing. I'm gonna document going through the standard page by page until it's done. And that's going to be like my video documentation that I meet every point in the standard. So when I release it, if someone asks, do you meet this part of the standard, this part, I'll pull up the live streams and be like, oh, on this date, this day, this video, I have it marked here at this timestamp that I met this part of the standard. This part of the standard, I'll go through the whole thing. Or, I don't know, that's why I'm doing this. So I'm just building up until I'm ready to actually go through the standard stuff.
Let first
But if you want to write an assembly, whatever, for x86, 64.
substitution evaluation of template spans. Assert. Rest sub is a possibly empty.
Which is easier than ARM. Assembly, whatever. Where's the browser?
9. 1 runtime semantics. Evaluation. Optional expression. Member expression.
You could use NASM, an assembler, whatever.
Member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with
Type in NASM assembler, I guess.
optional expression. Call expression optional chain. Let base reference be.
And you download the assembler.
Let base value be.
And it shows up as a command line tool
Value is either undefined or null.
on the desktop. I don't think they always had an icon to click, but now they have one. I think it used to be like command line, you always had to open it. Now there's like a shortcut, I guess.
Which begins with the token
And then you need like a linker.
for 200.
So you guys Visual Studio. So like you download Visual Studio,
Let base reference
just install the whole thing. It's like 40 gigs or something.
base value be. Get value. Base
It's like 40 gigs for Visual Studio.
null. Then a return undefined.
And in those 40 gigs, Visual Studio takes code like this, C code, and it makes this. So with 40 gigabytes of code, processing, raw processing, power, CPU, documentation, and intrinsics, 40 gigabytes makes this shit-ass output of assembly. While GCC, it's free, open source, designed by people that are smarter than the people that work at Microsoft. It's not 40 gigabytes, and they're able to make this output. So, Visual Studio, it's a sucky compiler. You should probably link with GCC. I don't know. Both are difficult to work with, but GCC, it's better in some cases. Everything has its pros and cons. I guess, I don't know.
You
But you make the assembly, it makes like an object file or something, then you link it to the compiler,
capital A C C E S S capital W I T H capital E X
I think it's a developer command prompt or something for Visual Studio.
strict optional chain. Identify a name if the source text matched by this optional chain is strict mode code. Let
So you make the NASM, you assemble assembly,
turn capital E V A
make the object file,
A T E capital P R O P E
and then you call link or something, and that makes a executable,
C E S S
and it makes
I T H
the executable, so you can click it,
base value. Identify a name.
and it runs
Private identifier. Let field name string be
as output to somewhere. So I don't know. It's not that simple. It's kind of complicated. You'd have to figure it out. But go have fun. Like Joe Biden said, whatever.
let new reference be. Change
Quote Joe Biden.
base value and base reference. Let new value be. Get value. New
Joe Biden has also said his butt's been wiped.
B is in tail position. This chain return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E.
Anybody who could go down 300 to 3,000 feet in the mine, sure and hell can learn how to program as well. Give me a break. Anybody who can throw coal into a furnace can learn how to program, for God's sake. Anybody who could go down 300 to 3,000 feet in the mine, sure and hell can learn how to program as well. Give me a break. Anybody who can throw coal into a furnace can learn how to program, for God's sake. Anybody who could go down 300 to 3,000 feet in the mine.
Okay, so I'm just gonna like let this run on loop because it's funny, and to like discourage you from watching this stream and go live your life. So I'm gonna like assemble this stuff. I'm gonna make sure this works. I'm gonna play Joe Biden on loop for a minute. So I don't know. Have fun. This guy's I guess you could call him an inspiration. You could also call him senile. And we all know the election was stolen. So I won't go there, whatever. Yeah, I'll just like leave this on loop. This guy was president of the United States of America. And I don't know what extracting coal mining, has to do with throwing coal into a furnace. I think that's like two separate jobs, and he kind of mixed them up as to one. So I don't know what he's getting at. Maybe you can make something out of what he's saying. So I gotta like get some code running. I'll like turn this off in a minute.
Learn how to program as well. Give me a break. Anybody who can throw coal into a furnace can learn how to program, for God's sake.
Rict. Optional chain. Optional chain. Identify a name. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N. New value. Identify a name. Strict. 66. ECMA International 2024. Optional chain. Optional chain. Private identifier. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3.3.1.0. 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let arggraph be. Evaluation of assignment expression. Let specify be. Get value. rgreph. Let promise capability be new promise capability, %promise %. Let specifier string be completion, to string, specifier. If abrupt reject promise, specifier string, promise capability, perform host load imported module, referrer, specifier string, empty, promise capability, return promise capability, 3, 3, 1 0, 1, 1 continue dynamic import, promise capability, module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused. Let onRejected be create built-in function rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion module link be if link is an abrupt completion, then I perform call promise capability undefined link 2. Return unused. C let evaluate promise be module evaluate. D let fulfill. Let closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace. Module 2. Perform call promise capability undefined namespace 3. Return unused. E let unfulfilled be create built-in function fulfilled closure 0. F perform promise then evaluate promise unfulfilled onRejected. G return unused. Link and evaluate be create built-in function link and evaluate closure 0. Let perform promise then load promise link and evaluate onRejected. Return unused. ECMA International 2024 267. The 13th of March 2011 tag templates 3. 3. 1 1. 1 runtime semantics. Evaluation. Member expression template literal. Let tag ref be. Evaluation of member expression. Let tag font be. Get value. Tag ref. Let this call be this member expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression template literal. Let tag ref be. Evaluation of call expression. Let tag font be. Get value. Tag ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. The 3rd of March 2012 meta properties. 3. 3. 1 2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meta. Let module be get active script or module. Assert. Module is a source text module record. Let import meter be module. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw import meter. P. D perform host finalize import meter module. E set module to import meter. F return import meter. Else. A assert import meter is an object. B return import meter. 3. 3. 1 2. 1. 1 host get import meter properties. Module record. The host-defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1328. The actual arguments include a template object 13284 and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign ECMA International 2024 133121. To host finalize import meter module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression yield await left-hand side expression yield await left-hand side expression yield await left-hand side expression yield await plus unary expression yield await unary expression yield await 1341 static semantics early errors update expression left-hand side expression plus no line terminator here plus no line terminator here. Left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3, 4, 2 postfix increment operator 1, 3, 4, 2, 1 runtime semantics. Evaluation. Update expression. Left-hand side expression plus let LHS be. Evaluation of left-hand side expression. Let old value be. Numeric. Get value. LHS. If old value is a number, then a let new value be number. Add old value. 1. Else. Assert. Old value is a big int. Be let new value be big int. Add old value. 1z. Perform. Put value. LHS. New value. Return old value. ECMA International 2024 269. 1, 3, 4. 3 postfix decrement operator 1, 3, 4, 3. 1 runtime semantics. Evaluation. Update expression. Left-hand side expression. Let LHS be. Evaluation of left-hand side expression. Let old value be. Numeric. Get value. LHS. If old value is a number, then a let new value be number. Subtract old value. 1. Else. Assert. Old value is a big int. Be let new value be big int. Subtract old value. 1z. Perform. Put value. LHS. New value. Return old value. 3, 4. 4 prefix increment operator 1, 3, 4, 4. 1 runtime semantics. Evaluation. Update expression. Plus unary expression. Let x be. Evaluation of unary expression. Let old value be. Numeric. Get value. Exper. If old value is a number, then a let new value be number. Add old value. 1. Else. Assert. Old value is a big int. Be let new value be big int. Add old value. 1z. Perform. Put value. Exper. New value. Return new value. 3, 4. 5 prefix decrement operator 1, 3, 4, 5. 1 runtime semantics. Evaluation. Update expression. Unary expression. Let x be. Evaluation of unary expression. Let old value be. Numeric. Get value. Exper. If old value is a number, then a let new value be number. Subtract old value. 1. Else. Assert. Old value is a big int. B. Let new value be big int. Subtract old value. 1z. Perform. Put value. Exper. New value. Return new value. 70. ECMA International 2024. 13.5 Unary operators syntax. Unary expression. Yield. Await. Update expression yield await. Delete unary expression yield await. Void unary expression yield await. Type of unary expression yield await plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await plus await. Await expression yield 3, 5, 1 third delete operator 3, 5, 1, 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. Or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N and capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1. To runtime semantics. Evaluation. Unary expression. Delete unary expression. Let ref be. Evaluation of unary expression. If ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert ref is false. B return true. If is property reference, ref is true, then assert is private reference, ref is false. B if is super reference, ref is true. Throw a reference error exception. C let base obj be. To object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be ref. B assert. Base is an environment record. C return base delete binding. Ref. The last rule means that expressions such as delete foo produce early errors because note of recursive application of the first rule. ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code. A syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2 the object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 avoid the operator. 3, 5, 2, 1 runtime semantics. Evaluation. Unary expression. Void unary expression. Let x be. Evaluation of unary expression. Perform. Get value. Exper. Return undefined. 3, 5, 3 the TPOF operator. 3, 5, 3. 1 runtime semantics. Evaluation. Unary expression. Type of unary expression. Let val be. Evaluation of unary expression. If val is a reference record, then if is unresolvable reference, val is true. Return undefined. Set val to. Get value. Val. If val is undefined, return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0, If val is a big int, return big int. 1. Assert val is an object. 2. Note, the step is replaced in section B. 3, 6, 3, 3. If val has an internal slot, return function. 4. Return object. 3, 5. For unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1354. 1 Runtime semantics. Evaluation. Unary expression plus unary expression. Let X be. Evaluation of unary expression. Return to number. Get value. Expa. 3, 5, 5 unary operator. 3, 5, 5. 1 Runtime semantics. Evaluation. Unary expression. Unary expression. Let X be. Evaluation of unary expression. Let old value be. Denumeric. Get value. Expa. If old value is a number, then a return number. Unary minus old value 4. Else AB. Assert. Old value is a big int. Return big int. Unary minus old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note, produces minus 0. And negating minus 0 produces plus 0. Bitwise not operator. Unary expression. Unary expression. 3, 5, 6. 3, 5, 6. 1 Runtime semantics. Evaluation. Let X be. Evaluation of unary expression. Let old value be. Denumeric. Get value. Expa. If old value is a number, then a return number. Bitwise not. Old value 4. Else AB. Assert. Old value is a big int. Return big int. Bitwise not. Old value. Logical not operator. Unary expression. Unary expression. 3, 5, 7. 3, 5, 7. 1 Runtime semantics. Evaluation. Let X be. Evaluation of unary expression. Let old value be to Boolean. Get value. Expa. If old value is true, return false. Return true. 3.6 Exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273. 136. 1 Runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Update expression. Exponentiation expression. 3.7 Multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of %. 3, 7. 1 Runtime semantics. Evaluation. Multiplicative expression. Multiplicative expression. Multiplicative operator. Exponentiation expression. Let op text be the source text matched by multiplicative operator. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Multiplicative expression. Op text. Exponentiation expression. 3.8 Additive operators syntax. Additive expression. Yield. Await. Multiplicative expression yield await. Additive expression yield await plus multiplicative expression yield await. Additive expression yield await. multiplicative expression yield await. 3, 8, 1. The addition operator plus. Note the addition operator either performs string concatenation or numeric addition. 3, 8, 1. 1. Runtime semantics. Evaluation. Additive expression plus multiplicative expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, additive expression plus multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024. 138. To the subtraction operator. 3, 8, 2. 1. Runtime semantics. Evaluation. Additive expression, multiplicative expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, additive expression, multiplicative expression. 3.9 bitwise shift operators syntax. Shift expression, yield, await. Additive expression, yield, await. 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 3, 9, 1. The left shift operator. 3, 9, 1. 1. Runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, shift expression, additive expression. 3, 9. To the signed right shift operator. 3, 9, 2. 1. Runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I N A R Y, capital E, shift expression, additive expression. 3, 9. 3. The unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 139 3. 1. Runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E V A L U A T E, capital S T R I N G, capital O R, capital N U M E R I C, capital B I-N-A-R-Y, capital E, shift expression, additive expression, 3.10 relational operators, syntax, relational expression, in, yield, await, shift expression yield await, relational expression in yield, 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 await, shift expression yield await, shift expression yield await, equals shift expression yield await, equals shift expression yield await, instantia of. Note 1. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await, plus in, relational expression, plus in yield await, in shift expression yield await, plus in, private identifier in shift expression yield await. 3.10. 1 runtime semantics, evaluation, relational expression, shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, true if R is undefined, return false, otherwise, return R, relational expression, shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, false if R is undefined, return false, otherwise, return R, relational expression, equals shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, false if R is either true or undefined, return false, otherwise, return true. 276. ECMA International 2024. Note 2. The in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, reval, true if R is either true or undefined, return false, otherwise, return true. Relational expression instantia of shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, return, instantia of operator, reval, relational expression in shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref. If reval is not an object, throw a type error exception, return, has property, reval, to property key, val, relational expression, private identifier in shift expression. Let private identifier be the string value of private identifier, letter FB, evaluation of shift expression, letter val B, get value, ref. If reval is not an object, throw a type error exception. Let private env be the running execution context's private environment. Let private name be resolve private identifier, private env, private identifier. If private element find, reval, private name, is not empty, return true, return false. 3.10. 2 instantia of operator, v, target. The abstract operation instantia of operator takes arguments v, an ECMAScript language value, and target, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if V is an instance of target either by consulting target's at has instance method or, if absent, determining whether the value of target's prototype property is present in V's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be get method target at has instance. If inst of handler is not undefined, then a return to boolean. Call inst of handler target v if is callable. Target is false. Throw a type error exception. Return ordinary has instance target v. Note steps 4 and 5 provide compatibility with previous editions of ECMAScript that did not use a at has instance method to define the instantia of operator semantics. If an object does not define or inherit at has instance, it uses the default instantia of semantics. ECMA International 2024 277 13.11 Equality operators. Syntax. Equality expression in yield await. Relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3.1.1 runtime semantics. Evaluation. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Return. Is loosely equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Letter b. Is loosely equal. Val. Dot. If R is true, return false. Otherwise, return true. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Return is strictly equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val b. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val b. Get value. Ref. Let R be is strictly equal. Val. If R is true, return false. Otherwise, return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $the $, b. Numeric comparison can be forced by plus equals plus b. Boolean comparison can be forced by equals b. Note 2. The equality operators maintain the following invariants. Up equals b is equivalent to up equals b. Up equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string the equals a and a equals new string the are both true. New string the equals new string the is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 binary bitwise operators syntax, bitwise and expression in yield await, equality expression in yield await, bitwise and expression in yield await, and equality expression in yield await, bitwise or expression in yield await, bitwise and expression in yield await, bitwise or expression in yield await, bitwise and expression in yield await, bitwise or 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 expression in yield await. 3, 1, 2, 1 runtime semantics, evaluation, bitwise and expression and equality expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise and expression, and equality expression. ECMA International 2024 279. Bitwise or expression, bit, wise and expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, bitwise or expression, bitwise or expression. 3.13 binary logical operators syntax, logical and expression in yield await, bitwise or expression in yield await, logical and expression in yield await, and bitwise or expression in yield await, logical or expression in yield await, logical and expression in yield await, logical or expression in yield await, logical and expression in yield await, coalesce expression in yield await, coalesce expression head in yield await, bitwise or expression in yield await, coalesce expression head in yield await, coalesce expression in yield await, bitwise or expression in yield await, short circuit expression in yield await, logical or expression in yield await, coalesce expression in yield await. 3, 1, 3, 1 runtime semantics, evaluation, logical and expression and bitwise or expression, letter FB, evaluation of logical and expression, letter val B, get value, ref, let bool be to boolean, val, if bool is false, return val, letter FB, evaluation of bitwise or expression, return, get value, ref, logical or expression, logical and expression, letter FB, evaluation of logical or expression, letter val B, get value, ref, let bool be to boolean, val, if bool is true, return val, letter FB, evaluation of logical and expression, return, get value, ref, 280, ECMA International 2024. The value produced by a and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions, coalesce expression head, bitwise or expression, letter FB, evaluation of coalesce expression head, letter val B, get value, ref, if the val is either undefined or null, then a letter FB, evaluation of bitwise or expression be return, get value, ref, else, a returnal val. 3.14 conditional operator. Syntax, conditional expression, in, yield, await, short circuit expression in yield await, short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await. 3.14. 1 runtime semantics, evaluation, conditional expression, short circuit expression, assignment expression, letter FB, evaluation of short circuit expression, let val be to boolean, get value, ref, if val is true, then a let true ref b, evaluation of the first assignment expression be return, get value, true ref, else a let false ref b, evaluation of the second assignment expression be return, get value, false ref. Note the grammar for a conditional expression in ECMAScript is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment operators syntax. Assignment expression in yield await, conditional expression in yield await plus yield expression in await, arrow function in yield await, async arrow function in yield await, left hand side expression yield await equals assignment expression in yield await, left hand side expression yield await, assignment operator assignment expression in yield await, left hand side expression yield await, and equals assignment expression in yield await, left hand side expression yield await equals assignment expression in yield await, left hand side expression yield await equals assignment expression in yield await, assignment operator 1 of percent equals plus equals and equals 3.15 static semantics, early errors, assignment expression, left hand side expression equals assignment expression. If left hand side expression is either an object literal or an array literal, the following early error rules are applied. Left hand side expression must cover an assignment pattern. If left hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression, and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3.15 to runtime semantics, evaluation, assignment expression, left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter FB. Evaluation of left-hand side expression, if is anonymous function definition, assignment expression, and is identifier ref of left-hand side expression are both true, then I let val be. Named evaluation of assignment expression with argument ref. See else. I let ref be. Evaluation of assignment expression 2. Let val be. Get value, ref. D perform. Put value, ref. Reval. Return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref be. Evaluation of assignment expression. Let val be. Get value, ref. Perform. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of assignment pattern with argument reval. Return reval. Assignment expression, ft hand side expression, assignment operator, assignment expression, let FB. Evaluation of left hand side expression, let val be. Get value, ref, let ref b. Evaluation of assignment expression, let eval b. Get value, ref, let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals and equals. Let R be capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R val op text reval perform put value ref R return R assignment expression left hand side expression and equals assignment expression. Let ref b evaluation of left hand side expression. Let val b get value ref let bool be to boolean val if bool is false return val if is anonymous function definition assignment expression is true and is identifier ref of left hand side expression is true, then let val b named evaluation of assignment expression with argument ref else let ref b evaluation of assignment expression b let reval b get value ref perform put value ref reval return reval assignment expression left hand side expression equals assignment expression. Let ref b evaluation of left hand side expression. Let val b get value ref let bool be to boolean val if bool is true return val if is anonymous function definition assignment expression is true and is identifier ref of left hand side expression is true, then let val b named evaluation of assignment expression with argument ref 6 else let ref b evaluation of assignment expression b let reval b get value ref ECMA International 2024 283 7 perform put value ref reval return reval assignment expression left hand side expression equals assignment expression. Let ref b evaluation of left hand side expression. Let val b get value ref if val is neither undefined nor null return val if is anonymous function definition assignment expression is true and is identifier ref of left hand side expression is true, then let val b named evaluation of assignment expression with argument ref else let ref b evaluation of assignment expression b let reval b get value ref perform put value ref reval return reval 3 1 5 3 capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R val op text reval the abstract operation capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R takes arguments val an ECMAScript language value op text comma percent plus and or and reval an ECMAScript language value and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If op text is plus, then let b to primitive val b let b to primitive reval see if prim is a string or reprim is a string, then I let lstrb to string prim 2. Let rstr be. To string, reprim 3. Return the string concatenation of lstr and rstr. Dset lval till prim. Eset raval to reprim. Note: at this point, it must be a numeric operation. Let num be. To numeric, lval. Let num be. To numeric, raval. If type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code. It is a runtime error if ref in step 1d, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value abcd. Let if op text is return big int exponentiate num renum. If op text is return big int divide num renum. If op text is return big int remainder num renum. If op text is return big int unsigned right shift num renum. Operation be the abstract operation associated with op text and type num. In the following table, 84 ECMA International 2024 op text type num. Operation number exponentiate number multiply big int multiply number divide number remainder number add percent plus number big int number op text type num plus big int number big int number big int number big int comma number big int number big int number big int. Operation big int add number subtract big int subtract number left shift big int left shift number signed right shift big int signed right shift number and signed right shift number bitwise and big int bitwise and number bitwise or big int bitwise or number bitwise or big int bitwise or return operation num renum. Note 1: no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2: step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, op text, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, op text, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of left operand. Let val be. Get value. Ref. Let ref be. Evaluation of right operand. Let val be. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, op text, reval. 3, 1, 5, 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await, array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern, yield, await, assignment dress property yield await, assignment property list yield await, assignment property list yield await, assignment dress property yield await opt, array assignment pattern, yield, await, eligible assignment dressed element yield await opt, assignment element list yield await, assignment element list yield await, eligible assignment dressed element yield await opt, assignment dress property, yield, await dart. Destructuring assignment target yield await, assignment property list, yield, await, assignment property yield await, assignment property list yield await, assignment property yield await, assignment element list, yield, await, assignment elision element yield await, assignment element list yield await, assignment elision element yield await, assignment elision element, yield, await, elision assignment element yield await, assignment property, yield, await, identifier reference yield await, initializer, plus in yield await opt property name yield await, assignment element yield await, assignment element, yield, await, destructuring assignment target yield await, initializer, plus in yield await opt, assignment dressed element, yield, await dart. Destructuring assignment target yield await, destructuring assignment target, yield, await, left-hand side expression yield await. 3. 1 5, 5, 1 static semantics, early errors, assignment property, identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment dress property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 1 3, 1 5, 5, 2 runtime semantics. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T. The syntax directed operation. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, takes argu, men value, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value. Perform. Capital P, R, O, P, E, R, T, Y, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment property list with argument value. Return unused. Object assignment pattern. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be in new empty list. Return. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A of assignment dress property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be. Capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment property list with argument value. Return. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator value sync return. Iterator close. Iterator record. Normal completion. Unused. Array assignment pattern. Elision. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision not assignment dressed element. Let iterator record B. Get iterator value sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision not assignment dressed element opt. Let iterator record B. Get iterator value sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Street. Status. B return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment dressed element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5 3 runtime semantics. Capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax-directed operation, capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, takes argument value, an ECMAScript language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all the structured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let ref be resolve binding. P let V be jet value P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true, then I set V to named evaluation of initializer with argument P be else I let default value be evaluation of initializer to set V to get value default value perform put value ref V return P 88 ECMA International 2024 assignment property property name assignment element let name be evaluation of property name perform capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V, of assignment element with arguments value and name. Return name 3155 for runtime semantics. Capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A. The syntax directed operation capital R E S T capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A takes arguments value, an ECMAScript language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment dress property, destructuring assignment target, let ref be evaluation of destructuring assignment target, let rest objb ordinary object create, % object prototype %, perform Copy data properties. REST OBJ. Value. Excluded names. Return. Put value. Ref. REST OBJ. 3. 1 5 5 5 Runtime semantics. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax directed operation. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N takes argument iterator record, an iterator record, and returns either a normal completely on containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment elision element, return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record. Assignment element list, assignment element list, assignment elision element. Perform. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment element list with argument iterator record. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N of assignment elision element with argument iterator record. Assignment elision element. Assignment element. Return. Capital I T E R A T O R capital D E S T R U C T U R I N G capital A S S I G N M E N argument iterator record. Assignment elision element. Elision assignment element. Perform. Capital I T E R A T O R capital D E S T R U C T U R I N G cap
Is okay, it's working. I don't know. Uh, I'm not a witch. People get these crazy ideas, whatever. I just joke about it. I'm good at predicting things, and I'll predict something will happen, and then it happens, and it seems like I caused it, but I didn't. I just kind of knew what would happen before it happens, because I'm good at predicting what will happen. So, I don't know. People take me seriously sometimes they don't. I don't know. People are silly. I'm not a witch, though. Just saying. And, when I say hexadecimal, I kind of feel like it plays in to whatever. Get to it. Anyways, I'm gonna try to like say binary as much as I can and avoid the word hexadecimal because there's some people who are like dead set with these stupid narratives, whatever you want to call it. So I'm like avoid the word hexadecimal. And I'll like print things in binary just because. So if you look at the Charco table, the number 1 is I think it's this one first. I think it's 31. I'm gonna Google it really quick. I think I typed the chart up right. It should be right. If not, I gotta like adjust the chart. I'll output to this window. In binary instead of the other representation of numbers. So I'll make this a 16-bit wide number instead, and I'll print binary, so like 0101. And I'm setting a bit here before loop entry. And I'm gonna roll it, so I rotate left, whatever. I just wish this would fucking work. Okay, now it's working. Windows sucks. Something's wrong with the USB. I need to get a new motherboard. This thing's dying. The USB ports are like peeling off the board. Dell sucks. The quality of a Dell computer, it's not very good. So I set a bit to the bottom bit of the value. It's a 16-bit value, and I'm gonna rotate it, roll to the left, whatever, so the bit gets carried to the left each time. I'm only looping 16 times. But if I went more than 16, 16 in length, so 0 to 15, not the 16th, is the number of times it loops. So like, there's a 16. possible bit positions when the number is 16 bits, like obviously. So this is a number, so like 4 bits in a nibble. If you want to call it a nibble, it doesn't matter what you call it. And then there's 2 nibbles per byte, or uint16, which is 16 bits. I mean uint8, so it's 1, 2, 3, 4, 5, 6, 7, 8. So this is a byte, and this is a byte. So now it's like 16 bytes. 16 bits, 2 bytes. So in hexadecimal, the word I want to avoid, it's harder to explain it because it looks like this, or I don't know. I'll like write it out in binary first. It's easier to understand explaining in binary anyways than it is in hexadecimal, whatever. So like, I'm setting the value to a bit, the number 1, which means only the bottom bit is set. So the bottom bit's set, and then it enters the loop, whatever. So I should be setting this bottom bit to the top of the register. So I'll just do like rotate right, one bit. I could change the value, whatever, but it doesn't matter. So now, after it sets the bottom bit here, it's going to rotate it to the right. And then the rotate is different than a shift. It's going to keep what was on the left-hand side and rotate it. So when it rotates to the right, this number here gets shifted 1, and then this bit ends up at the top of the number, whatever. So now, when it enters the loop, it's going to look like that, the bit on top. So when it rotates to the left 1 bit, that bit at the top, it's going to end up at the bottom here. And when does the next loop entry? I don't know, this is like really simple stuff. I'm just explaining it, whatever. It'll be set here, and when it rotates left again, it's to be set here. So if I was going to do more than 16 loops, iterations, 16 length of iterations, that's how I would preserve this bit. Because if you're shifting it, it's going to get lost when it gets shifted off the end. So I don't know. Rotate instructions are slower than shift instructions. But I don't know. Assembly is a lot better than C language. Well, then I guess it depends on the CPU. I won't get into it, but C language doesn't have rotate natively in the language. You can make macros and stuff, but it's not the same. I don't know, I'll just try to stay on track. So if I keep rotating the bit, each iteration, whatever, this is what the binary number looks like. This is 0, 1, 2, 3. Okay, so it should be really easy to see this, whatever. So you see like the bit, it's getting rotated to the left in the 16-bit value. Now rotate means that if I was in a loop again and continue to rotate after this bit gets shifted to the end here, when it rotates again, the bit won't be lost because it rotates the value in the register. It's going to be carried around to the bottom again and go back up to the top, and then you can rotate again or whatever. I don't know, it doesn't matter. And it's not just a bit. If it was a whole value, like if it was that, when it rotates left, it's going to retain the whole value. So the whole value gets like rolled in the register. When it shift, it's going to like destroy the top bits. So whatever gets shifted in at the bottom will be zeros. Unless it's a assigned left shift, which I don't think any CPU supports. But if it's assigned right shift, it might carry in a 1 if the sign bit's 1, or a 0 if the sign bit's 0. So I don't know. I'm just printing as binary, whatever. Okay, so this is like the binary representation of this bit being shifted, whatever. So as hexadecimal, it's gonna look like this. Okay, so hexadecimal, as implied by the name, ending in decimal. Zero. Okay, hexadecimal doesn't match up to the actual bit position. So I shouldn't even put it on the right hand side because it's confusing. In binary, the common convention for counting is starting with 0 and then setting 1. And every time it's been saturated, the length of bits, whatever, you start with another 0. And then you set a 1. And then you set a 1. And when it's been saturated, you get another 0. It's the same thing as a decimal. You go to 9, you get 10, except 10 uses 0 as a placeholder for the column of 10, where binary has no placeholder. The column is the column itself. I guess, technically, I don't know, whatever. So you get 10, you get 20, you get 30. At some point, you get to 99, whatever, you get 100. So decimal's different in the grouping, whatever, because it's by tens when the new column's added. Binary doesn't do that, whatever. So, like, I don't know. If you take 0, 0, 0, 1, 1, 0, 1, 1, and then you duplicate the pattern like this. You get 0, 0, 1, 1, 0, 1, 1. And then you paste on the left of this the original 0, 0, 0, 1, 1, 0, 1, 1 for each of the grouping of 4. You now have 0 to 15 in binary, whatever. So this gets translated, or it's represented in hexadecimal, not by decimal, because as you can see, 9 is a digit. It's used in decimal numbers, whatever. So if you're going to add another number 9 in decimal, you'd add another column. So what, like 19? Like, that doesn't work. It's only 0 to 9. That's used for decimal. So for hexadecimal, the geniuses that decided to represent it said, let's use letters. That's how they decided to represent numbers in hexadecimal. Now this is very confusing when you learn programming, because they take a number system that you know that's decimal, and then they mix it in with binary, and it represents part of the numbers. And on top of that, they throw in letters. So like, if you're learning how to program, you're like, what the fuck is going on? So that's how it is, whatever. So since you can only represent a single digit, or it's assumed, or the common convention is to use a single digit for a single representation of a grouping, and this is a grouping of 15, 0 to 15 in binary, they needed a symbol. It's just a symbol. It doesn't matter what it is. It just needs to represent it. So it can be converted or represented as binary as another symbol, which is 1010 for A at least. So instead of going like that, because that's just as confusing as A, B, C, D, E, F, they go A, B, C, D, E, F. So I don't know. That's hexadecimal, or the explanation of how it works, whatever. So I'm gonna try. So like this here represented in hexadecimal would be so like as you can see here, each hexadecimal number represents 4 bits. So it takes 2 hexadecimal numbers to make 8 bits. And you just place them next to each other. So now it's a hexadecimal number that's 8 bits. That's just like the number 10, the number 20, 30. And then you like add another column to it. So now it's like 3 columns, 1, 2, 3. It's the same thing with hexadecimal, but it's a grouping of 4 bits represented by a symbol. So I'll like split this up into 4. Okay, but basically what I'm getting at here is that instead of printing hexadecimal like I am right now, when I click this and open it, right now it's printing 69 whatever. I'm going to print binary instead. So when it shifts the position of the bit to the left, when its output to this window, instead of being hexadecimal, that is right now, I want to avoid the word hex and instead I'll print it as binary like this. So it's like easier to see anyways. Because as hexadecimal, if I go like Control F, that matches up with 1 in hexadecimal. If I do Control F, this pattern of 4 bits is represented by 2 in hexadecimal. If I do the next one, that should be 4. So I might look up down here, whatever. And yeah, that's 4 in hexadecimal. And this should be 8 in hexadecimal. And you see it's highlighted. It's 100. So that's 8 in hexadecimal. So this is 4 zeros. That's 0 in hexadecimal, because you can see here it matches. So that's 0. And then these are all 0. So I'm going to make this column for the hexadecimal representation of the binary digit 0. And then if we go over to the left column, that's 0, 0, 0, 0, 0. So these four are 0. And hexadecimal. Okay, so here is 1. And this is 0, 0, 1, 0, 0, 1, 0, 0, and 1, 0, 0. And as you can see, unless it's like really blurry because they compress the video that gets streamed, it should be visible because I'm zoomed in. If it's not, oh well. So you see how 0, 1 and 0, 1 here. 0, 0, 1, 0. And this matches up with right here. This matches up here. So the column of the bit, once it reaches the end, it goes to the next column. So I'll just add here where the bit's at. And then the rest of these for this column is 0. All the way down. So those columns are represented by 0 and hexadecimal. So now the next 4 bits, all the above here are 0. For this column. So I'll put a 0. And this is 0, 0, 0, 1. So you see how the pattern repeats. It's just like decimal. There's columns, there's numbers, repetition, blah, blah, blah. And then the rest of these are 0. As you can see, they're all 0. So I'll put 0 for that column. And then the last column. The last 4, the pattern repeats to this column. 1, 2, 4, 8. And then it gets set here. And all the bits above it in their column, they're all 0. So I'll set those 0. So this first column here, So this column, I don't know. So this is a byte, hexadecimal. 2 nibbles make a byte, and a nibble represents hexadecimal digit because a nibble is 4 bits. You should have called it nib decimal, like nibble decimal, instead of hexadecimal. I think they picked hexadecimal on purpose because it sounds like magic or some shit. Because calling it hexadecimal because there's 6 letters is just stupid. It's really dumb. It's the stupidest reason to call it hexadecimal. I will Google it in a second because I want to double check if that's why it's called that. So anyways, my point is I want to try to avoid saying hexadecimal. Because I'm not saying it on purpose. Some people are kind of slow. So this is a number in binary on the left. And this is a number in hexadecimal on the right. So right now I'm printing to the window. The result, whatever the number in hexadecimal. And that's more difficult to understand than binary. And hexadecimal is usually preceded with 0x, computer, whatever. So this is more difficult to read because like 0x02, you don't know what that is unless you know hexadecimal representation. So if instead of showing it like 69 or whatever, like 0x69, like I'm doing right now in here, so instead of like showing it like hexadecimal, the position of the bit, I'm gonna log it as binary like this. Because that way it's more symbolic, or it's literal, it's not symbolic. Because hexadecimal symbolizes where the bit's at, but the actual bit, to literally like see it, it's easier in binary. So if I log this whatever on the left hand side, to this window whatever, it's easier to see that like at loop 0, it should be at the first bit, then shifted 1 bit, or rotated 1 bit, rotate 2 bits, 3 bits, all the way up to 16, whatever. So I don't know. So I'm gonna like adjust this to represent binary instead. And then to represent binary, I need the ASCII chart. and I have to find 0 and 1 on the chart. So I like typed this up yesterday, so I don't have to look at it picture every time. So in the chart, whatever, I think this is the first byte in hexadecimal, and then this is the second byte, whatever. So 1 is possibly 31. So it's a letter 1, number 1, whatever. And then the number 0 is 30, I think. I don't know, I gotta double check. And then I'll print 30 or 31 if that is for representing the digit of 0 and the digit of 1 as a string. And I'll print the char code. So like represent here as 0, 1, whatever. So I don't know. I'm gonna Google hexadecimal really quick. And then for decimal or hexadecimal, whatever, I think that they might have picked 0x to represent hexadecimal. On purpose. So if I put this into the calculator, it's I don't know, it doesn't matter. Or not that number. Whatever max in is. So this is like bit 0 to 15. This is 31. This is a 32-bit number, the bottom half. So I'll just click all the bits on. Just for fun. I'm gonna like click them out of order just because I can. I'm getting there. This is such a nice calculator, and the Mac is so much better than the Windows. I think they're all set. Yeah, they're all set. I'm just stalling. So that's 0xFFFF, whatever in hexadecimal. That's base 16. This is base 10. I gotta type that up, whatever. Okay, so this number in decimal that's billion, right? I'm tired. Pretty sure it's billion. This is 4 billion something something. But the digits it takes to represent this number so I type it up here, whatever. So this is like I guess a text editor has a limit that you can zoom in. As hexadecimal, that's 1, 2, 3, 4, 8. 8. I got 8 here, whatever. 1, 2, 3, 4, 5, 6, 7, 8. See how it's 8. So now, when I type the decimal version of this number, that is how many digits? Let's see. Well, I know, I don't know, I'm just pretending that I don't know, whatever. 429. 496. Okay, so you said they take up the same amount of space when represented in letters or numbers of the alphabet or the numerical decimal system. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 characters. I want to see if this is true for 16-bit. So I'll just click 16 times because I can. So that's 16-bit. Now I'm gonna like type it in instead of click 16 times because someone might think that I don't know how to type it in, because why the hell would I click it 16 times? So I'm just gonna do that too. So clear, and instead of clicking 16, I'm gonna type it in. Ta-da! So this is a 16-bit number, decimal, 65535. So it's 4 F's in hexadecimal. 1, 2, 3, 4. And then look at that. Even at 16 bits, it takes up the same space to represent a hexadecimal number. Is that true for 8 bits? That's 255 and 0xFF. And then here, it ends up being less bits or less characters to represent the same thing. So in this case, using decimal takes up less space in decimal format. So, I don't know. I guess it's just a coincidence that when prefixed with 0x, that ends up being the same representation of decimal when it's packed whatever. Because I think 0x is stupid. They should just call it H for hexadecimal if they're going to call it hexadecimal. So I don't know. The whole 0x prefix is stupid. And it's confusing on top of everything to people learning to code. But that's, I don't know. 0x is used at the beginning. And it conveniently takes up the same amount of space for 16-bit, 32-bit, possibly 64-bit. I don't want to check. It's going to take too long to type that up. I wasted enough time already. But what I think, at operating system level, you shouldn't have to represent hexadecimal with a prefix. Because it's the year 2025. We should have a more advanced way to store numbers. So like the type of the number would be stored with the number. So you could type FFFFF, whatever it is represented as in hexadecimal, without needing a prefix, because you could type it in and then pick the format of it on a number by number, character by character, base, whatever. So I don't know. The whole prefix thing is stupid. And if they're going to make it prefix decimal or hexadecimal, they should make you prefix decimal by putting a D or something at the front of every decimal number. Or they should force you to do something like always identify a number as positive or negative to make it just as inconvenient to work with as it is with hexadecimal numbers, because it's confusing enough already with people trying to learn. It just makes it more confusing when they gotta deal with all these stupid things to like make it possible to represent different data types in ASCII characters instead of just updating the underlying data structure itself to represent multiple things, whatever. So, I don't know. I kind of like have like a for like representing the other part of hexadecimal. I need like 1 second. Dang it. I'd like. I just wanted to check something. Now they're making me validate my account. That took a lot of effort to freaking log in. So I don't know. This is how like I mapped out the character set, whatever. I think maybe you better go like 0 to 7 and put a slash on top of the number for hexadecimal and call it something different. I don't know. I don't like hexadecimal, whatever. Leave the word hex in there. It's like it's a little off. So I don't know. This would look cooler for hexadecimal representation instead of like A, B, C, D, E, F for the last 6. But that has to be like, or this would have to be like implemented at a OS level to be useful. Just, I don't know, saying. If only a new operating system would come out someday. It'd be great. Who knows? Maybe someday something new will come out. But for now, it's Windows. So much fun. So instead of like for hexadecimal representing the numbers with different letters or numbers, we're coming up with like some way to symmetrically invert the top half, because that's what I did whenever I get to 7, I think. I invert the numbers. So that zero is all zeros set whatever, then 0 with the slash is all ones, which is the same thing as what they do for hexadecimal now by doing 0 represents all zeros. But instead, F represents all ones. So I kind of like, I think this would be better. Would be better, whatever, for representing the hexadecimal. But then these would have like a dash in them. This would be kind of like negative or positive numbers. Which is also why I kind of did this way. Is so like you could represent negative and positive numbers without needing a sign. Assuming that the sign bit would identify it as positive or negative. So you got 0 to 7. Is positive, and then down here I map 8 and 9. So like that's like the positive numbers. And if you want like -1, -2, -3 as decimal even, you could use these numbers. And 7 and 9 are right here. Or 8, 9, whatever, are right here. And then that way, 0 to 15, a nibble, whatever, they map directly to the actual digits of 0 to 15 in binary. So you don't have to do the funky like add 31 or 30 to get to compute like which position that the letter is inside of ASCII encoding. So this way, like 0 to 15 is straight up 0 to 15 as binary. So, I don't know. There's like lots of cool ways to represent numbers or anything if there's a different OS. But that's not possible with the modern operating system. But one day, maybe something more modern will be coming out. But who knows? I don't know. It's impossible to tell the future. I'm not a witch. I'm pretty sure that's what a witch would say too, except they're not a witch. They probably are, but I'm actually not. Like being a witch would be the dumbest thing ever. It'd be delusional, like completely delusional. And then it's hard to tell the difference between a witch and a narcissist because witches or black magic, whatever you want to call it, it's a whole lot like narcissism. It's like they took narcissistic traits and then they apply it for like manipulation, whatever. Because whoever started that stuff is like, oh, that seems to work. I'm gonna call it dark magic or whatever the fuck you want to call it. I don't know. It's hard to tell the difference between when someone's narcissistic. I don't know, whatever. I'm going on like several different topics here. So like that's binary, hexadecimal representation, numbers, whole bunch of stuff. If you know computing, you already know the stuff. If you don't, maybe now. When you see like 0x or like binary, you kind of know a teeny bit more because it's like way more complicated if you want to just keep going. And I'm not going to keep going. So what I'm going to do now, because I got to get done with this engine. Why is this not zooming out? It'd be really cool to represent numbers without a sign. So you don't have to put positive or negative in front of it. Then it's like in the number itself. So you could do like +4 plus -4, except the number 4 would look like a -4. And you wouldn't need that extra sign. It'd be like in the number itself. That'd be really cool. And for time. Okay, I'm done. I don't know. The modern OS, it sucks ass. The modern OS sucks. And it will be replaced. So I'm gonna like cut this stuff, paste it to another file, in case I need to like make a diagram, whatever. I'm just gonna undo to make sure I didn't like click somewhere and screw something up. Because when I'm zoomed in that close, I could like grab and delete something on accident and not even know it. I'm gonna undo really quick. But basically, I'm gonna like adjust the routine right now, get it to print this bit because it's rotating the bit. So I'll get it to print and it's gonna look in binary format like I just explained in this window here. So it's gonna print in binary where the bit's at, if it's working correctly, which it should be. Where did the thing go? Here. So it's gonna print in binary right here, whatever. As it loops each iteration. And then I'm gonna use the routine to like adjust the number and I'll print the result. And after I like make sure it's working, I'll speed test it and then compare it to the other compilers. I think this is rewinded far enough. And I don't know, last thing. And I'm gonna get to like making the routine to print binary whatever. I gotta add +1 -1 to the result to get 0 or 1. So it'll print 0 or 1 in a row to the window. To this window to represent as binary. So I don't know, that's what I'm gonna do now. If I explain every step, it's gonna take forever, so I'm just gonna do whatever. Oh, and then this is like a super low resolution font or whatever. I used like the least number of pixels I could to try to keep like visually identifiable letters. It is a little bit difficult to read, whatever. But I did that on purpose. So like, if this was, hypothetically speaking, of course, used for an OS, like a new OS, that would be released, hypothetically it would support low-res screens and handle like LCDs and stuff easier if the font's condensed in the first place, and then like I would make a better looking font than this for better screens. But then the screens themselves, the liquid crystal display, lots of them have prefixed characters. You set a digit, you send it, and it'll decode it to output a number. They're not totally pixel by pixel. you send it a symbol and it puts a symbol. So like when I talk about cheap screens, I'm talking about cheap LCD screens that actually do pixels. Some of them don't do pixels, so like this font wouldn't be possible in all displays or whatever. But like I'm accounting for like the lowest common denominator. Kind of like how like I'm writing the JavaScript engine using this computer, which is a first Gen i7. It's a first Gen i7. Here, 860, whatever. Like it shows up in the docs, whatever. So when I'm optimizing the assembly here in this file, I'm doing it based off the CPU and the documentation, or this documentation. That has instruction timings for various processors. Like the Intel, however it's said. Which shows up here. So like the current JavaScript engine, it doesn't support these operations or extensions on the CPU, but I'm going to support it because I'm going to be writing in assembly. The one I'm doing right here, whatever. And it didn't highlight. Somehow, here it is. The Intel i7, first generation. It says i920. My computer is oh my god, come on, where the fuck is it? Here it is. My computer's a 860. It's not a 920. But I asked Chatbot, and it said an 860 is a dual band version of the triple band of the i920, which is a triple band memory. So like this one's triple band memory. It came out a little bit before the 860, which is dual band. But when I go into the Windows specs, it says this is a first generation i7. So I don't know. This isn't exactly the same CPU, but it's like the same exact thing. The instructions are, the memory is different. It's faster on this one. I don't know. It's basically the same thing. So I'm gonna be, when I write my JavaScript engine, I'm gonna account for Intel i7, the lowest common denominator, and then I'm gonna account for the newer CPUs. And I'm gonna be adding support for MMX, SSE, SSE2, SSE3. I don't know if AMD 3D now. I think they removed it. I don't know if they put it back. I don't know. I'm gonna support whatever. I gotta like actually test it though to see if there's a actually performance boost when using those instructions. But first I gotta just get some simple tests in assembly and eventually I get to that point. So I don't know. Instead of like designing for the current high-end CPU and top tech, the fastest stuff, and then relying on a whole bunch of like crutches, I'm gonna like write code for the most common, least common denominator, which is first Gen i7. Kind of like with the font, whatever. I'd make a font for an OS if I was making an OS. Hypothetically, I'd make a font like this for like the lowest common denominator. And then I'd like make a new font that's better looking than this. So I go like real low CPU support, then highest CPU support, low screen support, then high screen support. So I don't know. That's what I'm gonna do. I'm just doing a little bit different. Most people will support the newest thing, and then they'll say, well, that's what it is. I'm using the newest tech. If it's not fast, just wait till next year. So I'm gonna like be doing this from like the fucking bottom up, and it should just get faster and faster and faster. The code or whatever. So I'm gonna like build this again to make sure I didn't mess something up. And then so I gotta assemble it, link it, open the executable, it prints, and it prints 72 instead of 69. So I don't know, everything works still. I didn't mess it up by making notes. So I don't know, I'm gonna get some more water. And I'm gonna run this. I'm gonna print this whatever. But first I gotta get it to print binary, like I was talking about a little bit ago. So I'm gonna get back, I'm gonna get to print binary. And I'll have it print this bit that's being rotated each iteration. And I'll check the output. Here, whatever, when it runs to make sure everything looks correct. And if that all looks good, everything's printing correctly, then I'll turn this on. It's already on. It's just not printing the result. Then I'll print this result to the window. When does this block? This is the first part of the C code. The C code here, but represented as assembly, whatever. Then I'll like print this, check to make sure it works. Then I'll check the second part down here. I gotta double check it. I'll paste it up there and then run it. Make sure that part works. And then I'm gonna paste the C code into the online compiler. And it's saved my history from last time. So it's already typed up here. It shows up over here. I don't know, this is the first part, second part. So I'm gonna like type it in here. I'll get what Clang makes, whatever, in Visual Studio's in here, to whatever. So I'll like get the full assembly instruction list. And then I'll paste it into Notepad for Visual Studio, and then whatever Clang or GC makes. And then I'm going to type them up on this computer. And I'll speed test it. And I'll compare all three to figure out if mine happens to be faster than the assembler or not. Faster than the C compiler, which makes assembly. So I don't know. That's my whole point. So I'll like BRB and get started on that. So I'm gonna update this whatever, get it to print the binary value instead when it logs to this window. It logs to this window for the result here. So that's what I'm gonna do first. Then I'm gonna run it, pass in to make sure it's printing the right thing. Then I'll test the routine and stuff and compare and speed test. And then I'm gonna get back to parsing and updating the engine from 32-bit to 64-bit. I'm also gonna make this 64-bit. Burp. I don't know. This is 16-bit. I'll update this to 64-bit too and speed test it after I get all the stuff tested, whatever. And then I'm gonna get back to the JavaScript Engine, whatever, converting it to 64-bit. It'll take too long if I talk through every single thing, so I'm just gonna do whatever and talk whenever I'm done. And I'm like, I don't know, whatever. I'm gonna try to get something done.
rate a record. Return. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment element with argument iterator record. Elision. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. C return if abrupt. Next. D if next is false, set iterator record to true. Return unused. Elision. Elision. Perform. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of elision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. ECMA International 2024 289. C return if abrupt. Next. D if next is false, set iterator record to true. 3. Return unused. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then elect if B. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then elect next B. Iterator step value. Iterator record. B if next is not done, then I set a value to next. If initializer is present and value is undefined, then if is anonymous function definition, initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref B else I let default value be. Evaluation of initializer 2. Let VB. Get value. Default value else a let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of nested assignment pattern with argument V. Return. Put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be array create 0, let M 0. Repeat. While iterator record is false, elect next B. Iterator step value. Iterator record B if next is not done, then I perform. Create data property or throw A to string N next 2. Set N to N plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return. Capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A L U A T, of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics, capital K E Y E D, capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation. Capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMAScript language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let b. Evaluation of destructuring assignment target. Let VB. Jet. Value. Property name. If initializer is present and v is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target are both true, then I let RHS value be. Named evaluation of initializer with argument ref be else I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else I let RHS value be v. If destructuring assignment target is either an object literal or an array literal, then a let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of assignment pattern with argument RHS value return. Put value ref RHS value 3.16 comma operator syntax expression in yield await assignment expression in yield await expression in yield await assignment expression in yield await 1316 1 runtime semantics evaluation expression assignment expression letter fb evaluation of expression perform get value ref letter fb evaluation of assignment expression return get value ref for ECMAScript language statements and declarations syntax statement yield await return block statement yield await return variable statement yield await empty statement expression statement yield await if statement yield await return breakable statement yield await return continue statement yield await break statement yield await plus return statement yield await with statement yield await return labeled statement yield await return throw statement yield await try statement yield await return debugger statement note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291 declaration yield await hoistable declaration yield await default class declaration yield await default lexical declaration plus in yield await hoistable declaration yield await default function declaration yield await default generator declaration yield await default async function declaration yield await default async generator declaration yield await default breakable statement yield await return iteration statement yield await return switch statement yield await return 4.1 statement semantics 4.1 1 runtime semantics evaluation hoistable declaration Generator declaration, async function declaration, async generator declaration, return empty, hoistable declaration, function declaration, return. Evaluation of function declaration, breakable statement, iteration statement, switch statement, let new label set be a new empty list, return. Labeled evaluation of this breakable statement with argument new label set, 4.2 block syntax, block statement, yield, await, return, block yield await return, block, yield, await, return, statement list yield await return opt, statement list, yield, await, return, statement list item yield await return, statement list yield await return, statement list item yield await return, statement list item, yield, await, return, statement yield await return, declaration yield await. 92. ECMA International 2024. 142. 1 Static semantics. Early errors. Block. Statement list. It is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list. 4. 2. 2 Runtime semantics. Evaluation. Block. Return empty. Block. Statement list. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Statement list. Block env. Set the running execution context's lexical environment to block env. Let block value be completion. Evaluation of statement list. Set the running execution context's lexical environment to old env. Return block value. Statement list. Statement list item. Let SL be. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4. 2. 3 block declaration instantiation. Code. env, the abstract operation block declaration instantiation takes arguments code, a parse node, and env, a declarative environment record, and returns unused code is the parse node corresponding to the body of the block. Env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do a for each element Dn of the bound names of D, do ECMA International 2024 293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1 eval 1 eval 1 eval 1 var a close bracket. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create immutable binding. Dn true 2. Else perform env create mutable binding. Dn false. Note, this step is replaced in section B 3 2 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding, fn, fo. Note, this step is replaced in section B 3 2 6. Return unused 4.3 declarations in the variable statement. 4 3 1. Syntax. Lexical declaration. In yield await. Let or const binding list in yield await. Let or const binding list in yield await. Lexical binding in yield await. Binding list in yield await. Lexical binding in yield await. Lexical binding in yield await. Binding identifier yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4 3 1. 1 static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note: lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 143.1. 2 runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be. String value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else, a let RHS be. Evaluation of initializer be let value be. Get value, RHS. Perform. Initialize reference binding, LHS, value. Return empty. Lexical binding. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let value be. Get value, RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement syntax. Variable statement, yield, await. Our variable declaration list, plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note: declaration. A var statement declares variables that are scoped to the running execution contexts. Note: variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt. Binding pattern yield await. Initializer in yield await. 4, 3, 2, 1 runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration. Perform. Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding id. Else a let RHS be. Evaluation of initializer B. Let value be. Get value RHS. Perform. Put value LHS. Value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let val be. Get value RHS. Return. Binding initialization of binding pattern with arguments reval and undefined. 4. 3. 3 destructuring binding patterns syntax. Binding G pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as the property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. Await. Eligiont binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Eligiont binding rest element yield await opt. Binding rest property. Yield. Await. Dart. Binding identifier yield await. Binding property list. Yield. Await. Binding property yield await. Binding property list yield await. Binding property yield await. Binding element list. Yield. Await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element. Yield. Await. Elisionort binding element yield await. Binding property. Yield. Await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element. Yield. Await. Single name binding yield await. Binding pattern yield await. Initializer. Plus in yield await opt. Single name binding. Yield. Await. Binding identifier yield await. Initializer. Plus in yield await opt. Binding rest element. Yield. Await. Dart. Binding identifier yield await. Binding pattern yield await. 4. 3. 3. 1 runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion contain either a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be. Property binding initialization of binding property list with arguments value and environment. Let next names be. Property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let P be. Evaluation of property name. Perform. Capital K. Id binding initialization of binding element with arguments value, environment, and P. Return P. 4. 3. 3. 2 runtime semantics. REST binding initialization. The syntax-directed operation REST binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let rest obj be ordinary object create. Object prototype. Perform. Copy data properties. Rest obj. Value. Excluded names. If environment is undefined, return. Put value. LHS. Rest obj. Return. Initialize reference binding. LHS. Rest obj. 4. 3. 3. 3 runtime semantics. Key binding initialization. The syntax-directed operation key binding initialization takes arguments value, an ECMAScript language value, environment an environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding element. Binding pattern initializer opt. Let VB. Jet. Value. Property name. If initializer is present and V is undefined, then a let default value be. Evaluation of initializer. B set V2. Get value. Default value. Return. Binding initialization of binding pattern with arguments V and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. Environment. Let VB. Jet. Value. Property name. If initializer is present and V is undefined, then if is anonymous function definition. Initializer is true. Then I set V2. Named evaluation of initializer with argument binding id be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. SEMVIA2. Get value. Default value. 5. If environment is undefined, return. Put value. LHS. V. Return. Initialize reference binding. LHS. V. 4.4 Empty statement syntax. Empty statement. 4. 1 runtime semantics. Evaluation. Empty statement. 1. Return empty. 4.5 expression statement syntax. Expression statement. Yield. Await. Look ahead. Function. Async. No line terminator here. Function. Class. Let. Expression. Plus in yield await. Note an expression statement cannot start with a U plus 007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a sync function because that would make it ambiguous with an async function declaration or a async generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4. 1 runtime semantics. Evaluation. Expression statement. Expression. Let x per f be. Evaluation of expression. Return. Get value. X per f. 4.6 If statement syntax. If statement. Yield. Await. Return. If. Expression. Plus in yield await. Statement yield await return. Else. Statement yield await return. If. Expression. Plus in yield await. Statement yield await return. Look ahead else. The look ahead restriction. Look ahead else. Resolves the classic dangling else problem in the note usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299 146 1 Static semantics. Early errors. If statement. If. Expression statement else statement. It is a syntax error if is labeled function. The first statement is true. It is a syntax error if is labeled function. The second statement is true. If statement. If. Expression statement. It is a syntax error if is labeled function. Statement. Is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. 4. 6. 2 runtime semantics. Evaluation. If statement. If. Expression statement else statement. Let x per f be. Evaluation of expression. Let x per value be to boolean. Get value. X per f. If x per value is true, then a let stmt completion be completion. Evaluation of the first statement. 4. else let stmt completion be completion, evaluation of the second statement 5. Return. Update empty, stmt completion, undefined. If statement, if, expression statement, let x per f be. Evaluation of expression, let x per value be to boolean. Get value, x per f. If x per value is false, then a return undefined 4. Else, let stmt completion be completion, evaluation of statement be returned.
Apparently,
stmt completion, undefined 4.
it's treated as an error to like not initialize that in the section data, not to zero it explicitly, which I guess should be, I don't know, whatever, doesn't matter.
Use, completion, label set, the abstract.
So it had to be zeroed out. I don't need to set a value. I just want to zero it anyways, so it doesn't matter.
Performs the following step.
So now I finally got it.
Normal completion, return true if complete.
2 times 1, reserve, word, 0.
300. ECMA International 2024. 4. If label set contains completion,
Which does whatever 1 time, and that whatever it does is reserve word. I think 0 is the value. So now I can put the length here, how many times to do it. So it'll be like reserved that many times to 0. It's be this type size.
do while state
Otherwise it's typed like this normally.
statement with argument
Reserve word, and then you put like
labelment, while statement,
how many words you want to reserve.
evaluation of while statement with
So it's confusing
iteration statement
because when it's like this is like the length of how many words.
with argument label set, iteration statement, for of statement, return, for of loop evaluation of for of statement with argument label set 1 4 7.
But when it's like this,
Do while statement, yield, await,
this is the length,
return, while
and instead for this part here, instead of this being length,
1 stack
it's a value to set.
errors. Do while statement, do statement while, expression, it is a syntax.
So I finally figured it out. I don't know. It didn't take too long. It's just annoying because I have to go on the internet.
Find and be
Because on the internet, someone's like, "Oh, do this," so it worked.
time.
But when I asked chatbot,
Loop evaluation. The syntax-directed operation do while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Do
chatbot says this.
while expression let v be undefined 2. Repeat a let stmt result be completion. Evaluation of statement b if loop continues. stmt result label set is false. Return update empty stmt result v see if stmt result.
And I said, well, how do I reserve it and zero it at the same time? How do I indicate it?
Evaluation of expression. Note within the statement part of an iteration
And chatbot said this, which is clearly whatever is what it's doing,
sign
like already.
2024
And then chatbot said this,
b get value x per f if to boolean
and said use duplicate to duplicate it. That's not how dupe works in this case.
while statement syntax while statement
So it was wrong. I typed it in. It didn't work.
while expression plus and yield await statement yield await
And then it's like, just do it at runtime. It's like, no shit. But I need to do it beforehand
while
because it has to be compiled at assemble time. Because it's not a runtime issue. It's an assemble time issue where they're like checking it to make sure the syntax is correct or whatever. And I said it didn't work. using dupe, and then chatbot's like, put times after it. I don't know. Chatbot is crap. Like, it's frustrating to figure out in the first place to like just figure something out. But then when chatbot gives you like the wrong direction and it's like really close to like the right thing, but it's not, it's really annoying because it's like it sets you off in like a completely different direction with the correct data or like variables or parameters, but they're all like jumbled up. And it tells you to like put times after it instead of before it. Like it needs to be before over here. It's just annoying. I don't know. Chatbot sucks. I'm gonna like try to finish this up, whatever. LBRB. It's taking too long. I forgot to turn on Siri.
Syntax error
Have it read the documentation.
is true.
I think it's working now.
To apply this rule, if the extension specified in B3.1 is implemented 147.3 to runtime semantics, while loop evaluation, the syntax-directed operation while loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: while statement, while expression statement, let v be undefined 2. Repeat, a let x per f be. Evaluation of expression, b let x per value be. Get value, x per f, see if to boolean, x per value, is false. Return v, d let stmt result be completion. Evaluation of statement, e if loop continues. Stmt result, label set, is false. Return. Update empty, stmt result, v, f if stmt result is not empty, set v to stmt result. 4, 7. Fourth f for statement syntax. For statement, yield, await, return. 4. Look ahead let, expression, in yield await opt. 4, 7. 4, 1. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4. var variable declaration list, in yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. 4. Lexical declaration, in yield await. Expression, plus in yield await opt. Expression, plus in yield await opt. Statement yield await return. Static semantics, early errors for statement. 4. Expression not. Expression not. Expression not statement. 4. var variable declaration list. Expression not. Expression not statement. 4. Lexical declaration expression not. Expression not statement. 02. ECMA International 2024. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply this rule if the extension specified in B3.1 is implemented. For statement 4. Lexical declaration expression not. Expression not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4, 7, 4. To runtime semantics. For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. For statement 4. Expression not. Expression not. Expression not statement. If the first expression is present, then a let x per f be. Evaluation of the first expression be perform. Get value, expref. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, for, var variable declaration list, expression statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement, for, lexical declaration expression statement. Let old env be the running execution context's lexical environment. Let loop env be new declarative environment. Old env, let is const be as constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do if is const is true, then I perform loop env create immutable binding. dn true be else I perform loop env create mutable binding. dn false set the running execution context's lexical environment to loop env. Let for DCL be completion, evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to old env. B return for DCL. If this const is false, let per iteration lets be bound names. Otherwise let per iteration lets be a new empty list. 0. If the first expression is present, let test be the first expression. Otherwise, let test be empty. 1. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. 2. Let body result be completion. For body evaluation, test, increment, statement, per iteration lets, label set. 3. Set the running execution context's lexical environment to old env. 4. Return body result. Copyright sign, ECMA International 2024 303 14 7 4 3. For body evaluation, test, increment, STMT, per iteration bindings, label set. The abstract operation for body evaluation takes arguments test, an expression pars node or empty, increment, an expression pars node or empty, STMT, a statement pars node, per iteration bindings, a list of strings, and label set. A list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let v be undefined. Perform. Create per iteration environment, per iteration bindings. Repeat. If test is not empty, then I let testref be. Evaluation of test. 2. Let test value be. Get value, testref. 3. If to boolean, test value, is false, return v. B. Let result be completion, evaluation of STMT. See if loop continues. Result, label set, is false, return. Update empty, result, v. D. If result is not empty, set v to result. Perform. Create per iteration environment, per iteration bindings. F. If increment is not empty, then I let incref be. Evaluation of increment. 2. Perform. Get value, incref. 4 7 4 4. Create per iteration environment, per iteration bindings. The abstract operation create pay. Our iteration environment takes argument per iteration bindings, a list of strings, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If per iteration bindings has any elements, then a let last iteration env be the running execution context's lexical environment. B. Let outer be last iteration env. C. Assert. Outer is not null. D. Let this iteration env be new declarative environment. Outer. E. For each element bn of per iteration bindings. Do I perform this iteration env create mutable binding. Bn. False. 2. Let last value be last iteration env get binding value. Bn. True. 3. Perform this iteration env initialize binding. Bn, last value. F set the running execution context's lexical environment to this iteration env. Return unused. 04. ECMA International 2024. 147. 5. The for of, and for await of statement syntax. For in of statement, yield, await, return. 4. Look ahead let, left-hand side expression yield await, in, expression, plus in yield await, statement yield await return. 4. var for binding yield await, in expression, plus in yield await, statement yield await return. 4. For declaration yield await, in expression, plus in yield await, statement yield await return. 4. Look ahead, let, async of, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return. 4. var for binding yield await, of assignment expression, plus in yield await, statement yield await return. 4. For declaration yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, look ahead let, left-hand side expression yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, var for binding yield await, of assignment expression, plus in yield await, statement yield await return, plus await. For await, for declaration yield await, of assignment expression, plus in yield await, statement yield await return. For declaration, yield, await, let or const for binding yield await, for binding, yield, await, binding identifier yield await, binding pattern yield await. Note this section is extended by an XB 3.5, 147, 5, 1 static semantics, early errors for in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await, left-hand side expression of assignment expression statement. For await, var for binding of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if as labby led function statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. Copyright sign, ECMA International 2024 305. For in of statement. 4. Left-hand side expression in expression statement. 4. Left-hand side expression of assignment expression statement. For await, left-hand side expression of assignment expression statement. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. For in of statement. 4. For declaration in expression statement. 4. For declaration of assignment expression statement. For await, for declaration of assignment expression statement. It is a syntax error if the bound names of for declaration contains let. It is a syntax error if any element of the bound names of for declaration also occurs in the for are declared names of statement. It is a syntax error if the bound names of for declaration contains any duplicate entries. 4, 7, 5. To static semantics is destructuring. The syntax-directed operation is destructuring takes no arguments and returns a boolean. It is defined piecewise over the following productions. Member expression, primary expression. If primary expression is either an object literal or an array literal, return true, return false. Member expression, expression, member expression. Identifier name member expression template literal super property, meter property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, return false. For declaration, let or const for binding, return is destructuring of for binding. For binding, binding identifier, return false. 06 ECMA International 2024 for binding. Binding pattern 1. Return true. Note this section is extended by an XB 3.5, 4, 7, 5, 3 runtime semantics. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z. The syntax-directed operation. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, I, T, I, A, L, I, Z, takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. For declaration, let or const for binding, return. Binding initialization of for binding with arguments value and environment. 4, 7, 5, for runtime semantics. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A. The syntax-directed operation. Capital F, O, R, capital D, E, C, L, A, R, A, T, I, O, N, capital B, I, N, D, I, N, G, capital I, N, S, T, A, N, T, I, A, takes argument environment a declarative environment record, and returns unused. It is defined piecewise over the following productions. For declaration, let or const for binding. For each L, mend name of the bound names if for binding. Do A if this constant declaration of let or const is true. Then, I perform environment create immutable binding. Name. True B else, I perform environment create mutable binding. Name. False 2. Return unused. 4, 7, 5, 5 runtime semantics. For an of-loop evaluation, the syntax-directed operation for an of-loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. For an of statement, 4, left-hand side expression in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, left-hand side expression, statement, key result, enumerate, assignment, label set. For an of statement, 4, var for binding in expression statement, let key result be. For an of head evaluation, expression, enumerate, return. For an of body evaluation, for binding, statement, key result, enumerate, var binding, label set. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements in the formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 307. For an of statement, 4, for declaration in expression statement, let key result be. For an of head evaluation, bound names of for declaration, expression, enumerate, return. For an of body evaluation, for declaration, statement, key result, enumerate, lexical binding, label set. For an of statement, 4, left-hand side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set. For in of statement, for, var for binding of assignment expression statement, let key result be. For in of head evaluation, assignment expression, iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set. For in of statement, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set. For in of statement, for await, left-hand side expression of assignment expression statement, let key result be. For in of head evaluation, assignment expression, async iterate, return. For in of body evaluation, left-hand side expression, statement, key result, iterate, assignment, label set, async. For in of statement, for await, var for binding of assignment expression statement, let key result be. For in of he de-evaluation, assignment expression, async iterate, return. For in of body evaluation, for binding, statement, key result, iterate, var binding, label set, async. For in of statement, for await, for declaration of assignment expression statement, let key result be. For in of head evaluation, bound names of for declaration, assignment expression, async iterate, return. For in of body evaluation, for declaration, statement, key result, iterate, lexical binding, label set, async. Note this section is extended by an XB 3.5, 4, 7, 5, 6 for in of head evaluation, uninitialized bound names, expr, iteration kind. The abstract operation for in of head evaluation takes arguments uninitialized bound names, a list of strings, expr, an expression parse node or an assignment expression parse node, and iteration kind, enumerate, iterate, or async iterate, and returns either a normal completion containing an iterator record or an abrupt completion. It performs the following steps when called. 1. 2. Let all DNV be the running execution context's lexical environment. If uninitialized bound names is not empty, then 08. ECMA International 2024 ABC D. Assert. Uninitialized bound names has no duplicate entries. Let new env be new declarative environment. Old env for each string name of uninitialized bound names. Do I perform new env create mutable binding name false. Set the running execution context's lexical environment to new env 3. Let expref be completion evaluation of expr. Set the running execution context's lexical environment to old env. Let expr value be get value expref. If iteration kind is enumerate, then if expr value is either undefined or null, then I return completion record, break, empty, empty. B let obj be. To object, expr value. C let iterator be enumerate object properties. Obj D let next method be. Jet iterator. Next. E return the iterator record. Iterator. Next method. False. Else. A assert. Iteration kind is either iterate or async iterate. B if iteration kind is async iterate. Let iterator kind be async. C else. Let iterator kind be sync. D return. Get iterator. Expr value. Iterator kind. The abstract operation for in of body evaluation takes arguments LHS, a parse node, STMT, a statement parse node, iterator record, an iterator record, iteration kind, enumerate or iterate, LHS kind, assignment, var binding, or lexical binding, and label set, a list of strings, and optional argument iterator kind, sync or async, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If iterator kind is not present, Set iterator kind to sync. Let old env be the running execution context's lexical environment. Let v be undefined. Let destructuring be as destructuring of LHS. If destructuring is true and LHS kind is assignment, then A assert LHS is a left-hand side expression. B let assignment pattern be the assignment pattern that is covered by LHS. Repeat. A let next result be. Call. Iterator record. Iterator record. B if iterator kind is a sync. Set next result 2. Await. Next result. See if next result is not an object. Throw a type error exception. DLS done B. Iterator complete. Next result. E if done is true. Return V. F let next value be. Iterator value. Next result. G if LHS kind is either assignment or var binding. Then I if destructuring is true. Then if LHS kind is assignment. Then a let status be completion. Destructuring assignment evaluation of assignment pattern with argument next value 2. Else A assert LHS kind is var binding. B assert LHS is a for binding. C let status be completion. Binding initialization of LHS with arguments next value and undefined. 2. Else let LHS ref be completion. Evaluation of LHS. It may be evaluated repeatedly. If LHS ref is an abrupt completion, then a let status be LHS ref 3. Else a let status be completion. Put value LHS ref. Next value H else I assert LHS kind is lexical binding. 2. Assert LHS as a for declaration. 3. Let iteration env be new declarative environment. Old env I've perform capital F O R capital D E C L A R A T I O N capital B I N D I N G capital I N S T A N T I A of LHS with argument iteration en V for in of body evaluation LHS STMT iterator record iteration kind LHS kind label set iterator kind 4 7 5 7 ECMA International 2024 309 14 7 5 8 Runtime semantics evaluation V set the running execution context's lexical environment to iteration env V. If destructuring is true, then let status be completion. For declaration binding initialization of LHS with arguments next value and iteration env 7. Else assert LHS binds a single name. Let LHS name be the sole element of bound names of LHS. Let LHS ref be. Resolve binding. LHS name. Let status be completion. Initialize reference binding. LHS ref. Next value. I if status is an abrupt completion. Then I set the running execution context's lexical environment to old env 2. If iterator kind is a sync. Return. A sync iterator close. Iterator record. Status 3. If iteration kind is enumerate, then return status I've. Else assert. Iteration kind is iterate. Return. Iterator close. Iterator record. Status J let result be completion. Evaluation of STMT. K set the running execution context's lexical environment to old env. L if loop continues. Result. Label set. Is false. Then I if iteration kind is enumerate. Then 1. Return. Update empty. Result. V2. Else assert. Iteration kind is iterate. Set status to completion. Update empty. Result. V. If iterator kind is a sync. Return. A sync iterator close. Iterator record. Status. Return. Iterator close. Iterator record. Status. M if result is not empty. Set V to result. Binding identifier. Identifier. Yield await. Let binding id be string. Value of binding identifier. Return. Resolve binding. Binding id. 4 7 5 9 enumerate object properties. O. The abstract operation enumerate object properties takes argument O, an object, and returns an iterator. It performs the following steps when called. Return an iterator object, 271112, whose next method iterates over all the string-valued keys of enumerable properties of O. The iterator object is never directly accessible to ECMAScript code. The mechanics and order of enumerating the properties is not specified but must conform to the rules specified below. The iterator's throw and return methods are null and are never invoked. The iterator's next method processes object properties to determine whether the property key should be returned as an iterator value. Returned property keys do not include keys that are symbols. Properties of the target object may be deleted during enumeration. A property that is deleted before it is processed by the iterator's next method is ignored. If new properties are added to the target object during enumeration, the newly added properties are not guaranteed to be processed in the active enumeration. A property name will be returned by the iterator's next method at most once in any enumeration. Enumerating the properties of the target object includes enumerating properties of its prototype, and the prototype of the prototype, and so on, recursively. But a property of a prototype is not processed if it has the same 10 copyright sign, ECMA International 2024 name as a property that has already been processed by the iterator's next method. The values of attributes are not considered when determining if a property of a prototype object has already been processed. The enumerable property names of prototype objects must be obtained by invoking enumerate object properties passing the prototype object as the argument. Enumerate object properties must obtain the own property keys of the target object by calling its internal method. Property attributes of the target object must be obtained by calling its internal method. In addition, if neither O nor any object in its prototype chain is a proxy exotic object, typed array, module namespace exotic object, or implementation provided exotic object, then the iterator must behave as with the iterator given by create for an iterator, O until one of the following occurs: the value of the internal slot of O or an object in its prototype chain changes. A property is removed from O or an object in its prototype chain. A property is added to an object in O's prototype chain, or the value of the attribute of a property of O or an object in its prototype chain changes. Note 1. ECMAScript implementations are not required to implement the algorithm in 1.4.7.1.0.2.1 directly. They may choose any implementation whose behavior will not deviate from that algorithm unless one of the constraints in the previous paragraph is violated. The following is an informative definition of an ECMAScript generator function that conforms to these rules. Function enumerate object properties. OBJ const visited equals new set. 4. Const key of reflect own keys. OBJ if type of key equals symbol. Continue. Const desk equals reflect get own property descriptor. OBJ key if desk visited add key if desk enumerable yield key. Const proto equals reflect get prototype of OBJ if proto equals null. Return 4. Const proto key of enumerate object properties. Proto if visited has proto key yield proto key. Note to the list of exotic objects for which implementations are not required to match create for an iterator was chosen because implementations historically differed in behavior for those cases, and agreed in all the others. 4, 7, 5, 1, 0 for an iterator objects. A for an iterator is an object that represents a specific iteration over some specific object. For an iterator objects are never directly accessible to ECMAScript code. They exist solely to illustrate the behavior of enumerate object properties. ECMA International 2024 311 14 7 5 10 1 create for an iterator object. The abstract operation create for an iterator takes argument object, an object, and returns a for an iterator. It is used to create a for an iterator object which iterates over the own and inherited enumerable string properties of object in a specific order. It performs the following steps when called. Let iterator be ordinary object create. % for an iterator prototype %. Set iterator to object. Set iterator to false. Set iterator to a new empty list. Set iterator to a new empty list. Return iterator 4, 7, 5, 1, 0, to the percent for an iterator prototype percent object. The percent for an iterator prototype percent object has properties that are inherited by all for an iterator objects. Is an ordinary object. Has an internal slot whose value is percent iterator prototype percent. Is never directly accessible to ECMAScript code. Has the following properties: 4, 7, 5, 1, 0, 2. 1% for an iterator prototype percent dart. Next, let O be the this value. Assert O is an object. Assert O has all of the internal slots of a for an iterator instance. 1, 4, 7, 5, 1, 0, 3. Let object be O. Repeat. If O is false, then I let keys be object. 2. For each element key of keys, do if key is a string, then A append key to O. 3. Set O to true. B repeat. While O is not empty, I let R be the first element of O. 2. Remove the first element from O. 3. If there does not exist an element V of O such that same value, R, V, is true, then let desk be object, R. If desk is not undefined, then A append R to O. B if desk is true, return create I to result object, R. False. C set object to object. D set O to object. E set O to false. F if object is null, return create I to result object, undefined. True. 4, 7, 5, 1, 0, 3 properties of for an iterator instances. For an iterator instances are ordinary objects that inherit properties from the percent for an iterator prototype percent intrinsic object. For an iterator instances are initially created with the internal slots listed in Table 39. 12. Copyright sign, ECMA International 2024. Table 39. Internal slots of for an iterator instances. Internal slot. Type. Description. Object. An object. The object value whose properties are being iterated. Object was visited. A boolean. True if the iterator has invoked on. False otherwise. Visited keys. A list of strings. The values that have been emitted by this iterator thus far. Remaining keys. A list of strings. The values remaining to be emitted for the current object before iterating the properties of its prototype. If its prototype is not null. 14.8. The continue statement syntax. Continue statement. Yield. Await. Continue. Continue. No line terminator here. Label identifier yield await. 148. 1 static semantics. Early errors. Continue statement. Continue. Continue label identifier. It is a syntax error if this continue statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement. 148. 2 runtime semantics. Evaluation. Continue statement. Continue. Return completion record. Continue. Empty. Empty. Continue statement. Continue label identifier. Let label be the string value of label identifier. Return completion record. Continue. Empty. Label. 4.9. The break statement syntax. Break statement. Yield. Await. Break. Break. No line terminator here. Label identifier yield await. 149. 1 static semantics. Early errors. Break statement. Break. ECMA International 2024. 13. It is a syntax error if this break statement is not nested, directly or indirectly, but not crossing function or static initialization block boundaries within an iteration statement or a switch statement. 4. 9. 2 runtime semantics. Evaluation. Break statement. Break. Return completion record. Break. Empty. Empty. Break statement. Break label identifier. Let label be the string value of label identifier. Return completion record. Break. Empty. Label. 4.10. The turn statement syntax. Return statement. Yield. Await. Return. Return. No line terminator here. Expression. Plus in yield await. 4. 10. 1 runtime semantics. Eval. Uation. Return statement. Return. Return completion record. Return. Undefined. Empty. Return statement. Return expression. Let exp be. Evaluation of expression. Let exp value be. Get value. Exp. If get generator kind is a sync. Set exp value to. Await. Exp value. Return completion record. Return. Exp value. empty. A return statement causes a function to cease execution and, in most cases, returns a value to note the caller. If expression is omitted, the return value is undefined. Otherwise, the return value is the value of expression. A return statement may not actually return a value to the caller depending on surrounding context. For example, in a try block, a return statement's completion record may be replaced with another completion record during evaluation of the finally block. Legacy 4.11 Fewth statement. Note: one use of the legacy with statement is discouraged in new ECMAScript code. Consider alternatives that are permitted in both strict mode code and non-strict code, such as destructuring assignment. 14. ECMA International 2024. Syntax: with statement, yield, await, return, with expression, plus in yield await, statement yield await return. 4.11. 1 Static semantics, early errors. With statement, with expression statement. It is a syntax error if the source text matched by this production is contained in strict mode code. It is a syntax error if is labeled function, statement, is true. Note: it is only necessary to apply the second rule if the extension specified in B3.1 is implemented. 4.11. 2 Runtime semantics, evaluation. With statement, with expression statement. Let val be evaluation of expression. Let obj be to eject. Get value, val. Let old env be the running execution context's lexical environment. Let new env be new object environment. Obj, true, old env. Set the running execution context's lexical environment to new env. Let c be completion, evaluation of statement. Set the running execution context's lexical environment to old env. Return. Update empty, c, undefined. Note: 2 The with statement adds an object environment record for a computed object to the lexical environment of the running execution context. It then executes a statement using this augmented lexical environment. Finally, it restores the original lexical environment. Note: no matter how control leaves the embedded statement, whether normally or by some form of abrupt completion or exception, the lexical environment is always restored to its former state. 4.12 The switch statement syntax. Switch statement, yield, await, return, switch, expression, plus in yield await, case block yield await return. Case block, yield, await, return. Case clauses yield await return opt. Case clauses yield await return opt. Default clause yield await return. Case clauses yield or 8 return opt. Case clauses yield, await, return. Case clause yield await return. Case clauses yield await return. Case clause yield await return. ECMA International 2024 315. Case clause yield, await, return. Case expression, plus in yield await, statement list yield await return opt. Default clause yield, await, return. Default statement list yield await return opt. 4.12. 1 Static semantics, early errors. Switch statement, switch, expression, case block. It is a syntax error if the lexically declared names of case block contains any duplicate entries. It is a syntax error if any element of the lexically declared names of case block also occurs in the are declared names of case block. 4.12. 2 Runtime semantics, case block evaluation. The syntax-directed operation case block evaluation takes argument input, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Case block, return undefined. Case block, case clauses. Let v be undefined. Let be the list of case clause items in case clauses. In source text order, let found be false. For each case clause C of A, do if found is false, then I set found to. Case clause is selected, C, input B if found is true, then I let R be completion, evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty, R, V, return V. Case block, case clause assopt. Default clause case clause assopt. Let v be undefined. If the first case clause is present, Then, let A be the list of case clause items in the first case clauses. In source text order 3. Else, let A be a new empty list. Let found be false for each case clause C of A. Do if found is false. Then I set found to. Case clause is selected. C. Input B if found is true. Then I let R be completion. Evaluation of C. 2. If R is not empty, set V to R. 3. If R is an abrupt completion, return. Update empty. R. V. Let found INB be false. If the second case clause is present, then let B be the list of case clause items in the second case clauses. In source text order 8. Else let B be a new empty list 9. If found is false, then 16. ECMA International 2024. For each case clause C of B. Do I have found INB is false. Then set found INB to. Case clause is selected. C. Input 2. If found INB is true, then let R be completion. Evaluation of case clause C. If R is not empty, set V to R. If R is an abrupt completion, return. Update empty. R. V 0. If found INB is true, return V 1. Let default be completion. Evaluation of default clause 2. If defaulter is not empty, set V to defaulter 3. If defaulter is an abrupt completion, return. Update empty. Defaulter V 4. Note: the following is another complete iteration of the second case clauses. 5. For each case clause C of B, do let R be completion. Evaluation of case clause C. B if R is not empty, set V to R. C if R is an abrupt completion, return. Update empty. R. V 6. Return V 4. 1 2 3 case clause is selected. C. Input. The abstract operation case clause is selected takes argument C, a case clause path node, and input, an ECMAScript language value, and returns either a normal completion containing a boolean or an abrupt completion. It determines whether C matches input. It performs the following steps when called. Assert. C is an instance of the production case clause. Case expression. Statement list opt. Let expref be. Evaluation of the expression of C. Let clause select to be. Get value. Expref. Return is strictly equal. Input. Clause selector. 4. 1 2. For runtime semantics. Evaluation switch statement. Switch. Expression. Case block. Let expref be. Evaluation of expression. Let switch value be. Get value. Expref. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Case block. Block env. Set the running execution context's lexical environment to block env. Let R be completion. Case block evaluation of case block with argument switch value. Set the running execution context's lexical environment to old env. Return R case clause. Case expression. 1. Return empty case clause. Case expression. Statement list 1. Return. Evaluation of statement list. Note this operation does not execute C's statement list, if any. The case block algorithm uses its return value to determine which statement list to start executing. Note no matter how control leaves the switch statement, the lexical environment is always restored to its former state. ECMA International 2024 317. Default clause. Default. 1. Return empty. Default clause. Default. Statement list 1. Return. Evaluation of statement list. 4.13 Labeled statement syntax. Labeled statement. Yield. Await. Return. Label identifier yield await. Labeled item yield await return. Labeled item. Yield. Await. Return. Statement yield await return. Function declaration yield await. Default. 4. 1 3. 1 static semantics. Early errors. Labeled item. Function declaration. It is a syntax error if any source text is matched by this production. Note an alternative definition for this rule is provided in B 3.1, 1.4, 1.3, 2 static semantics is labeled function. STMT. The abstract operation is labeled function takes argument STMT, a statement parse node, and returns a boolean. It performs the following steps when called. If STMT is not a labeled statement, return false. Let item be the labeled item of STMT. If item is labeled item, function declaration, return true. Let sub STMT be the statement of item. Return is labeled funct on sub STMT. 4.1.3.3 runtime semantics. Evaluation labeled statement, label identifier, labeled item. Return. Labeled evaluation of this labeled statement with argument. Note a statement may be prefixed by a label. Labeled statements are only used in conjunction with labeled break and continue statements. ECMAScript has no goto statement. A statement can be part of a labeled statement, which itself can be part of a labeled statement, and so on. The labels introduced this way are collectively referred to as the current label set when describing the semantics of individual statements. 318. ECMA International 2024. 14.1.3. For runtime semantics. Labeled evaluation. The syntax-directed operation labeled evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Breakable statement, iteration statement. Let STMT result be completion. Loop evaluation of iteration statement with argument label set. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Breakable statement. Switch statement. Let STMT result be completion. Evaluation of switch statement. If STMT result is a break completion, then if STMT result is empty, then if STMT result is empty, set STMT result to normal completion, undefined. 2. Else. Set STMT result to normal completion. STMT result. Return STMT result. Note 1. A breakable statement is one that can be exited via an unlabeled break statement. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Let STMT result be completion. Labeled evaluation of labeled item with argument new label set. If STMT result is a break completion and STMT result is label, then A set STMT result to normal completion. STMT result 5. Return STMT result. Labeled item. Function declaration. Return. Evaluation of function declaration. Statement. Block statement. Variable statement. Empty statement. Expression statement. If statement. Continue statement. Break statement. Return statement. With statement. Throw statement. Try statement. Debugger statement. Return. Evaluation of statement. Note 2. The only two productions of statement which have special semantics for labeled evaluation are breakable statement and labeled statement. ECMA International 2024 319. 14.14 Throw statement syntax. Throw statement. Yield. Await. Throw. No line terminator here. Expression. Plus and yield await. 4.1.4. 1 runtime semantics. Evaluation. Throw statement. Throw expression. Let x per f be. Evaluation of expression. Let x per value be. Get value. X per f. Return. Throw completion. X per value. 4.15 Tree statement syntax. Try statement. Yield. Await. Return. Try block yield await return. Catch yield await return. Try block yield await return. Finally yield await return. Try block yield await return. Catch yield await return. Finally yield await return. Catch. Yield. Await. Return. Catch. Catch parameter yield await. Block yield await return. Catch block yield await return. Finally. Yield. Await. Return. Finally block yield await return. Catch parameter. Yield. Await. Binding identifier yield await. Binding pattern yield await. 4.1.5. 1 static semantics. Early errors. Catch. Catch. Catch parameter. block. It is a syntax error if bound names of catch parameter contains any duplicate elements. It is a syntax error if any element of the bound names of catch parameter also occurs in the lexically declared names of block. It is a syntax error if any element of the bound names of catch parameter also occurs in the are declared names of block. Note an alternative static semantics for this production is given in B. 3.4. Note, the try statement encloses a block of code in which an exceptional condition can occur, such as a runtime error or a throw statement. The catch clause provides the exception handling code. When a catch clause catches an exception, its catch parameter is bound to that exception. 320. ECMA International 2024. 1415. To runtime semantics. Catch clause evaluation. The syntax-directed operation catch clause evaluation takes argument thrown value, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: catch parameter, block. Let old-env be the running execution context's lexical environment. Let catch-env be new declarative environment. Old-env, for each element argname of the bound names of catch parameter. Do a perform catch-env create mutable binding, argname. False. Set the running execution context's lexical environment catch-env. Let status be completion. Binding initialization of catch parameter with arguments thrown value and catch-env. If status is an abrupt completion, then A. Set the running execution context's lexical environment to old-env. B. Return status. Let B be completion. Evaluation of block. Set the running execution context's lexical environment to old-env. Return. B. Catch block. Return. Evaluation of block. 415. 3. Runtime semantics. Evaluation. Try statement. Try block catch. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else, let C be B. Return. Update empty. C. Undefined. Try statement. Try block finally. Let B be completion. Evaluation of block. Let F be completion. Evaluation of finally. If F is a normal completion, set F to B. Return. Update empty. F. Undefined. Try statement. Try block catch finally. Let B be completion. Evaluation of block. If B is a throw completion, let C be completion. Catch clause evaluation of catch with argument B. Else, let C be B. Let F be completion. Evaluation of finally. If F is a normal completion, set F to C. Return. Update empty. F. Undefined. Note, no matter how control leaves the block, the lexical environment is always restored to its former state. ECMA International 2024 321 14.16. The debugger statement syntax. Debugger statement. Debugger. 416. 1. Runtime semantics. Evaluation. Debugger statement. Debugger. If an implementation-defined debugging facility is available and enabled, then a perform an implementation-defined debugging action. B. Return a new implementation-defined completion record. Else, A. Return empty. 5. ECMAScript language. Functions and classes. 5.1 Parameter lists syntax. Unique formal parameters. Yield. Await. Formal parameters yield await. Formal parameters. Yield. Await. Empty. Function rest parameter yield await. Formal parameter list yield await. Formal parameter list yield await. Formal parameter list yield await. Function rest parameter yield await. Formal parameter list. Yield. Await. Formal parameter yield await. Formal parameter list yield await. Formal parameter yield await. Function rest parameter. Yield. Await. Binding rest element yield await. Formal parameter. Yield. Await. Binding element yield await. 5. 1. 1 static semantics. Early errors. Unique formal parameters. Formal parameters. 22. Copyright sign. ECMA International 2024. Note: evaluating a debugger statement may allow an implementation to cause a breakpoint when run under a debugger. If a debugger is not present or active, this statement has no observable effect. Note: various ECMAScript language elements cause the creation of ECMAScript function objects. 10.2. Evaluation of such functions starts with the execution of their internal method. 102. 1. It is a syntax error if bound names of formal parameters contains any duplicate elements. Formal parameters. Formal parameter list. It is a syntax error if is simple parameter list of formal parameter list is false and bound names of formal parameter list contains any duplicate elements. 5. 1. 2. Static semantics. Contains expression. The syntax-directed operation contains expression, takes no arguments and returns a boolean. It is defined piecewise over the following productions. Object binding pattern. Binding rest property. 1. Return false. Object binding pattern. Binding property list. Binding rest property. 1. Return contains expression of binding property list. Array binding pattern. Elige not. 1. Return false. Array binding pattern. Elige not binding rest element. 1. Return contains expression of binding rest element. Array binding pattern. Binding element list. Elige not. 1. Return contains expression of binding element list. Array binding pattern. Binding element list. Elige not binding rest element. Let us be contains expression of binding element list. If his is true, return true. Return contains expression of binding rest element. Binding property list. Binding property list. Binding property. Let us be contains expression of binding property list. If his is true, return true. Return contains expression of binding property. Binding element list. Binding element list. Binding elision element. Let us be contains expression of binding element list. If his is true, return true. Return contains expression of binding elision element. Binding elision element. Elige not binding element 1. Return contains expression of binding element. Note multiple occurrences of the same binding identifier in a formal parameter list is only allowed for functions which have simple parameter lists and which are not defined in strict mode code. ECMA International 2024 323. Binding property. Property name. Binding element. Let his be is computed property key of property name. If his is true, return true. Return contains expression of binding element. Binding element. Binding pattern initializer 1. Return true. Single name binding. Binding identifier 1. Return false. Single name binding. Binding identifier initializer 1. Return true. Binding rest element. Binding identifier 1. Return false. Binding rest element. Binding pattern. Return contains expression of binding pattern. Formal parameters. Empty. 1. Return false. Formal parameters. Formal parameter list. Function rest parameter. If contains expression of formal parameter list is true, return true. Return contains expression of function rest parameter. Formal parameter list. Formal parameter list. Formal parameter. If contains expression of formal parameter list is true, return true. Return contains expression of formal parameter. Arrow parameters. Binding identifier 1. Return false. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return contains expression of formals. A sync arrow binding identifier. Binding identifier. Return false. 5. 1. 3. Static semantics. Is simple parameter list. The syntax-directed operation is simple parameter list takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element. Binding pattern. Return false 324. ECMA International 2024. Binding element. Binding pattern initializer 1. Return false. Single name binding. Binding identifier 1. Return true, single name binding, binding identifier initializer 1. Return false, formal parameters, empty, 1. Return true, formal parameters, function rest parameter 1. Return false, formal parameters, formal parameter list, function s parameter 1. Return false, formal parameter list, formal parameter list, formal parameter. If a simple parameter list of formal parameter list is false, return false. Return is simple parameter list of formal parameter, binding element. Return is simple parameter list of binding element. Arrow parameters, binding identifier. Return true, arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return is simple parameter list of formals. Async arrow binding identifier. Return true. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Member expression arguments. Let head be the async arrowhead that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Return is simple parameter list of head. 5, 1. For static semantics. Has initializer. The syntax-directed operation has initializer takes no arguments and returns a boolean. It is defined piecewise over the following productions. Binding element. Binding pattern. Return false. ECMA International 2024 325. Binding element. Binding pattern initializer 1. Return true. Single name binding. Binding identifier 1. Return false. Single name binding. Binding identifier initializer 1. Return true. Formal parameter list. Formal parameter list. Formal parameter. If his initializer of formal parameter list is true, return true. Return has initializer of formal parameter. 5, 1. 5 static semantics. Expected argument count. The syntax-directed operation expected argument count takes no arguments and returns an integer. It is defined piecewise over the following productions. Formal parameters. Empty. Function rest parameter. Return 0. Formal parameters. Formal parameter list. Function rest parameter. Return expected argument count of formal parameter list. Formal parameter list. Formal parameter. If his initializer of formal parameter is true, return 0. Return 1. Formal parameter list. Formal parameter list. Formal parameter. Let count be expected argument count of formal parameter list. If his initializer of formal parameter list is true or has initializer of formal parameter is true, return count. Return count plus 1. Arrow parameters. Binding identifier 1. Return 1. Arrow parameters. Capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Note the expected argument count of a formal parameter list is the number of formal parameters to the left of either the rest parameter or the first formal parameter with an initializer. A formal parameter without an initializer is allowed after the first parameter with an initializer, but such parameters are considered to be optional with undefined as their default value. 2. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return expected argument count of formals. 26. ECMA International 2024 Property Set Parameter List. Formal parameter. If his initializer of faux, Romal parameter is true, return 0. Return 1. A sync arrow binding identifier. Binding identifier 1. Return 1. 5.2 Function definitions syntax. Function declaration. Yield. Await. Default. Function binding identifier yield await. Formal parameters. Yield. Await. Function body. Yield. Await. Plus default. Function. Formal parameters. Yield. Await. Function body. Yield. Await. Function expression. Function binding identifier. Yield. Await opt formal parameters. Yield. Await. Function body. Yield. Await. Function body. Yield. Await. Function statement list yield await. Function statement list. Yield. Await. Statement list yield await. Plus return opt 1 5. 2. 1 static semantics. Early errors. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier opt. Formal parameters. Function body. If the source text matched by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present and the source text matched by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict if function body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of function body. It is a syntax error if formal parameters contains super property is true. It is a syntax error if function body contains super property is true. It is a syntax error if formal parameters contains supercall is true. It is a syntax error if function body contains supercall is true. Function body. Function statement list. It is a syntax error if the lexically declared names of function statement list contains any duplicate entries. Note the lexically declared names of a function body does not include identifiers bound using var or function declarations. ECMA International 2024 327. It is a syntax error if any element of the lexically declared names of function statement list also occurs in the var declared names of function statement list. It is a syntax error if contains duplicate labels of function statement list with argument is true. It is a syntax error if contains undefined break target of function statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a function statement list with arguments and is true. 5. 2 static semantics. Function body contains use strict. The syntax directed operation function body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Function body. Function statement list. If the directive prologue of function body contains a use strict directive, return TRUE. Otherwise, return false. 5. 2. 3 runtime semantics. Evaluate function body. The syntax-directed operation evaluate function body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, perform, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list, return. Evaluation of function statement list. 5, 2. For runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J. The syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J, takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: function declaration, function binding identifier, formal parameters, function body. Let name be string value of binding identifier. Let source text be the source text match by function declaration. Let f be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform cert function name. F. Name. Perform make constructor. F. Return f. Function declaration. Function. Formal parameters. Function body. Let source text be the source text match by function declaration. Let f be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Perform make constructor. F. Return f. 328. ECMA International 2024. An anonymous function declaration can only occur as part of an export default declaration. Note, and its function code is therefore always strict mode code. 152. 5 runtime semantics. Capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital E, X, P. The syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital E, X, P, takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: function expression, function, formal parameters, function body. If name is not present, Set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by function expression. Let closure be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. env. Private env. Perform set function name. Closure. Name. Perform make constructor. Closure. Return closure. Function expression. Function binding identifier. Formal parameters. Function body. Assert. Name is not present. Set name to string value of binding identifier. Let outer env be the running execution context's lexical environment. Let funky env be new declarative environment. Outer env. Perform funky env create immutable binding. Name. False. Let private env be the running execution context's private environment. Let source text be the source text matched by function expression. Let closure be ordinary function create. Function prototype source text. Formal parameters. Function body. Non-lexical this. Funcs env. Private env. Perform set function name. Closure. Name 0. Perform make constructor. Closure 1. Perform func env initialize binding. Name. Closure 2. Return closure 5. 2. 6 runtime semantics. Evaluation. Function declaration. Function binding identifier. Formal parameters. Function body. 1. Return empty. Note 1 an alternative semantics is provided in B. 3.2. Function declaration. Function. Formal parameters. Function body. 1. Return empty. Function expression. Function binding identifier. Formal parameters. Function body. 1. Return. Capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P a function expression. Note the binding identifier in a function expression can be referenced from inside the function expression's function body to allow the function to call itself recursively. However, unlike in a function declaration, the binding identifier in a function expression cannot be referenced from and does not affect the scope enclosing the function expression. Note 2 a prototype property is automatically created for every function defined using a function declaration or function expression, to allow for the possibility that the function will be used as a constructor. ECMA International 2024 329. Function statement list. Empty. 1. Return undefined. 5.3 Arrow function definitions syntax. Arrow function. In. Yield. Await. Arrow parameters yield await. No line terminator here. Equals. Concise body in. Capital C. O. V. E. R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await. Concise body, in, look ahead. Expression body in, await. Function body. Yield, await, expression body, in, await, assignment expression in, yield await, supplemental syntax. When processing an instance of the production, arrow parameters, yield, await, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await. The interpretation of capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, E D capital E X P R E S S I O N capital A N is refined using the following grammar. Arrow formal parameters yield await. Unique formal parameters yield await. 5 3 1 static semantics early errors. Arrow function arrow parameters equals concise body. It is a syntax error if arrow parameters contains yield expression is true. It is a syntax error if arrow parameters contains await expression is true. It is a syntax error if concise body contains use strict if concise body is true and is simple parameter list of arrow parameters is false. It is a syntax error if any element of the bound names of arrow parameters also occurs in the lexically declared names of concise body. Arrow parameters capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N a list capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N must cover an arrow formal parameters 1 5 3 2 static semantics. Concise body contains use strict. The syntax directed operation concise body contains use strict takes no arguments and returns a boolean. It is defined piecewise over the following productions. Concise body, expression body, return false. 30. ECMA International 2024. Arrow parameters, yield, await, binding identifier yield await. Concise body, function body, return function body contains use strict of function body. 5 3 3 runtime semantics evaluate concise body. The syntax directed operation evaluate concise body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following productions. Concise body, expression body, perform. Capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I function object arguments list return evaluation of expression body 5 3 4 runtime semantics capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S. The syntax directed operation capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions. Arrow function, arrow parameters equals concise body. If name is not present, Set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by arrow function. Let closure be ordinary function create. Percent function prototype percent. Source text. Arrow parameters. Concise body. Lexical this. env. Private env. Perform set function name. Closure. Name. Return closure. An arrow function does not define local bindings for arguments. Super. This. Or new target. Note. Any reference to arguments. Super. This. Or new target within an arrow function must resolve to a binding in a lexically enclosing environment. Typically this will be the function environment of an immediately enclosing function. Even though an arrow function may contain references to super, the function object created in step 5 is not made into a method by performing make method. An arrow function that references super is always contained within an on-arrow function, and the necessary state to implement super is accessible via the env that is captured by the function object of the arrow function. 5. 3. 5 Runtime semantics. Evaluation. Arrow function. Arrow parameters equals. Concise body. Return. Capital I, N, S, T, A, N, T, I, A, T, E, capital A, R, R, O, W, capital F, U, N, C, T, I, O, N, capital E, X, P, R, E, S, of arrow function. Expression body. Assignment expression. Let x per f be. Evaluation of assignment expression. Let x per value be. Get value, x per f. Return completion record. Return, x per value. Empty. ECMA International 2024 331. 15.4 Met. Hot definitions syntax. Method definition. Yield. Await. Class element name yield await. Unique formal parameters. Yield. Await. Function body. Yield. Await. Generator method yield await. Async method yield await. Async generator method yield await. Get class element name yield await. Function body. Yield. Await. Set class element name yield await. Property set parameter list. Function body. Yield. Await. Property set parameter list. Formal parameter. Yield. Await. 1 5 4 1 Static semantics. Early errors. Method definition. Class element name. Unique formal parameters. Function body. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of function body. Method definition. Set class element name. Property set parameter list. Function body. It is a syntax error if bound names of property set parameter list contains any duplicate elements. It is a syntax error if function body contains use strict of function body is true and is simple parameter list of property set parameter list is false. It is a syntax error if any element of the bound names of property set parameter list also occurs in the lexically declared names of function body. 5. 4. To static semantics. Has direct super. The syntax directed operation has direct super takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition. Class element name. Unique formal parameters. Function body. If unique formal parameters contains supercall is true, return true. Return function body contains supercall. Method definition. Get class element name. Function body. 1. Return function body contains supercall. Method definition. Set class element name. Property set parameter list. Function body. If property set parameter list contains supercall is true, return true. Return function body contains supercall. Generator method. Class element name. Unique formal parameters. Generator body. 2. If unique formal parameters contains supercall is true, return true. Return generator body contains supercall. 32. ECMA International 2024. Async generator method. Async class element name. Unique formal parameters. Async generator body. If unique formal parameters contains supercall is true, return true. Return async generator body contains supercall. Async method. Async class element name. Unique formal parameters. Async function body. If unique formal parameters contains supercall is true, return true. Return async function body contains supercall. 5, 4, 3 static semantics. Special method. The syntax-directed operation special method takes no arguments and returns a boolean. It is defined piecewise over the following productions. Method definition. Class element name. Unique formal parameters. Function body. 1. Return false. Method definition. Generator method. Async method. Async generator method. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Return true. 5, 4. For runtime semantics. Define method. The syntax-directed operation define method takes argument object, an object, and optional argument function prototype, an object, and returns either a normal completion containing a record with fields, an ECMAScript function object, or an abrupt completion. It is defined piecewise over the following productions. Method definition. Class element name. Unique formal parameters. Function body. Let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. If function prototype is present, then a let prototype be function prototype 5. Else, a let prototype be %function prototype %. Let source text be the source text match by method definition. Let closure be ordinary function create. Prototype. Source text. Unique formal parameters. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Return the record. Closure. ECMA International 2024 333 15 4. 5 runtime semantics. Method definition evaluation. The syntax-directed operation method definition evaluation takes arguments object, an object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It is defined piecewise over the following productions. Method definition. Class element name. Unique formal parameters. Function body. Let method f be. Define method of method definition with argument object. Perform set function name. Method def. Method def. Return. Define method property. Object. Method def. Enumerable. Method definition. Get class element name. Function body. Let proc key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text match by method definition. Let formal parameter list be an instance of the production formal parameters. Empty. Let closure be ordinary function create. %function prototype %. Source text. Formal parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Get. If prop key is a private name, then a return private element. Accessor. Undefined 10. Else, a let desk be the property descriptor. Enumerable. True be perform. Define property or throw. Object. Prop key. Desk. See return unused. Method definition. Set class element name. Property set parameter list. Function body. Let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text match by method definition. Let closure be ordinary function create. %function prototype %. Source text. Property set parameter list. Function body. Non-lexical this. env. Private env. Perform make method. Closure. Object. Perform set function name. Closure. Prop key. Set. If prop key is a private name, then a return private element. Accessor. Closure 9. Else, a let desk be the property descriptor. Enumerable. True be perform. Define property or throw, object, prop key, desk, see return unused, generate a method, class element name, unique formal parameters, generate a body, let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by generator method. Let closure be ordinary function create. Generator function prototype source text. Unique formal parameters. Generator body. Non-lexical this. env. Private env, perform make method, closure, object, perform cert function name, closure, prop key. Let prototype be ordinary object create, generator function prototype 34. ECMA International 2024. 9. Perform. Define property or throw, closure, prototype, property descriptor, prototype, true, false, 0. Return. Define method property, object, prop key, closure, enumerable, async generator method, async class element name, unique formal parameters, async generator body, let prop key be. Evaluation of class element name. Let env be the running execution context's lexical environment. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync generator method. Let closure be ordinary function create. Async generator function prototype source text. Unique formal parameters. Async generator body. Non-lexical this. env. Private env, perform make method, closure, object, perform cert function name, closure, prop key. Let prototype be ordinary object create, async generator function prototype perform. Define property or throw, closure, prototype, property descriptor, prototype, writable, true, false, 0. Return. Define method property, object, prop key, closure, enumerable, async method, async class element name, unique formal parameters, async function body, let prop key be. Evaluation of class element name. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync method. Let closure be ordinary function create. Async function prototype source text. Unique formal parameters. Async function body. Non-lexical this. env. Private env, perform make method, closure, object, perform cert function name, closure, prop key, return. Define method property, object, prop key, closure, enumerable, 5.5 generator function definition syntax, generator declaration, yield, await, default, function binding identifier yield await, formal parameters, plus yield, await, generator body, plus default, function, formal parameters, plus yield, await, generator body, generator expression, function binding identifier, plus yield, await opt formal parameters, plus yield, await, generator body, generator method, yield, await, class element name yield await, unique formal parameters, plus yield, await, generator body, function body, plus yield, await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await. ECMA International 2024 335. Note 2 yield expression cannot be used within the formal parameters of a generator function because any expressions that are part of formal parameters are evaluated before the resulting generator is in a resummable state. Note 3 abstract operations relating to
This is getting boring. I don't know. It's like define bytes and reserve bytes. It's all just annoying. I don't know. So I gotta like get to reserve, well, define bytes between these two parts. So I'm gonna put this in this random tag, whatever. So I can do Control F. I gotta put it at the end of all these now. I could make a macro for each line. I'm just gonna like write it up like this because I want to get done. I don't know. I'm trying to figure out the compiler syntax and stuff. So it's taking longer. This is so boring.
Text match by formal parameters is strict mode code. The early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present in the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict if generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of th, e-bound names of formal parameters also occurs in the lexically declared names of generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error.
I'm just gonna name it this instead of random letters, random text to mark these lines of code to control find and quickly select them all at once. Yada yada.
Semantics. Evaluate generator body. The syntax directed operation evaluate generator body takes arguments.
I am so bored of this. I almost, whatever, have it set up.
Use and returns a throw completion or a return completion. It is defined piece.
So I can like toggle between printing a hexadecimal value or binary. So I gotta like mark the rest of the lines, these lines, I can toggle it, check this, and it should work the same exact way for binary. I just picked the other option. I could have like deleted stuff and just rewrote it. I don't know. This is cleaner, so I can like keep the old mode in case I need it, or add another mode to like print a 64-bit value. So, I don't know. I'm almost ready to test crap. Taking so long.
Generator brand. Set G to empty. Perform generator start. G. Function body. Return completion record. Return. G. Empty. 36. ECMA.
And then chatbot
4. Note 1. The syntax.
is like completely unuseful.
The. Capital I. N. P.
It told me to do define bytes 100 times 0 whatever.
M. E.
And then it's like, you're right to point out the mistake. I apologize for that. I made an error, suggesting the syntax is indeed correct. It suggests that like 90% of things that it suggests are incorrect. It's just annoying. So I'm gonna try to hurry up and get done. Asking chatbot takes just as much time as Googling it. I don't know. Everything sucks.
E. G. E. N. E. R. A. T. O. R. Capital F. U. N. C. T. I. O. N. Capital O. B. The syntax directed operation. Capital I. N. S. T. A. N. T. I. A. T. E. Capital G. E. N. E. R. A. T. O. R. Capital F. U. N. C. T. I. O. N. Capital O. B. Takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: generator declaration, function binding identifier, formal parameters, generator body. Let name be string value of binding identifier. Let source text be the source text matched by generator declaration. Let f be ordinary function create. Generator function prototype. Source text. Formal parameters. Generator body.
now I can select all
Private env.
and then insert this other part. So now they're all gonna be defined to the same size or whatever for the value. I should make a macro, but that'll take even more time. So I'm just doing this or whatever. Everything's taking so long already. I don't know. I'm just gonna try to get done now.
Let source text be the source text matched by generated
And I'm pretty sure what chatbot gave me yesterday to get the time, whatever, it's probably not gonna work because chatbot probably gave me the wrong thing. So I still gotta run that. If it doesn't work, that's gonna be another hour or so of trying to figure out what does work. So I'm probably gonna have to Google it because chatbot is just useless when it comes to like programming.
prototype true, false, false. Return F 5.4 runtime semantics. Capital I N S T A N
So now all the lines are selected at once.
E capital
I delete here. And then I make this to a string defined by space, enter, tab.
N capital
This is so boring. I'm so bored.
I
And then enter.
A T E
And I might have to restart. This computer is so laggy.
E R A T O
And then paste.
N C
And then now I'm gonna tag all the lines with the same ending. So I don't have to like click through to figure out.
private name and returns an ECMAScript function
So like paste that, doesn't matter. I'll copy this, whatever.
expression function formal parameters generate a body if name is not present set name to let env be the lexical environment of the running
And then I'll paste.
let source text be the source text matched by generator expression let closure be ordinary function create percent generator function prototype percent source text formal parameters generate a body non-lexical this env
Did I mess it up?
name closure name let
I think I messed it up already. It's cool.
prototype percent perform define property or throw closure prototype property descriptor prototype writable true false false return closure generator expression function binding identifier formal parameters generate a body assert name is not present set name to string value of binding identifier let outer env be the running execution context's lexical environment let funky env be new declarative environment outer env perform funky env create immutable binding name false let private env be the running execution context's private environment let source text be the source text matched by generator expression an anonymous generator declaration can only occur as part of an export default declaration note and its function code is therefore always strict mode code ECMA International 2024 337 8 let closure be ordinary function create percent generator function prototype percent source text formal parameters generate a body non-lexical this funcs env private env perform set function name closure name 0 let prototype be ordinary object create percent generate a function prototype percent
And try that again.
throw closure prototype property descriptor prototype true false false 2 perform fun env in
Hit extra space.
5 runtime semantics evaluation generator expression function binding identifier opt formal parameters generate a body 1 return capital I N S T G E N E R A T O R capital F U N C T I.
But now I have to get rid of this prefix.
Expression, yield expression, yield return, yield undefined, yield expression, yield assignment expression. Let x the ref be. Evaluation of assignment expression. Let value be. Get value, x the ref, return, yield, value.
And I'll define it above whatever.
Expression. Let generator kind be get generator kind.
And I can set the toggle, and I think it's gonna work for binary, whatever. And then I can just adjust the loop, finish it up.
Let iterator value generator kind. Let iterator be iterator record. Let received be normal completion. Undefined. Repeat. Note the binding identifier in a generator expression can be referenced from inside the generator expression's function body to allow the generator code to call itself recursively. However, unlike in a generator declaration, the binding identifier in a generator expression cannot be referenced from and does not affect the scope enclosing the generator expression. 38. ECMA International 2024. A. B. If received as a normal completion, then I let in a result be. Call. Iterator record. Iterator record. Received 2. If generator kind is async, set in a result 2. Await. In a result 3. If in a result is not an object, throw a type error exception. I've let done be. Iterator complete. In a result v. If done is true, then return. Iterator value. In a result v. If generator kind is async, set received to completion. Async generator yield. Iterator value. In a result 7. Else. Set received to completion. Generator yield. In a result. Else if received is a throw completion, then I2 let throw be. Get method. Iterator. Throw. If throw is not undefined, then 2, 3, 5 let in a result be. Call. Throw. Iterator. Received. If generator kind is async, set in a result 2. Await. In a result. Note. Exceptions from the inner iterator throw method are propagated. Normal completions from an inner throw method are processed similarly to an inner next. If in a result is not an object, throw a type error exception. Let done be. Iterator complete. In a result 15.6 syntax. If done is true, then error return. Iterator value. In a result. If generator kind is async, set received to completion. Async generator yield. Iterator value. In a result. Else. Set received to completion. Generator yield. In a result 3. Else. Note. If iterator does not have a throw method, this throw is going to terminate the yield loop. But first we need to give iterator a chance to clean up.
Name. The name for these defines are really long. I should probably make them shorter, but it doesn't matter.
Completion. Else. Perform. Iterate.
At least I don't have to worry about naming something the same name an accident, because there's no way I could possibly end up naming something the same name with a name for a variable this long. So I don't know, whatever. This is like totally unreadable.
If return is undefined, then set value to received. If generator kind is async, then a set.
So for binary, it's 0x. I mean, hexadecimal. For binary, it's just do y. Because that's what people do.
Iterator. Received v. If generator kind is async, set in a return result 2. Await.
Copy it.
V. If in a return result is not an object, throw a type error exception 7. Let done be. Iterator complete. In a return result 8. If done is true, then set value to. Iterator value. In a return result. Return completion record. Return. Value. Empty. 9. If generator kind is async, set
Dang it. I missed one.
Torvalve innereten.
I missed 2. I also gotta update this one.
function definitions, async generator declaration, yield, await, default, async, no line terminator here, function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async, no line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async, no line terminator here, function binding identifier, plus yield, plus await opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async generator body, function body, plus yield, plus await, ECMA International 2024, 39. Note 1 yield expression and await expression cannot be used within the formal parameters of an async generator function because any expressions that are part of formal parameters are evaluated before the resulting async generator is in a resumable state. Note 2 abstract operations relating to async generators are defined in 2.7, 6, 3, 1.5, 6, 1 static semantics, early errors, async generator method, async class element name, unique formal parameters, async generator body. It is a syntax error if has direct super of async generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically
It's completely unreadable, but that doesn't matter because it works.
function by
So I'm going to build it, see if it works, and then I'm going to toggle it
body, async
to pick a binary whatever.
async generator body, async generator expression, async function binding identifier opt, formal parameters,
So this is to log it.
text match by formal parameters is strict mode code.
It's hexadecimal. Looks like it works.
Parameters are applied if binding identifier is present in the source text match by binding identifier.
And then I'll pick the other keyword.
Identifier is either eval or arguments. It is a syntax
Here, and I'll set it.
body is true and is simple parameter list of formal parameters is false.
Pick. Right now, this one's picked
Formal parameters also occurs in
for hexadecimal whatever, so now I'll pick this option to use for enum. This enum to use for binary.
it is a syntax error if formal parameters contains await expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async generator body contains super property is
Then I'll run it.
error if formal parameters contains supercall is true. It is a syntax error if async generator body contains supercall is true. 5, 6, to runtime semantics. Evaluate async generator body. The syntax-directed operation evaluate async generator body takes arguments
This is error on 614.
script function object and arguments list, a list of ECMAScript,
And there's no error.
and returns a throw complete.
I just didn't put the code there.
It is defined piecewise over the
I made it say error, so as a reminder to put code here.
form. Capital F U N C T I O N capital D
So I'll just put nothing here yet.
L A R A T I O N capital I N S T A N T I A T I function object arguments list. Let generator be ordinary create from constructor
Because I need to get the char code for
type percent.
0 and 1.
Set generator to empty. Perform async generator start. Generator. Function body. Return completion record. Return.
Which is possibly char code of
National 2024.
31 and 32. Or 30 and 31.
N S T A N T I.
Because this is a table of letters, whatever. 30, and then 0, then 31. I need some water.
E-N-E-R-A.
So like down there.
R, capital F-U-N-C-T, the syntax directed operation, capital I-N-S-T-A-N-T-I-A-T-E, capital A-S-Y-N-C, capital G-E-N-E-R-A-T-O-R, capital F-U-N-C-T, takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the...
So down here, when it's binary mode, to log binary, like the char code of A is possibly 41. I gotta check to make sure I copied this graph right.
To sync generator.
So if it was 41, if I was doing A and B, I do like 41 and then 42, the char code. So I'd set it to 41.
Let prototype be ordinary object create.
And I gotta test each bit, whatever.
Prototype % perform. Define property or throw F. Prototype. Property descriptor. Prototype.
Maybe I'll use the low register.
F. A sync generator declaration.
And maybe I'll set the high register to the value to use.
Generator body.
So like I'll move.
Be the source text matched by a sync.
It really doesn't matter.
FB ordinary function create.
It's done. I just gotta get done. I'm not speed testing this part. I'm just printing it.
Formal parameters. A sync generator body. Non-lexical this. env. Private env. Perform set function name. F. Default. Let.
So I can move to C high.
To send a sync generator function.
That's a high byte of the C register.
Perform. Define property or throw.
If I want to like print the letters A and B to the string.
Type true, false, false. Return F, 5, 6. In semantics, capital I.
So instead of this YY, it would print AB.
T, I, A, T, E.
Then we get like the char code, the hexadecimal value, which is possibly 41 for A. And then 42 for B. So I do 41 for A.
T, the syntax directed operation, capital I, N.
So I type in 0x41.
A, N, T, I, A, T, E.
And that means A.
S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U.
Because that's char code whatever for A.
Takes optional argument name, a property key or a private name, and returns an ECMA.
And then
It is defined piecewise over the following productions: a sync generator expression, a sync function, formal parameters, a sync generator body. If name is not present, set name to. Let env be the lexical environment.
I'll just use AX or DX to hold the data to set.
Bit environment.
So if DX holds value to set,
Expression. Let closure be ordinary function create. Percent a sync generator function prototype. Percent source text. Formal parameters. A sync generator body. Non-lexical this. env. Private env. Perform set function name. Closure. Name. Let prototype be ordinary object.
so like DX is the value to set whatever. This is an hexadecimal.
Perform. Define property or throw. Closure.
If I want to print this as binary, what's in DX?
Type. Writable. True. False. False. Return closure. A sync generator.
I could do,
Sync function binding identifier. Formal parameters.
if I like, don't care about preserving the value of DX.
execution context's lexical environment. Let funky env
Like if it doesn't matter if I destroy it.
env perform funky env create
Man, it's freaking laggy.
sync generated declaration
I'm not typing when I click.
export default.
Like if it doesn't matter if I save this to like another register, so it's saved somewhere in case I need it, then I can like destroy the value.
Context's private environment. Let source text be the source.
Or I could like rotate it so it doesn't get destroyed. So I'll just rotate it.
Generate a function prototype percent source text formal parameters async generate
Just rotate, carry right, carry the bit on the right. I don't remember. Alright, assuming it does.
ordinary object create percent async generate a function prototype
I could do
1 perform define property or throw closure prototype property descriptor prototype writable true false 2 perform fun
I'm just gonna destroy the value.
closure 3 return closure 5 6 5 runtime semantics evaluation async generator expression async function binding identifier opt formal parameters async generator body return capital I N S T
And do I have to do it backwards?
S Y N C capital G E N E R A T O R capital F U N C T of async generator expression 5.7 class definitions syntax class declaration yield await default class binding identifier yield question mark await class tail yield await class default class tail yield await class expression yield await
You need to be backwards. So I don't know. I'm gonna assume it needs to be backwards.
yield await class heritage yield await opt class body yield await opt class heritage yield await
So they were like rotate, carry left 1,
body yield await class
and then I'll do rotate, carry left C high. I gotta double check. I don't remember the instructions. I never really used the carry. If I shift right, CL1, then it clears the bottom bit. And then I can like rotate, carry left 1 after I rotate, carry left DX, because the carry is going to be set to the carry flag. Assuming I got double check. This might not be totally right. So like, I don't know. I'll be back and then I'll write this up for real. I need some water. So if I rotate, carry left 1, then this holds 0x41. Which is a char code for A. When I shift right, shift left, it's going to give me 0x40 because I shifted off the bottom bit. So it was this. Now it's this, but it's not 40. It's actually oh, it's 20. Zero x 20. So now the bottom bit's off. I rotate the carry bit, which is the top bit, in dx. So dx is going to be whatever it is, but it's going to carry the bit around. So if dx had like top bit set, when you rotate carry left, I think I gotta double check. That top bit will be set to the carry flag. It's still gonna rotate to keep what it had. Unless rotate carry left sets the bit. I don't remember. I gotta double check. I'm gonna do rotate carry left. Here. Does that destroy the value? Yeah, I need to double check. I'm not gonna ask chatbot though, because chatbot is be totally wrong. Then I'll end up making it to 40 if the carry bit was 0, if the carry bit was 1. That's be 41. So I don't know. Basically, it's going to print a 16-bit number. So if I do this 16 times, I gotta double check the instructions. I don't remember totally. So I might have to switch it up, whatever. But I'm gonna like take the value, I'll rotate it, carry the bit. Or do I have to like, I don't know. However I get the bit that I want at the top, I'll just grab that bit, and I'll set to the bottom of CL, and I'll shift right first to set it after, and then I'll set it to 0, 1, 0, 1, 0, 1. So the rest of the value remains the same. And I'll toggle between B, A, B, depending on whatever 1 or 0 is. So then I'll set it to 0, 1, and then I'll do 0, 1. The check or whatever. So like I'm basically just toggling the bottom bit. I'll probably just change it to shift the bit to the bottom and then XOR or something instead. Because I don't remember how the carry flags work. It's kind of like, it ends up being slower sometimes because it has to use the flags register. It ends up being a lot slower, which is why I don't use them. So I probably shouldn't even bother with rotate and carry flags. So I don't know. I'll be right back. I gotta like test this. Double check the carry flag stuff. And then I'll run it. Well, first, I can like set it to make sure like it's gonna print 16 characters instead of 2. So I'll do that, then I'll be back and figure out the routine, whatever. And then I can like test the routine that I have, the actual routine that does the operation down here. And I might have to adjust this too if the rotate doesn't work like I was assuming it would. Because I don't remember totally. Then I'll test that, whatever, and I can compare it to however fast whatever the compiler generates, the C compiler, speed test stuff, or whatever. So right now, for instance, 2 char codes, I'm gonna change the mode, whatever, and it should print 15 or 16 length, but 15 of them, whatever. Sorry, I set it to the binary mode, defined here. Turned off the error message that was here. I have this kind of set up, so I'll put it together when I get back. I'm not going to enter because it says F0. Save it again and then run it. So now it prints this, and now when I run it, it should print 16 of these. And then I can print binary. And it doesn't work. I think it works. Except the first one. I gotta adjust it, dang it. I can't tell if that's 16. Okay, that's 16. It's so blurry. I don't know how to make the text bigger. It doesn't matter. It just has to work. All I need is result. I'm gonna tweak this really quick to make it print the right thing there. And then I'll BRB and make the routine and actually test the stupid code in a time or speed test or whatever. This stuff. And now I gotta assemble it. Put like a space after the Y. I'll just have it print question marks instead. I need water. Build it. Dang it. And now it looks correct. Now I just gotta make the routine to set the question marks to 1 or 0. That's all that's left. Then I can finally test it, and then speed test it, and then get back to parsing. I also have to make it 64-bit, but that's not that much work. I'll just change the register size to 64-bit instructions and keep it the same. And then I'll see if there's a difference between 64-bit instruction timing or 16-bit instruction timing. Well, that was extremely boring. So I will BRB. I need water. So bad. Water. This is so boring. Whisper, whisper. This is a flying squirrel.
T is a syntax error if has direct super of async generator method is true. It is a syntax error if unique formal parameters contains yield expression is true. It is a syntax error if unique formal parameters contains await expression is true. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of unique formal parameters is false. It is a syntax error if any element of the bound names of unique formal parameters also occurs in the lexically declared names of async generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier, formal parameters, async generator body. If the source text match by formal parameters is strict mode code, the early error rules for unique formal parameters. Formal parameters are applied if binding identifier is present in the source text match by binding identifier is strict mode code. It is a syntax error if the string value of binding identifier is either eval or arguments. It is a syntax error if function body contains use strict of async generator body is true and is simple parameter list of formal parameters is false. It is a syntax error if any element of the bound names of formal parameters also occurs in the lexically declared names of async generator body. It is a syntax error if formal parameters contains yield expression is true. It is a syntax error if formal parameters contains await expression is true. It is a syntax error if formal parameters contains super property is true. It is a syntax error if async generator body contains super property is true. It is a syntax error if formal parameters contains supercall is true. It is a syntax error if async generator body contains supercall is true. 5, 6. To runtime semantics. Evaluate async generator body. The syntax-directed operation evaluate async generator body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a throw completion or a return completion. It is defined piecewise over the following productions: async generator body, function body, perform, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, function object, arguments list. Let generator be ordinary create from constructor, function object, %async generator function prototype %async generator context, set generator to empty, perform async generator start, generator, function body, return completion record, return, generator, empty, 40, ECMA International 2024, 156, 3 runtime semantics, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, the syntax-directed operation, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, takes arguments env, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions: async generator declaration, async function binding identifier, formal parameters, async generator body. Let name be string value of binding identifier. Let source text be the source text match by async generator declaration. Let f be ordinary function create, %async generator function prototype %, source text, formal parameters, async generator body, non-lexical this, env, private env, perform cert function name, f, Name. Let prototype be ordinary object create. %async generator function prototype %perform. Define property or throw. F. Prototype. Property descriptor. Prototype true. False. False. Return F. Async generator declaration. Async function. Formal parameters. Async generator body. Let source text be the source text match by async generator declaration. Let F be ordinary function create. %async generator function prototype source text. Formal parameters. Async generator body. Non-lexical this. env. Private env. Perform cert function name. F. Default. Let prototype be ordinary object create. %async generator function prototype %perform. Define property or throw. F. Prototype. Property descriptor. Prototype true. False. False. Return F. 5, 6. For runtime semantics. Capital I N S T A N T I A T E. Capital A S Y N C. Capital G E N E R A T O R. Capital F U N C T. The syntax directed operation. Capital I N S T A N T I A T E. Capital A S Y N C. Capital G E N E R A T O R. Capital F U N C T. Takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: async generator expression, async function, formal parameters, async generator body. If name is not present, set name to. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text match by async generator expression. Let closure be ordinary function create. %async generator function prototype source text. Formal parameters. Async generator body. Non-lexical this. env. Private env. Perform cert function name. Closure. Name. Let prototype be ordinary object create. %async generator function prototype perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. Return closure. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Assert. Name is not present. Set name to string value of binding identifier. Let outreenv be the running execution context's lexical environment. Let funkenv be new declarative environment. Outreenv. Perform funkenv create immutab. Le binding. Name. False. An anonymous async generated declaration can only occur as part of an export default. Note: declaration. ECMA International 2024 341 6. Let private env be the running execution context's private environment. Let source text be the source text match by async generator expression. Let closure be ordinary function create. %async generator function prototype source text. Formal parameters. Async generator body. Non-lexical this. Funcs env. Private env. Perform cert function name. Closure. Name 0. Let prototype be ordinary object create. %async generator function prototype %1. Perform. Define property or throw. Closure. Prototype. Property descriptor. Prototype. Writable. True. False. False. 2. Perform funkenv initialize binding. Name. Closure. 3. Return closure. 5, 6. 5 runtime semantics. Evaluation. Async generator expression. Async function binding identifier opt. Formal parameters. Async generator body. Return. Capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T of async generator expression. 5.7 Class definitions. Syntax. Class declaration. Yield. Await. Default. Class binding identifier. Yield await. Class tail. Yield await. Class default. Class tail. Yield await. Class expression. Yield. Await. Class binding identifier. Yield await op. Class tail. Yield await. Class tail. Yield. Await. Class heritage. Yield await op. Class body. Yield await opt. Class heritage. Yield. Await. Extends left-hand side expression. Yield await. Class body. Yield. Await. Class element list. Yield await. Class element list. Yield. Await. Class element. Yield await. Class element list. Yield await. Class element. Yield await. Class element. Yield. Await. Method definition. Yield await. Static method definition. Yield await. Field definition. Yield await. Static field definition. Yield await. Class static block. Note the binding identifier in an async generator expression can be referenced from inside the async generator expression's async generator body to allow the generator code to call itself recursively. However, unlike in an async generator declaration, the binding identifier in an async generator expression cannot be referenced from and does not affect the scope enclosing the async generator expression. 42. ECMA International 2024. Field definition. Yield. Await. Class element name. Yield await. Initializer. Class in yield await opt. Class element name. Yield. Await. Property name. Yield await. Private identifier. Class static block. Static. Class static block body. Class static block body. Class static block statement list. Class static block statement list. Statement list. Yield. Class await. Return op. Note a class definition is always strict mode code. 5. 7. 1 Static semantics. Early errors. Class tail. Class heritage art. Class body. It is a syntax error if class heritage is not present in the following algorithm returns true. Let constructor be a constructor method of class body. If constructor is empty, return false. Return has direct super of constructor. Class body. Class element list. It is a syntax error if prototype property name list of class element list contains more than one occurrence of constructor. It is a syntax error if private bound identifiers of class element list contains any duplicate entries, unless the name is used once for a getter and once for a setter and in no other entries, and the getter and setter are either both static or both non-static. Class element. Method definition. It is a syntax error if prop name of method definition is not constructor and has direct super of method definition is true. It is a syntax error if prop name of method definition is constructor and special method of method definition is true. Class element. Static method definition. It is a syntax error if has direct super of method definition is true. It is a syntax error if prop name of method definition is prototype. Class element. Field definition. It is a syntax error if prop name of field definition is constructor. Class element. Static field definition. It is a syntax error if prop name of field definition is either prototype or constructor. Field definition. Class element name initializer opt. It is a syntax error if initializer is present and contains arguments of initializer as true. Copyright sign. ECMA International 2024 343, it is a syntax error if initializer is present and initializer contains supercall as true. Class element name. Private identifier. It is a syntax error if string value of private identifier is constructor. Class static block body. Class static block statement list. It is a syntax error if the lexically declared names of class static block statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of class static block statement list also occurs in the var declared names of class static block statement list. It is a syntax error if contains duplicate labels of class static block statement list with argument is true. It is a syntax error if contains undefined break target of class static block statement list with argument is true. It is a syntax error if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of class static block statement list with arguments and is true. It is a syntax error if contains arguments of class static block statement list is true. It is a syntax error if class static block statement list contains supercall is true. It is a syntax error if class static block statement list contains await is true. 5, 7, 2 static semantics. Class element kind. The syntax-directed operation class element kind takes no arguments and returns constructor method, non-constructor method, or empty. It is defined piecewise over the following productions. Class element. Method definition. If prop name of method definition is constructor, return constructor method. Return non-constructor method. Class element. Static method definition. Field definition. Static field definition. Return non-constructor method. Class element. Class static block. Return non-constructor method. Class element. Return empty. 5, 7, 3 static semantics. Constructor method. The syntax-directed operation constructor method takes no arguments and returns a class element pars node or empty. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is constructor method, return class element. Return empty. Class element list. Class element list. Class element. 2. Let head be constructor method of class element list. If head is not empty, return head. 44. ECMA International 2024. 3. If class element kind of class element is constructor method, return class element. Return empty. 5, 7, 4 static semantics. Is static. The syntax-directed operation is static takes no arguments and returns a boolean. It is defined piecewise over the following productions. Class element. Method definition. Return false. Class element. Static method definition. Return true. Class element. Field definition. Return false. Class element. Static field definition. Return true. Class element. Class static block. Return true. Class element. Return false. 5, 7, 5 static semantics. Non-constructor elements. The syntax-directed operation non-constructor elements takes no arguments and returns a list of class element pars nodes. It is defined piecewise over the following productions. Class element list. Class element. If class element kind of class element is non-constructor method, then a return class element. Return a new empty list. Class element list. Class element list. Class element. Let list be non-constructor elements of class element list. If class element kind of class element is non-constructor method, then a append class element to the end of list. 3. Return list. Note early error rules ensure that there is only one method definition named constructor and that it is not an accessor property or generated definition. ECMA International 2024 345. 15, 7, 6 static semantics. Prototype property name list. The syntax-directed operation prototype property name list takes no arguments and returns a list of property keys. It is defined piecewise over the following productions. Class element list. Class element. Let prop name be prop name of class element. If prop name is empty, return a new empty list. If a static of class element is true, return a new empty list. Return prop name. Class element list. Class element list. Class element. Let list be prototype property name list of class element list. Let prop name be prop name of class element. If prop name is empty, return list. If a static of class element is true, return list. Return the list concatenation of list and prop name. 5, 7, 7 static semantics. All private identifiers valid. The syntax-directed operation all private identifiers valid takes argument names, a list of strings, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of all private identifiers valid. For each child node child of this parse node, do A if child is an instance of a non-terminal, then I if all private identifiers valid of child with argument names is false, return false 2. Return true. Member expression. Member expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of member expression with argument names. Return false. Call expression. Call expression. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of call expression with argument names. Return false. Optional chain. Private identifier. If names contains the string value of private identifier, return true. Return false. Optional chain. Optional chain. Private identifier. If names contains the string value of private identifier, then a return all private identifiers valid of optional chain with argument names. Return false. Class body. Class element list. 2. Let new names be the list concatenation of names and private bound identifiers of class body. Return all private identifiers valid of class element list with argument new names. 46. ECMA International 2024. Relational expression. Private identifier in shift expression. If names contains the string value of private identifier, then a return all private identifiers valid of shift expression with argument names. Return false. 5, 7, 8 static semantics. Private bound identifiers. The syntax-directed operation private bound identifiers takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Field definition. Class element name initializer. Return private bound identifiers of class element name. Class element name. Private identifier. Return a list whose sole element is the string value of private identifier. Class element name. Property name. Class element. Class static block. Return a new empty list. Class element list. Class element list. Class element. Let names 1 be private bound identifiers of class element list. Let names 2 be private bound identifiers of class element. Return the list concatenation of names 1 and names 2. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async method. Async class element name. Unique formal parameters. Async function body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return private bound identifiers of class element name. 5, 7, 9 static semantics. Contains arguments. The syntax-directed operation contains arguments, takes no arguments and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains arguments. For each child node child of this parse node, do A if child is instance of a non-terminal, then I if contains arguments if child is true. Return true to. Return false. ECMA International 2024 347. Identifier reference. Identifier. If the string value of identifier is arguments, return true. Return false. Function declaration. Function binding identifier. Formal parameters. Function body. Function. Formal parameters. Function body. Function expression. Function binding identifier. Formal parameters. Function body. Generator declaration. Function binding identifier. Formal parameters. Generator body. Function. Formal parameters. Generator body. Generator expression. Function binding identifier. Formal parameters. Generator body. Async generator declaration. Async function binding identifier. Formal parameters. Async generator body. Async function. Formal parameters. Async generator body. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function declaration. Async function binding identifier. Formal parameters. Async function body. Async function. Formal parameters. Async function body. Async function expression. Async function binding identifier. Formal parameters. Async function body. Return false. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Generator method. Class element name. Unique formal parameters. Generator body. Async generator method. Async class element name. Unique formal parameters. Async generator body. Async method. Async class element name. Unique formal parameters. Async function body. Return contains arguments of class element name. The 5th of July 2010 runtime semantics. Class field definition evaluation. The syntax-directed operation class field definition evaluation takes argument home object, an object, and returns either a normal completion containing a class field definition record or an abrupt completion. It is defined piecewise over the following productions. Field definition. Class element name initializer opt. 2. Let name be. Evaluation of class element name. If initializer is present, then 48. ECMA International 2024. ABCDE. Let formal parameter list be an instance of the production formal parameters. Empty. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the empty sequence of Unicode code points. Let initializer be ordinary function create. Percent function prototype percent. Source text. Formal parameter list. Init. Ializer. Non-lexical this. env. Private env. F perform make method. Initializer. Home object. G set initializer to name. Else. A let initializer be empty. Return the class field definition record. Name. Initializer. Note the function created for initializer is never directly accessible to ECMAScript code. The 5th of July 2011 runtime semantics. Capital C L A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A L. The syntax directed operation. Capital C L A S S capital S T A T I C capital B L O C K capital D E F I N I T I O N capital E V A.
Test. Is mic working? The whole try to get like an emotional reaction out of someone, so you can go like, "Why are you overreacting?" That game is a fun game. I don't know. At my time though, I'm gonna have to show a couple people how it's done, because like when someone plays that game, they don't even do it right. It's like, if you're gonna do it right. Like for real.
Percent function.
Anyways, I'm gonna get this shit done.
Class static block
I have to... Oh yeah, print a loop.
method. Body function. Home object. Return the class static block definition record. Body function. Note the function body function is never directly accessible to ECMAScript code. The 15th of July 2012 runtime semantics. Evaluate class static block body. The syntax directed operation evaluate class static.
So first, I think...
ECMAScript function object. And
Wait, what did I say it?
language value or an abrupt completion. It is defined piecewise over the following productions. Class static block body. Class static block statement list. Assert. Function object is a synthetic function created by capital C L A S S capital S T A T I C capital B L O C K capital.
Okay, so first, I'm gonna... I could just like shift value. I don't know. I'm gonna test which byte I've decided to. If I have to go like backwards or forwards.
I O N.
Because I think it's a big Indian. Like END, IAN.
I O N.
When you type up like hexadecimal, and then behind the scenes they save it as little endian or big endian, depending on the architecture.
Evaluation of class static block statement list.
So I should.
2013 runtime semantics. Class element evaluation.
I doubt there's any x86 that's big endian.
Either a normal completion containing either a class field definition,
Ask chatbot.
static block definition record, a private element, or unused, or an abrupt completion. It is defined piecewise over the following productions: class element, field definition, static field definition, return, class field definition, evaluation of field definition with argument object, class element, method definition, static method definition, return, method definition, evaluation of method definition with arguments object and false, class element, class static block, return, capital C L A S S, capital S T A T I C, capital B L O C K, capital D E F I N I T I O N.
So I guess ARM supports both.
L of class.
Because ARM tends to be used for like smaller processors, like routers and stuff or something, where it's stored, whatever.
The 5th of July 2004.
I won't bother. Maybe I should account for that.
Operation class definition evaluation takes argument
For now, I'm just gonna into the loop or whatever.
and class name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. Note: freeze of specification. Private methods and accessors are included alongside private fields in the slot of class instances. However, any given object has either all or none of the private methods and accessors defined by a given class. This feature has been designed so that implementations may choose to implement private methods and accessors using a strategy which does not require tracking each method or accessor individually. For example, an implementation could directly associate instance private methods with their corresponding private name and track, for each object, which class constructors have run with that object as their this value. Looking up an instance private method on an object then consists of checking that the class constructor which defines the method has been used to initialize the object, then returning the method associated with the private name. This differs from private fields, because field initializers can throw during class instantiation. An individual object may have some proper subset of the private fields of a given class, and so private fields must in general be tracked individually. It is defined piecewise over the following productions: class tail, class heritage art, class body opt. Let env be the lexical environment of the running execution context. Let class env be new declarative environment, env. If class binding is not undefined, then a perform class env create a mutable binding. Class binding, true. Let outer private environment be the running execution context's private environment. Let class private environment be new private environment, outer private environment. If class body is present, then a for each string dn of the private bound identifiers of class body. Do I if class private environment contains a private name pn such that pn is dn, then assert. This is only possible for getter setter pairs too. Else, let name be a new private name whose is dn. Append name to class private environment. If class heritage is not present, then a let protoparent be percent object prototype percent. B let constructor parent be percent function prototype percent. Else. 50. ECMA International 2024. A B C D E F. Set the running execution context.
So I'm gonna ask chatbot this. I'm asking it both ways. So if it says one way's right, it'll contradict it, so maybe it'll give me the correct answer.
Superclass ref b completion. Evaluate. For x86 and x86-64, the RCR does that modify the rotated value, or only rotate yet keep the bit at the right or left to the flag's reg. and then not modify the rotated value other than the rotate itself, like would RCR change the bit that is rotated into on if it was set in the flags? The RCR rotate through carry right instruction in the x86 and x86-64 assembly language modifies both the destination operand and the carry flag. Let's break down its behavior step by step to clarify what happens. The RCR instruction, RCR destination, count. This instruction rotates the bits of the destination operand to the right by the specified number of bits, count, and the bit that is shifted out of the least significant bit, LSB, is placed into the carry flag. The value of the carry flag before the rotation is then placed into the most significant bit, MSB, of the operand.
Oh, okay. I think I got it. I never used the result of the rotate. I usually just rotated it in, or I would set the flag and then rotate it in. I wouldn't use the rotated result after the rotate. But chatbot says that the bit on the other side goes into the flag. I just assumed that, well, I don't know, I didn't know at the time. There wasn't chatbot. I just Googled it. And everybody on the internet said, don't use the result after rotate because you don't know if it's garbage or not, because it sets flags after and it messes it up, which didn't really make sense. Chatbot does make more sense, so chatbot might actually be right. So I don't know. I'll try setting this up with the rotate, carry, whatever, instead of just shifting and masking. But that makes sense because in the documentation, whatever, for the rotate, carry, yeah, the rotate, whatever, the roll or rotate right, it's 1 1 1, so it's ones across, or UOPS, throughput, whatever the things are. But then for a rotate carry, it's 2 2 2. It's probably because it modifies the flags, but also modifies register, but has a pull, so it's 2 right operations. I don't know why they wouldn't optimize that somehow to make it 1. Because it seems maybe because, I don't know, on modern CPUs, they're use the flags register only for jumps. And that's all they modified, or optimized. I don't think they optimized the rotate carry. I'll check the K7 CPU, see if that's 2 2 2. Or if it's slower than that, maybe. So I don't know. That explains why it's probably takes 2 UOPs to complete. Because it like it sets and also carries and then sets. And that makes more sense that it would set the flag on the other side to the carry flag in the flags register. Because I used to think, well, I don't know. Everyone said it's not reliable what's in the flags after certain instructions. I don't know. It's all complicated. I was just doing assembly for fun. This is like for competition. So now I gotta like actually figure it out. So the K7, whatever, I have a. I think this is. I don't know if this is. The square K7 or the slot. I think there's like a square version of the K7. I overclocked the K7, whatever, the slot cartridge one, to like just under 2 gigahertz. And the motherboard, like, it popped, and, like, pfft, and then a bunch of like transistors popped on it. So, like, that was way too high. I still have to fix that. Okay, so I have the K7 slot A. So like 1999, and then they made the slot version of it, or the socket, where it goes in the socket. So this table doesn't relate to CPU I have. It relates to the one after it, which is like probably completely different. I got like a 900 megahertz of these for this table, but I guess it's not the same CPU. I think the table's talking about the CPU. This looks a whole lot like the CPU they put in the PS4. This is like, I don't know. Look at this.
Early Athlon K7 slotter processors had clock speeds between 500 MHz and 1 GHz, higher than the Jaguar's 1.6 GHz but less efficient and designed for different tasks.
Is that true? Is it true that a 1999 CPU had higher clock speeds than the PS4 Jaguar? I think it might be true. The Pentium CPU is garbage. Wait, really? I think chatbot is mixing stuff up. This is saying that the K7 is faster, right?
Early Athlon K7 slotter processors had clock speeds between 500 MHz and 1 GHz, higher than the Jaguar's 1.6 GHz but less efficient and designed for different tasks.
It seems to be worded like the older one is faster. That's what it sounds like. So I don't know. I'm gonna ask you this and I'm done asking questions. Chatbot.
Explain this. Early Athlon K7 slotter processors had clock speeds between 500 MHz and 1 GHz, higher than the Jaguar's 1.6 GHz but less efficient and designed for different tasks, which was faster. Apologies for the confusion in that statement. Let's clear things up.
Man, chatbot sucks. You literally can't believe anything chatbot says. I was just asking curiosity. And chatbot's like, not even giving accurate info.
The clock speed alone doesn't determine overall performance, and I made a mistake in how I presented that comparison. Here's a clearer breakdown.
And now chatbot is walking it back to reword what it said. It's like, oh, it's stupid.
Clock speed versus overall performance 1. Clock speed. The early Athlon K7 slotter processors had clock speeds between 500 MHz and 1 GHz. This means that the highest clock speed in the Athlon K7 slotter series was 1 GHz. The PS4 Jaguar CPU runs at a clock speed of 1.6 GHz.
I don't know if there's a 1 gigahertz slot A. I could only find 900 megahertz, like really close to 1 gigahertz. And you can overclock it to just under 2 gigahertz. But the motherboard, it can't take it.
At first glance, the Jaguar's 1.6 GHz clock speed seems higher than the Athlon's 1 GHz. But clock speed alone isn't the full measure of performance. Several other factors contribute to how fast a CPU performs.
When you overclock the K7 slot A, holy shit, it is fast. It can render, I don't know. You can render in Movie Maker, and it's like real-time rendering. It's just so fast.
Efficiency and design. The Jaguar CPU in the PS4 is a multi-core processor with 8 cores, 4 modules with 2 threads per module. This design is optimized for multi-threaded applications, especially in gaming and real-time processing, which takes full advantage of parallelism.
I like real-time processing. If it does real-time processing, why don't programs have real-time priority? Because nothing is done in real time anymore.
The Athlon K7 slotting was single-core with clock speeds up to 1 GHz. It was a high-performance CPU for its time, but it didn't have the multi-core architecture that modern processors like Jaguar do. Which CPU is faster? The Jaguar PS4 CPU is faster in overall performance, especially in tasks that require multi-threading and parallel processing, which is common in modern gaming in general. The Athlon K7 slotter processor, while faster in raw single-thread performance at the same clock speed, would struggle in tasks that demand multi-core or multi-threaded execution like modern gaming, because it was single-core.
How does it say this? It says the clock speed is 1.6. 1.6 is lower than 1.4. That doesn't make sense, right? Because 1.6 is higher than 1.4. Right? I don't know. Chatbot is making no sense.
What was the front bus speed on the PS4 compared to the FSB speed that the K7 could handle?
Chatbot is mixing up all of these numbers. It is like completely wrong at this point. I'm asking it, how is this true? Because it said this is true.
How is this true? While the clock speed of 1.6 GHz is lower than the Athlen's 1 GHz to 1.4 GHz range. You're absolutely right to question that statement. That was an incorrect comparison, and I apologize for the confusion. Let me clarify it properly. What I should have said, the PS4's 1.6 GHz clock speed is higher than the Athlon K7's maximum 1 GHz clock speed. Therefore, the Jaguar CPU in the PS4 is running at a higher frequency than the Athlon K7.
Chatbot is so confusing. It says it's wrong, and it says it's wrong about being wrong, and it says I'm sorry about being wrong, about being wrong, about being wrong. It's just overall wrong. Okay, knowing that chatbot is probably wrong, I'm gonna ask it if these two CPUs have the same instruction timing. It's probably gonna be wrong. I'll just ask it anyways.
Do the AMD Athlon K7, Step 2, Revision A5, Socket and Early Athlon K7, Pre-Step 2, Slaughter have the same instruction timings? The AMD Athlon K7, Step 2, Revision A5, in socket and the Early Athlon K7, Pre-Step 2, In Slaughter do share much of the same instruction set architecture, since both are part of the Athlon K7 family. But there are some differences between the two in terms of performance, stability, and architecture that could affect instruction timings indirectly. Let's break it down. Slaughter processors, pre-step 2, were the first generation and were generally less optimized than later revisions. They were more prone to instability, had lower overclocking potential, and had less efficient power management.
Okay, so I think chatbot generally just says the newer one is faster. So I don't know. The timings in this table probably don't match the other CPU, but this is an old CPU. So I'm gonna like check the rotate instructions. That's my whole point. I just got distracted. That's odd. That's really weird. So the K7, the rotate, left, right, a timing of 1 1, 1/3, ALU so could do. It can handle 3 at a time, possibly. The rotate carry with the register, and then 1 is 1 1 1 1, 1/3. Hold on, wait a second. Oh, rotate carry left with the values 9 and 7. So it's more expensive to rotate carry left by 2, possibly UOPs. I don't know, because they use different categories or headers for the categories. So this is ops, not UOPs, whatever. So why the hell is this 1999 CPU, 2000 CPU? Why the hell can it do a rotate left, a rotate right, in a time of 1 1 and handle up to 1 and handle up to 3 at a time on the ALU? That's probably why his computer or CPU was so fast. That's reciprocal throughput. Let's chatbot to double check. I'm gonna spell stuff wrong. I really don't care.
Reciprocal throughput on CPU instruction table timings is 1/3 a good value. In CPU instruction timing, the term reciprocal throughput refers to the number of cycles per instruction CPI for a particular instruction or set of instructions. Essentially, it tells you how many CPU cycles it takes to execute one instruction. When you see a value like 1/3 in terms of reciprocal throughput, it means that the instruction takes one cycle every 3 instructions on average, or each instruction completes in 3 CPU cycles. This is a way to represent the efficiency or speed of an instruction on the processor.
Well, that's confusing. Because what's the point in having reciprocal throughput if it still takes 3 to complete?
In relation to the ops if it is 1.
Why can't they just put the time it takes? Why do they gotta split it up in a table across two values?
In the context of CPU instruction throughput, when the reciprocal throughput, or CPI, cycles per instruction is 1, it typically means that each operation, ops, or instruction takes 1 cycle to execute, or, put another way, 1 operation per cycle. Let's break this down in terms of the relationship between operations, ops, and reciprocal throughput, CPI. On an out-of-order CPU would 1/3 reciprocal throughput mean that if there are 3 different uses of that instruction, they would complete at the same time, by 3 cycles? Great question. Let's break down what 1/3 reciprocal throughput means on an out-of-order CPU and how it might affect the execution of instructions. Reciprocal throughput of 1/3 explained in the context of a CPU's instruction pipeline. Reciprocal throughput of 1/3 means that the CPU completes 1 instruction every 3 cycles, or alternatively, that each instruction takes 3 cycles to execute. This is the cycle time it takes to execute a particular instruction. It suggests that the CPU is not completing the instruction in 1 cycle but rather spans the execution across 3 cycles for that particular instruction. Out-of-order execution. Out-of-order execution allows the CPU to execute multiple instructions at once, but not necessarily in the order they were received, which helps keep the CPU busy and optimize throughput. Here's how this would impact your question. Scenario: Let's say you have 3 different instances of an instruction that has a 1-stroke 3 reciprocal throughput on an out-of-order CPU. Here's how it would work.
Anything chatbot says could be totally wrong, so I shouldn't be asking chatbot for advice.
Instruction 1 enters the pipeline at cycle 1.2. Since the instruction takes 3 cycles, because of the 1-stroke 3 reciprocal throughput, instruction 1 will complete at cycle 3.3. Instruction 2 enters the pipeline while instruction 1 is still being processed. It doesn't have to wait for instruction 1 to finish. Instead, the CPU might start executing instruction 2 in an available execution unit or part of the pipeline at cycle 2. Similarly, instruction 3 can enter the pipeline as soon as there's room, perhaps at cycle 3, and while instruction 1 is still executing, instruction 2 might complete at cycle 4, and instruction 3 at cycle 5.
Okay, that's how I was like thinking about it. So like it says like 1 out of 3. So I was thinking, well, if you pack up 3 of them, it takes 3 cycles to like execute them or whatever, which ends up being 3, 4, 5 cycles. Or is that 6 cycles? I don't know. But if you load up the pipeline or the out of order execution, whatever, with like 3 of them, whatever, in relation to like saturating the pipeline, that's like how many, it doesn't matter. I was thinking of it in that case, whatever, like how many it can pack until it becomes slower based on how many can complete within that many.
Key points to consider: parallel execution. An out-of-order CPU doesn't necessarily execute all 3 instances of the instruction in a strict sequential manner. Instead, it can execute the instructions out of order, meaning multiple instructions can be in flight simultaneously in the CPU, but they might be at different stages of completion.
It's like they don't complete it at the same time, but the time it takes, you can at least pack more in and know that at worst case, it'll take that long for the first one and a little bit longer for the last one ever. Which is like, I don't know. So if you put like 3 of them, you're pretty much totally locking up more instructions because they're all going to take at least 3 to complete. I guess that's a better way to think about it. Rather than try to like load up 3 of them, knowing it's going to slow it down, but then get other instructions ready to have less delay or cycles, whatever, to complete.
In practice, this means that if you have 3 instances of an instruction with 1-stroke 3 reciprocal throughput, they may complete within 3 cycles of one another, but not exactly at the same time unless the CPU is specifically designed to handle that level of parallelism and all the resources are available.
Well, that's not even out of order if it still takes 3 cycles for each. I don't know. That's confusing. Everything is based on context. So the roll and the rotate are 1 1, 1/3. Even for the carry here, carry it's 1 1, 1/3. So I'm gonna check the i7 whatever, and I'm gonna like type this up because I'm done being distracted. It takes so long to scroll down. For the i7 whatever, rotate right, rotate left is 1 1 1, 1 1. So that's fast. But then the carry is rotate by 1 2 2 2 2 2. So I think that they intentionally designed it or it's designed somehow between the two because it looks like the rotate with immediate is a timing of 3 and 2 and 1. Oh, there's more table. There's more rows or columns. I don't know. I don't know why they didn't design the i7 to make the carry quicker. Because it's rotate carry 1. It's like 2's across. But then the roll without the carry is 1's. And on the K7, it was 1 1, 1/3. So I'll check. So I don't know. We optimize the code. It depends entirely on the CPU. This table is different for all of them. So it says throughput. What is fused domain? Oh, it's more complicated. All right, I'm done looking at this. That's probably though why it's listed as 0.33 instead of like 1/3, because it's easier to understand that it's slower than 1, because when you type 1/3 like on the other one, the K7, like this says 0.33, 0.33. I think it was for the same thing, reciprocal throughput. So they got 0.33, but the K7, they're using decimals for the K7, for the AMD. They're using decimals for this Intel, this documentation. So reciprocal throughput on the K7, they're using here. So in the case 7, they're doing 1 out of 3 instead of putting 0.33. It says 1 out of 3. So the decimal place 0.33 is easier to understand. Because it's confusing when it's, I don't know, whatever. Okay, so that was I wasted so much time. But now I know the rotate instruction. So I'm gonna put that in place now. It's a little bit too distracting. I looked up too much crap. So based on what chatbot said, whatever. I don't know. Siri keeps not reading. Like when I start like opening more tabs in the browser. The text to speech just stops reading. I'll just leave it off for now. So I'm gonna set DX to like 1111. So I gotta check if 41 is a char code for A. That's all I'm gonna do. I'm not gonna go down a rabbit hole looking up random stuff. This time, I'm gonna stay on track. I'm gonna look up one thing and not go down a rabbit hole of random things like I just did however long ago. That took way too long. Totally off track. I'm gonna go to Google instead of chatbot. Because if chatbot gives me the wrong answer, I will end up arguing with chatbot, and I'm gonna waste time, and I'm gonna get even more distracted. Okay, it's a good thing I didn't. Chatbot. It says 0x41 is the value A. I have to stop asking chatbot anything. I get so off track. Okay, so my chart, whatever, is right then, I think. I think I copied it right. So like this is 4 and 1. So this is the low byte, and this is the second byte. So it's A, and then 42 is B. So if dx holds a value to print, I'm not going to bother to preserve the value. It's ended up getting destroyed if I rotate that. Unless I rotate left and rotate right, then rotate left, then rotate right, I could like pass a bit back to the thing that it came from, possibly. I'm not going to think about that. Instead, I'm just going to print the value. So I'm moving to dx, the value to print. Should I just use a loop? I'm going to make a loop. So I don't have to type it up 16 times. Because typing it up 16 times is lazy, but it's not lazy because 16 is kind of like a lot of times to type it up. And they're using a dot, or chatbot made this last time. Or I grabbed whatever from what chatbot made, I guess. It was a dot. I don't remember if that means that the label's local to like some region or something. I gotta look up what that means again. It means something with a label. Because I don't know, whatever. So I'm moving to RCX 16. And then here, I'll decrement RCX. And I'll jump until RCX is 0. Alright, so I'm going to set C high, the high part of the C register, to char code for A. If I rotate, carry right, CL, but first I have to instead I'll just use CL. So I'll rotate K right, CL. To go from 0x for 0, jar code for A, to 0x to 0. Then I'll rotate, carry left. Now I'll rotate K right, the DX register. So that way I carry in the DX what was pushed out from CL. And then now what's in the carry flag is the bottom bit of whatever DX is. So I'll call it question mark, I guess. So I'll call this A. This will be B. This is 4. I'll just type in a binary. So if A is at the bottom, A is not a binary number. I'm calling it A to like identify that it's the bit that belongs to CL. Alright, I'm not gonna play games if I like shuffle it back and forth. If I put X here, whatever, I think I'd have to like move C high, D high, then rotate left, rotate carry left, C high, and then that would set the carry pin to DX, what was carried, because I set C high to D high so I don't destroy DX. So I would like save, if I call this B, that means when it does this rotate carry, it would be at the top of CL, and then the carry register would be holding A, which means that my rotate carry right with DX. Wait, I'm using CL for the count down, dang it. Okay, so basically, I think I'd have to like save beforehand, whatever. I'd be able to like preserve both registers so they don't get destroyed. But that doesn't matter, so I'll just shift and destroy the register because it just needs to print. And then saving the value of both registers is just gonna make it slower. So DX holds the print value, C high holds the char code. I'll set CL to 16. That way it can be used for the count and to hold the char code. This is really bad assembly. I don't care though. I'm just gonna write this, get it done. So I shift right, C high 1. I'm not gonna make notes. I'm gonna rotate key right, DX. Because I want to carry what's at the bottom of it to print the binary number. I have to shift it to the left though. So I'll check if it's backwards or forwards. And then I gotta rotate carry left. The C high register. That's the upper part. The CX register. It's 16-bit. and then the C high, a CL register. So like CL is a low, 8 bits, and C high is 8 bits above it. So when accessed as C high or CL, it's 2 different 8-bit. But when accessed as CX, it treats it as a 16-bit. So I'm just splitting it up. And I think this is like the slowest assembly. Because they highly discourage, by they I mean Intel, people on the internet, they're like, don't ever break up the CX register because it'll slow things down. And I think it does. That doesn't matter though, I just gotta print it. So I rotate carry right, DX1. I rotate carry left, C high 1. So now I'm rotating the bit that was shifted out of DX into, or rotated out of, into C high. Which means that the bit in C high the top bit is going to hold 0 because I shifted. So I'm not going to bother to preserve the value. I think that's literally all it needs to do. And RBX, it's at the, it needs to be incremented each iteration. I'll just replace C high with nothing. Am I using the A register? I'm not. So I'll just use A register, the A register to hold what needs to be set. And B is being used as like the base headrest, I don't know. So I'll replace this with AL. And I'm using 64 registers, only 1 byte of them. Well, 16 for D. I don't know. Very, very simple loop. Overly explained. That's why I should not talk. I just do it. So I'm gonna stop talking as much when I do the rest of this. So I gotta like increment though this too. So it's gonna print to like here, then here, and here, 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 as it increments. And then I'll build it. Builds. And then run it. I think it has an issue. Well, that's weird. Oh. I'm incrementing RBX. And as it does the 16 loops, it's destroying it. Oh no, I'm not even computing it. That's why. So it's probably writing to 0. Unless I didn't 0 it up. Okay, whatever. It was just throwing an exception silently. I thought it would like throw an error, like a memory or a segment fault, which would have been more useful than like the program just not popping up. Alright, so now RBX will actually hold the address that needs to be set. Because entering down here, I didn't even set it because I forgot to copy it from the other part, of the loop. And it doesn't matter if it's incremented because it's going to reset anyways. Each iteration up here, whatever. No, here. Right here. So now it should work. Okay, so it looks like A is followed by add symbol, or add symbols before A. I gotta add one more to it. The value. I'll just print 0, 1 instead. Oh, it's because A is 41. So when I shift off the bit, B is 0. I thought A was 1 and B was. I have to add 1 instead of shift. So like 0 and 1 though, it lines up so I can do the shift or the key or whatever instead. So it's only because it's even and odd 0 and 1 that I can do it like this. Otherwise I'd have to add 0 or add 1. I don't know, whatever. So instead I'm gonna set 30, 0x30 instead of 41. So this is jar code for 0, unless I messed up the table. I think I copied it right, because it's 30 here. So the jar code for 31, which one is here, is 31. So when I shift off the bottom bit and I rotate in the bit, it's going to be setting that top bottom bit, toggling it on and off. So it'll pick between 0 and 1. This should work. But I think it's backwards too. Alright, so now I think it's working. Except that it's backwards. So I did have to flip it. So it's printed big Indian in the program, but when I run it, the addresses are little Indian. So from the base address, it has to be set backwards. So I could add the base address and then subtract inside the loop instead. Or I can just do rotate carry right. I'll just try that. Well, that's not correct. Oh, I did the wrong one. I meant to do dx. There it is. Now it's correct order. This is so not exciting. Alright, so now I'm going to put it back to what it was. Because there's more than one way to skin a cat. That's such a creepy saying. Who says skin a cat? So since there's more than one way to skin a cat, I'm not going to say that anymore because it's creepy. I'm going to like put this back to rotate right. And it's backwards because if I put F here at the bottom, that means that this number here should print like this, or like how you would expect it to print. Because technically, both ways are correct depending on context. Context. So when I print this with the F instead of the 1, it should look like this in the window. So when I run it, it's backwards. See how the 1s are at the end? They should be to the right side. So I flip it by rotating carry left. See how it's the correct way now? The 1s are on the bottom. And it's 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0. Or I can leave it how it was with rotate carry right. And instead, I could change the index and add to RBX. It'd probably be better to use Lee. What is it? RBX plus wherever I defined the length. Which is here, 16. I gotta multiply it by 60. Man, this zoom tool sucks. The magnifier tool. And I change this to decrement. Except I think I have to put it in front. Because I added the length, which is base 1, which means it's 1 above the actual indice. The other way, it was at the index itself, so it didn't have to be adjusted beforehand. Or I could like subtract 1 from this result, so I don't have to put it on top. I'll just put it on top. And then ta-da, that's the correct way. Which may not be obvious, because if I like switch it to like rotate carry left, this computer's so laggy. So when I switch it to rotate carry left, whatever, and now things will be backwards again. So now it's backwards again with the ones on the left, zeros on the right. Or the zeros with the 1, because it's 1. So I don't know. There's a gazillion different ways. Nobody should be skinning cats. But I guess there's a bunch of ways to do it. So like, there's a ton of different ways to do assembly. So now that this finally works, to print it, whatever, I will pass in this one, okay, so I don't know, I have notes, I guess. R13, I'm using it to pass in the value for now, whatever my note says. So R13, I set it to 1, and I rotate right just because I can. I could set it to 8. Instead, be funky, or do something funky. I'm gonna set it to 0. I'll just XOR the whole register. Or not. That's too wide. There's so many different ways to do something that nothing matters. Unless it's the fastest way, which is what I'm going to speed test, hopefully, in a couple minutes. Because I don't know, I think I almost have everything set up. It's printing. I wasted time Googling stuff. So I think I'm almost ready to like speed test it now. So I'm going to XOR R13W, which is a word. So it's a 16-bit. Which makes it all zeros, because it's 0. That's what XOR does. It cancels itself out. I'm going to increment the register to set it to 1. So now it's going to be 1, so it's 0 to 1. It's incremented. And then I'm going to rotate right 1. So it increments to 1. I rotate right 1. Which means that the whole number shifts 1. It gets clipped off the bottom. It pops back up on the top because it rotated. So if I rotate it again, this gets popped off the bottom. I'll just wait. So if I rotate another time, it rotates, this gets clipped, cut off the bottom, put on the top, it goes there. So I rotated 1 to get the bit to the top. Because I want to enter the loop, I'm going to rotate at the top of the loop. That way it's set up. When it's like this, it's set up so when it enters, it'll be rotated. And instead of being in this state, this for like the rest of the loop, like the body of the loop, it won't be this since it rotates left on entry, and I set it beforehand to be like this, so when it loops, it's going to rotate left, which gets rid of this bit and puts it on the bottom. So it cuts it, puts it on the bottom, so now it's back to 1. I don't know, I'm explaining this like very, very low level. Because, I don't know, I can't. It doesn't matter. Someone might understand it if they don't. Because lots of times people just rush through. So I don't know. I'm trying to like explain it. So if I rotate on the next entry, alright, so this is what it looks like. First entry, next entry. Next entry is to rotate again. So it goes to the left. Gets cut off. Put to the top. So now it's this. So the next entry, it gets cut off. Put it at the top, or the bottom, technically. Next entry. It gets shifted to the left, cut off, put to the bottom. So each entry is going to shift it to the left 1 bit. So I'm using this register for the whole loop or whatever. I don't have to, normally you have to like load, store, because you're like, there's not many registers. But x86 64 has these extra ones, 8, 9, 10 to 15. So it's like, I don't know, it's a lot easier to keep things in registers, even though they're fake and they're memory bound and they're banked to a register bank in a file, but that doesn't matter because it's all in context or based on context, but that itself depends on context. So it's going to loop through each time, rotate this register that I'm using purely for only rotating this bit. This is like very, very simple. None of this is complicated yet. I'm gonna like explain the simple stuff. I'm not gonna explain, or I'll try to explain the complicated stuff, but at that point, even if you know what I'm saying, you understand it, people that know, they won't need me to describe it, and people that don't know, there's no point in describing it, because if you don't know, unless you want to know. So if you want to know, and you figure it out, or understand the other stuff, you would be able to figure it out eventually. But people who don't want to know, but have some kind of understanding, some of them won't get it anyways. So I'll like explain the super simple stuff, and then explain the more complicated stuff less, I guess. So I'm not doing this yet. Do this right after. So the registers A, B, C, D, they're going to be destroyed every time it enters, at least for this loop. The speed test loop, I'm going to have to like not print it because it's going to slow it down. And I'll have to like offload values to stack and stuff. So like I'll print it to make sure it works, but I'll make a separate loop after I know it's working to actually do the speed test. So I can like make a macro and call it. So we'll do the same exact thing in both places, but two separate loops for two different things. So this is from yesterday. It computes where it computes the offset that needs to set for each line, for each iteration entry. So now when I run it in a second, I have to adjust it, I think. This bit should be set here, 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 all the way down to 15 if it's working. So now I have the bit being set. It enters, everything's set up. Every entry, it should do this. So I'm going to take it, R13, register 13, wide, 16-bit. This isn't related to the computation. This is just to print to the line in the message box. And this sets RBX, which I forgot earlier. But now it's being set, as you can see here, whatever. So like, it's adding, it doesn't matter. This prints the same way as the other way. This just does more work. Because the other way is kind of like set up. It didn't need this extra addition. But right now, it is printing backwards. So I'm going to flip it back. I'll just keep it set up like this and then change this. Optimization wise, this could potentially be faster or slower. It depends entirely on the CPU. But you can kind of like guesstimate which instructions and weigh which ones to use based on various CPUs. But this might be slower, but it could be faster because decrement is faster than addition sometimes. In context. Everything I say assembly related is in context. So now I'm going to run it. All I changed was the rotate carry to make it print this value in the correct direction. I did change the rotate stuff, but that doesn't matter because it's not being printed. That's like behind the scenes or whatever. But I'm going to attach it to here after I check and make sure it's printed right. Assembly is so much fun. I don't know, it's not fun, but it's better than C programming. It feels like actually accomplishing something. In C programming, it's like you don't get what you want. You have to write it in a really funky way. You have to deal with the compiler, the bugs with the compiler. I don't know. This is better. Assembly. It's way better. Okay, so now it's printing correctly. So since it's printing correctly, now I'm going to set it dx whatever. I'll just set it underneath. This isn't a speed test. This isn't optimized. So it doesn't matter. I'll just set it twice. I'll have it here as notes. So if I like want to like print this or whatever, so I'll just leave it if I ever need to print like this again. And I can just comment this one out. So we'll do this instead or whatever. So I hit save. So now the whole thing, nothing changes except for dx. That's the only thing I changed. So now dx is going to be set to R13W. dx is 16-bit, it's D high and DL. R13W means R13 word, which is 16-bit. So it's getting the 16-bit, the bottom, from the 64-bit register because this is 64-bit register, and this specifies 16 bits only from the 64-bit register. And then I don't know if this will set the register when using 16 bits, if it destroys all the bits above it, or only above 32 bits. So I will Google that, or maybe I shouldn't. I'm going to try Sandtrack for now. So now when I run it, dx will be set to this, but it doesn't matter. It's being overridden to this, which is the register being rotated. Where the heck is it? Here. Now, when I run it, it's going to print 1, 1, 1, 1, 1, all the way down to the bottom corner. This computer is so laggy. I clicked down. I don't know what happened. Like the key got stuck or something. I think this computer needs more cooling. It's getting too hot. And the USB is loose. It's probably the main thing. which means I'm not safe to like plug in a USB drive and copy data. It could totally screw it up. I need to get a new motherboard. But the SATA drive, that's also loose. I need a new motherboard. Okay, so since it rotates whatever, this is what should be printed to the window. I keep saying to. Weird. I don't know why I'm doing that. I don't know. I think I like saying to. The mic doesn't sound as clear, but then saying to sounds weird. There's no way to win. Unlike assembly, there is a way to win. I'm gonna write faster assembly than the C compiler. Or I don't know, that's the plan. Let's see how it goes. So I saved it. The only difference is it's doing this. I over-explained everything. So I'm gonna run it. And did it work? Looks like it worked. So that's done. So now it loops 16 times. I'm using a 16-bit register. I'm testing, or I have a routine, whatever, to test up to 16 bits. I'll make another one after that does 64 bits. So like in the number, no matter what the number is, since it's a 16-bit number, there's only 15 possible positions because it's 16-bit for the bit to be set that's high. So like the bits below it, it doesn't matter if those are set. All I'm testing for is the highest bit that's set. So the first part of the routine needs to set. It needs to keep 1 bit. So like right now, this is like optimal condition. So I don't know, I talked about this like 2 days ago maybe. There's like 2 parts to the routine. It could be merged into 1 big part, but I'll just keep it 2 separate parts. I think I have a way to like cut the code down to half of what the instructions, like to fold the whole thing and compress it to make it faster, whatever. But if this is faster, I'll just show this. I'm not gonna give away assembly techniques. Well, it's not really assembly techniques. I don't really remember the assembly that well. It's like the logic behind breaking it down to the fewest operations. The instructions themselves are important, but the logic is more important because you need the logic to determine what is being done or whatever. It's like the timing and stuff with the instructions is important on the table, whatever. It's like the timing in the table. That's extremely important, but it does vary between registers. Sometimes a lot, sometimes a little. So the most important thing overall is the logic, whatever, in the instruction count. If the logic is better, the number of instructions needed will be less because on the table or A table. It depends on the CPU. No matter what instruction there is, it always takes at least one cycle or clock cycle, UOP, whatever it's called. This one's ops or clock or time. There's different names for it. No matter what, it physically takes at least one. It has a latency of one or has some form of latency. So like in the best case scenario, every instruction would take one or a little under one of a clock cycle, whatever you want to call it. So like let's say it's like best case scenario, if every single one of these instructions takes one to execute, it takes one execute, that's going to take it'll take 26 time. Or ops, or UOPS, whatever you want to call it. So like, this is Visual Studio, Microsoft Visual Studio output. The assembled code that it evaluates and creates from the C code. This is what VCC makes. So like if every one of these is optimal, every instruction takes one time, whatever you want to call it, cycle. And there's no latency. Everything's always one if it's like the perfect CPU. Even if it's like out of order and stuff, and has a whole bunch of shit internally, like Chatbot said earlier, it still takes a cycle, and only so many can be done cycle, even though it does do multiple at one time. If each of these take one, it's going to take 16 time UOP cycles, whatever you want to call it, overall, which means this is going to be faster than Visual Studio, which takes 26. So in a perfect world with the super awesome CPU that has perfect instructions, they're all the same time of one. These would both run, and this is going to be faster no matter what the CPU, no matter how good it is, because one is one cycle is one cycle. Now, there has to be like a base that something takes to complete. It's not possible for all of them to take less than a cycle, because if they all take half of a cycle, like let's say they'll take 0.5 a cycle, that literally means that they take one. Because it means it's faster overall. So maybe it's like a 2 gigahertz CPU, you clock it up to 4 gigahertz, then it would be like a 1 is now 0.5. Because time and the amount to execute, like, do you know what I don't know. I think I'm explaining this in a way that makes sense. If everything's one, and like a CPU that's not the world's greatest CPU, say like a couple of these are slower. Like this one takes 2 maybe. Maybe this one takes 3. and then 4 and 4. So now, since these are slow or whatever, so like this is +1, slower, 2, 3. I'll just write it like prison style, whatever it's called, as ticks. So like 2 times slower, it would be 2 ticks. And 3 times would be 3 ticks. So all these that are 4 times slower be 4 ticks. Okay, so like this is an unoptimal CPU. Because some are slower than others, which is real world because some of these take one UOP, whatever you want to call it, the clock cycle. This one takes a 9, so this one's really slow. What's this one? Push. Man. Usually the push instructions are faster. They're supposed to optimize for function calls. So I don't know. So like 9, 3, 6, none of them are all going to be 1. So in this like example, this isn't real timing or whatever. It means I have to take all these 1s. And I'll put them at the bottom here. And I'm gonna like split them up so they all take up a line. Like straightening out. A clump into a single line. Okay, so now it's linear. Like there's no instruction here, but like maybe like this one takes 3. So like maybe I so like this would be like the shadow time, whatever, the cycles that are spent on the extra instructions that take longer to do, whatever. So now that it's not a perfect CPU, it did take 16 instructions, but now it's going to take 25 instructions. And then the Visual Studio, it was at 25, 26, which means that if it's not a perfect scenario CPU, that's not all 1s, cycles, clocks, UOPs, whatever. If it's not all 1 to complete, even though it's less instructions, it takes more time. Not more time though. It takes 1 clock, or it ended up being at 25, 26, so it's 1 clock less. So in this scenario, if this wasn't a perfect CPU, even though it's less instructions, it's going to take about the same time. But since this wasn't a perfect CPU, there's no way that this is a perfect CPU. So I'm going to apply the same imperfectness to the CPU as it was in this one. So now I'm going to apply that to this side. Like, let's say it's like the same CPU model, because if you compare it by speed and stuff, clearly one's faster than the other. So I'll like just put these somewhere. Alright, so I put it next to the negate. So like let's say like negate locks up the CPU pipeline because there's a whole bunch in a row. It can only do so many negations at a time, so these get slower or something. So whatever. So if I take now that the CPU is like a real CPU, it's the same as this one, whatever. But really, since there's more instructions, there'll be more things that are slower. So I'll like duplicate, or I'll add some more time to a couple more instructions. Alright, so now like they're not all ones. It's kind of like some are a little bit slower, some are a little bit faster. So it's like more realistic because it wouldn't directly apply. So I'm going to take up all these ones and see when I spread it out over time how many cycles overall. And now all the like uneven whatever, more than one cycle, they're globbed up on the bottom. So I'll make it linear. So now when they're like, let's say like this is real world circumstances, it's not a perfect CPU. Some instructions take longer than others, which they do, because if I go to the table of real world CPUs, some take longer than others. Some are like 9 and clock cycles go up, so whatever you want to call it. Or 1, some are 2, and some have longer throughput, some don't. It all depends. It's 18. I don't know, whatever. That's why it's confusing too, because it's like 1 out of 3. Then this was 18. That's confusing. So, in a real world scenario, even though GCC, GNU, whatever it's called, it was $16 instructions. Here, whatever, when you add up the fact that they're not all one time, it gets up to 25, so it's slower based on real world scenarios, whatever. But it's still faster because in the Visual Studio code, when you add up all the extra instructions, it was bigger in the first place, 26, but now that it's not a perfect CPU to be the same as over here, you're looking at 41 instructions, which is still about so it's about the same distance and speed when compared to GCC, GNU, whatever it is, to compile the code. And this still isn't a real world scenario, because some of these are like 9, 10, 1, 2. It just depends. So if like Visual Studio had an instruction that's like 9 cycles to complete, that's gonna really slow this thing down. So if I take those 9 cycles, whatever you want to call it, time, UOP, clocks, something, and I like make it linear, now the Visual Studio Code is at about 50 instructions, but not instructions, it's time in general, cycles of all the instructions overall, because they're not all 1 unit to complete or whatever. So the more of the like oddball, really slow instructions, which exist in the real world, the slower it'll be. So when you're writing assembly, if you stick to the ones that are more commonly used and tend to be less instructions, it's gonna be faster in general, even if you picked the perfect instruction. So, instruction count in context, I guess, because really anything is true, but in context, I am almost certain that the instruction count and what was the other thing? Something else. The instruction count is like one of the major important factors, because no matter how fast it is, it takes time to complete, but each one's gonna take at least 1 cycle to complete. So like less instructions generally means faster code, unless all the instructions are very slow, which I kind of already explained by like doing this or whatever. So I don't know. That's kind of what I aim for when doing assembly and stuff. I don't know, that kind of possibly explains it. You could ask Chatbot too, and see what Chatbot says. I'm not gonna ask Chatbot, I'm gonna stay on track or whatever. I need some water. My mouth is so dry. So, I've completely forgotten what I was doing. Entirely. Oh, I was gonna set. So like this is like a perfect scenario. If I can get it, there we go. A perfect scenario for a bit test is 1 bit set, but that's not the real world. There's gonna be other bit set. So I'm gonna like set it to a different value, whatever. So if I set R13, the value is going to be rotated. Instead of setting it to 1, I'm going to set it to this value here, whatever. I'll save and run it. So this would be like perfect world scenario. But the number is going to generally look like this or something, or some value, where it's going to be more bits set than just the top bit. So like the first part of the routine, it gets the top bit. It doesn't get the top bit. It takes a number in general and it folds it in half and half and half. So it carries whatever bit's set to the bits below it, cutting the number in half. So I'll go over that when I get back. I had to get some water, my mouth is so dry. So I'm going to test the first part of the routine, which will set all the bits on first, and then I'll XOR the flip and keep only the top bit. And then the second part of the routine is where I do like the trick or whatever, where I take the position of the bit and unfold it or refold it back into an accumulated value instead of the bit being set as a distance from the base. I roll the number back up instead of unroll it. So it's like the second routine. And that's what I'm comparing in, or comparing against in C, when Visual Studio, the C makes this output, which is shit, and GCC makes this. I'm going to compare my code against Visual Studio and GCC. And then I'm comparing it because I'm writing a JavaScript engine. I have to get back to that. To stop with assembly. So I'm going to compare everything, see what's faster. Visual Studio, GCC. Or my assembly, wherever it's at, is somewhere in the file. Because I'm writing a JavaScript engine that I gotta get back to, so I gotta hurry up and finish this up. And I gotta go through the standard, that's 800 pages. From top to bottom, whatever. I'm gonna apply assembly, whatever, to like the big parts of the program. And current JavaScript engines, if you ask Chatbot, they don't use SIMD instructions for JavaScript. They want to, but they don't. So that's what I'm going to do. Right now I'm testing general purpose registers. Then I'm going to test 64-bit. Then I'll test MMX or SIMD, whatever you want to call them, later. So like I don't know, I'm basically testing to see if I can beat the compiler. Like if I can beat the compiler, this and this, whatever, on like a first attempt. Because this is like a first attempt right here, whatever. I still have to check to make sure it works, whatever, correctly. But if I can beat the compiler on the first attempt, if I like optimize this 3 or 4 more times, then I'll be able to get much faster code, much smaller code. Because I kind of already explained how optimizing kind of works. If I can get much smaller code, like this is probably going to be faster, unless the instructions take longer to complete, but they do look fast. But if I can make my code to like this big in space or size, whatever you want to call it, length or span, if this is GCC, but if I could make my code this big, this would most definitely be faster than this. The C compiler is somewhat generic. It's not a human. I'm actually a human. So, since I'm a human, I can optimize and get code that big when the compiler can only do code, generate code that's this large. So I'm going to basically be testing whatever to make sure it's worth it. So if it's not worth it and I can't beat the compiler, or I'm like neck to neck with the compiler, and there's not much benefit to doing assembly, then I won't bother with assembly. But if there is a big benefit, then I'm going to end up doing assembly if I can get code about this big, and if it's faster, because it'll be dramatically faster. Because they do use C in the current JavaScript engines for some things, like for hash maps and stuff. So if I'm using C2, I'm not using C++ hash maps. But if I'm using C, then it means my code's gonna be, in general, on par with JavaScript. But if I stoop down to assembly level and I get stuff faster than C, then my engine's gonna be faster, like a fuckload faster. Like so much faster, it's be like fast as fuck. So that's what I'm trying to figure out. Because I'm gonna have to like write stuff in assembly if it's gonna be worth it when I get back to this engine, whatever, and write my JavaScript engine. So I don't know. I'm gonna get some water. I'll be RB. And like I'm almost ready to speed test this stuff. I just gotta test the routine, make sure it's working. Only like 15 iterations. So like it's easy to tell if it's working or not really quick. So I'll do that when I get back. I think I'll actually be able to speed test it. I'm gonna get some water. I'll be RB.
If capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R contains yield expression is true. It is a syntax error if capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R contains a weight expression is true. It is a syntax error if any element of the bound names of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R also occurs in the lexically declared names of a concise body. It is a syntax error if capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R of a concise body is true and is simple parameter list of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is false. 5. 9. To static semantics. Capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R. The syntax directed operation capital A S Y N C capital C O N C I S E capital B O D Y capital C O N T A I N S capital U S E capital S T R takes no arguments and returns a boolean. It is defined piecewise over the following productions: a concise body, expression body, return false, a concise body, a function body, return function body contains use strict of a function body. 1. 5. 9. 3. Runtime semantics. Evaluate a concise body. The syntax-directed operation evaluate a concise body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns a return completion. It is defined piecewise over the following productions: a concise body, expression body. Let promise capability be new promise capability, %promise %. Let decl result be completion, function declaration instantiation, function object, arguments list. If decl result is an abrupt completion, then a perform call promise capability undefined decl result 4. Else a performance and function start promise capability expression body return completion record return promise capability empty. 5. 9. For runtime semantics. Capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E. The syntax directed operation capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E takes optional argument name, a property key or a private name, and returns an ECMAScript function object. It is defined piecewise over the following productions: a arrow function, a arrow binding identifier equals, a concise body. If name is not present, Set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let parameters be a sync arrow binding identifier. Let closure be ordinary function create. %async function prototype source text parameters async concise body lexical this env private env perform set function name closure name return closure ECMA International 2024 357 async arrow function capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body. If name is not present, set name 2. Let env be the lexical environment of the running execution context. Let private env be the running execution context's private environment. Let source text be the source text matched by a sync arrow function. Let head be the async arrow head that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let parameters be the arrow formal parameters of head. Let closure be ordinary function create. %async function prototype source text parameters async concise body lexical this env private env perform set function name closure name return closure 5 9 5 runtime semantics evaluation async arrow function async arrow binding identifier equals async concise body capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals async concise body return capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E of async arrow function 15.10 tail position calls 5.10.1 static semantics is in tail position call. The abstract operation is in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. It performs the following steps when called. If the source text match by call is non-strict code, return false. If call is not contained within a function body, a concise body, or an async concise body, return false. Let body be the function body, concise body, or async concise body that most closely contains call. If body is the function body of a generator body, return false. If body is the function body of an async function body, return false. If body is the function body of an async generator body, return false. If body is an async concise body, return false. Return the result of has call in tail position of body with argument call. 5.10.2 static semantics has call in tail position. The syntax-directed operation has call in tail position takes argument call, a call expression parse node, a member expression parse node, or an optional chain parse node, and returns a boolean. Note tail position calls are only defined in strict mode code because of a common non-standard language extension, C10, 2, 4, that enables observation of the chain of caller contexts. Note one call is a parse node that represents a specific range of source text. When the following algorithms compare call to another parse node, it is a test of whether they represent the same source text. Note 2, a potential tail position call that is immediately followed by return get value of the call result is also a possible tail position call. A function call cannot return a reference record, so such a get value operation will always return the same value as the actual function call result. 58. Copyright sign, ECMA International 2024. It is defined piecewise over the following productions. Statement list item. Let his be has call and tail position of statement list with argument call. If his is true, return true. Return has call and tail position of statement list item with argument call. Function statement list. Empty. Statement list item. Declaration. Statement. Variable statement. Empty statement. Expression statement. Continue statement. Break statement. Throw statement. Debugger statement. Block. Return statement. Return. Labeled item. Function declaration. For in of statement. 4. Left-hand side expression of assignment expression statement 4. var for binding of assignment expression statement 4. For declaration of assignment expression statement case block return false if statement if expression statement else statement let his be has call and tail position of the first statement with argument call if his is true return true return has call and tail position of the second statement with argument call if statement if expression statement do while statement do statement while expression while statement while expression statement for statement 4. Expression not statement 4. var variable declaration list expression not statement 4. Lexical declaration expression not statement for in of statement 4. Left-hand side expression in expression statement 4. var for binding in expression statement 4. For declaration in expression statement ECMA International 2024 359 with statement with expression statement return has call and tail position of statement with argument call. Labeled statement label identifier labeled item return has call and tail position of labeled item with argument call. Return statement return expression return has call and tail position of expression with argument call. Switch statement switch expression case block return has call and tail position of case block with argument call. Case block case clause assopt default clause case clause assopt let has be false if the first case clauses is present. Set has to has call and tail position of the first case clauses with argument call. If his is true, return true. Set has to has call and tail position of default clause with argument call. If his is true, return true. If the second case clauses is present, set has to has call and tail position of the second case clauses with argument call. Return has case clauses. Case clauses case clause. Let his be has call and tail position of case clauses with argument call. If his is true, return true. Return has call and tail position of case clause with argument call. Case clause. Case expression. Statement list opt default clause. Default. Statement list opt. If statement list is present, return has call and tail position of statement list with argument call. Return false. Try statement. Try block catch. Return has call and tail position of catch with argument call. Try statement. Try block finally. Try block catch finally. Return has call and tail position of finally with argument call. Catch. Catch. Catch parameter. Block. Return has call and tail position of block with argument call. 60. ECMA International 2024. Assignment expression. Yield expression. Arrow function. Async arrow function. Left-hand side expression equals assignment expression. Left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression bitwise and expression and equality expression bitwise or expression bitwise or expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression equality expression Equality expression equals relational 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 expression relational expression shift expression relational expression shift expression relational expression equals shift expression relational expression equals shift expression relational expression instance of shift expression relational expression in shift expression private identifier in shift expression additive expression shift expression additive expression shift expression additive expression plus multiplicative expression additive expression multiplicative expression multiplicative operator exponentiation expression update expression exponentiation expression update expression left hand side expression plus left hand side expression plus unary expression delete unary expression void unary expression type of unary expression plus unary expression await expression ECMA International 2024 361 call expression super call import call expression call expression identify name call.
Testing. Is this thing working? It works. Test. I think it's working. I just drink water. My throat is still. Dang it. I'm not even trying to whisper. My voice just keeps cracking. Okay, so I think like 40, 50 minutes before like the stream hits 12 hours. So I'm gonna try to like just get this running. I know the print part works, whatever. So like there's two parts to the code that I'm using, whatever, to like to get the highest bit set. 1 second. I need to like find the original. Windows moved around all my freaking Sublime windows. Nothing's where it was. I can't find anything. thought I saved a copy of it. The heck is it not finding? The heck? Okay, I finally found it. That took way too long. It wasn't like searching the folders. I don't even know. I might have to restart. Something's wrong with Windows. Okay, so basically, this is the C program, or the C routine. I know there's an instruction at CPU level to get the highest bit set, or it's something like that. What I'm testing for is the efficiency of the C compiler at generating the logic. And then, I don't know, my voice is so cracky. I need some more water. But I explained how like the instruction count is kind of like the most important thing. That probably made it sound easy, but it's not just the instruction count. It's also the cache size, the amount of memory, the jump instructions. Sometimes more code could be better. I don't know. Not generally. There's like a whole bunch of things to take into account, and then there's memory access, fetching from the cache, or doing fetches to bypass the cache, or I don't know. It's like there's tons of stuff. So I'm just trying to like test this or whatever to see if with this code, this logic, whatever, how efficient the C compiler is, whatever. Visual Studio isn't very efficient. So the first part of the routine here, this is like common knowledge, everybody does this, or like it's known, whatever. I'm not claiming this part, but this part, I haven't seen this technique specifically used. So like, if nobody else actually did do it and they didn't claim it, I'm claiming it mine. There's a better technique than this, or it's the same technique, but it'd be written better. The way I wrote it here or down there, whatever. I'm not gonna like write it for real, for real. I'm just trying to like write it so it'll be fast enough to prove that it's faster. I don't want to. I don't want to give away a bunch of free code. So this is a C program. I'm gonna paste this into the Godbolt compiler. On the left-hand side, whatever, here. I'll give the instructions. So I'll do this for Visual Studio. But you gave this last time, I'll do it for GCC too. So I'll paste the first part and the second part. This is only the second part. So paste that in, this whole thing in over there, so I can speed test it. So I'm going to make sure this part works first, whatever. I'll test that now. And I'll test to make sure the second part works. And then I'll paste this into the browser like I just said, whatever. I don't know. I don't know if I have enough time. I hope I have enough time. It took so long to just find this. I forgot to switch the screen. It took way too long to find this. I was like doing Control F and it was searching like it was only like 103 files. I was searching for it and it just wouldn't find it. So I don't know. I found it now. I have a copy of it here. So I'm gonna like make sure the code I have for this part works. I'm gonna test it. I'm gonna make sure this part works. Then I'm gonna speed test it. I'm hoping the clock works that Jetpack gave me. I didn't try it yet. Assuming it works, I'll have enough time to test stuff. If not, I don't know. I'll have to figure it out. So this first part here is down here. Right here. So I'll paste this in. I don't know. I'll just make a backup of this file and then delete stuff because there's so much crap in it already. This theme's getting old. I'm gonna like switch it up with something different. I'm going to set this value R13, the register used to hold the rotated pin. I'm going to set it back to 1. So it's going to propagate the bit to the left each time. I got this new block, whatever. Here, whatever. This is part 1 of this. Oh, my throat is killing me. Of this here, whatever. Part 1, where it says set. It's going to fold the value, set all the bits on, then XOR it with it shifted once to set all the bits off underneath it to keep only 1 bit. So right now, it's gonna do this, whatever. It's gonna set the bit, rotate each time. So I'm gonna turn off the bottom part of this routine. I don't know. I'll put OK so I like remember to go back to it. I probably won't remember. So that turns off what this part would do. So now the result, it should fold the number. Meaning that when it prints, instead of printing this now, if I pass this in to here and I take the result and print that instead of this, so I like apply an operation to it, which is in here. When I apply that operation, if this is working correctly, the part 1 of it, it should make this result. Right here it's folding the number whatever, or it should be, assuming it does whatever. I still have to test it to make sure it works. My throat is killing me. So I'm gonna fold the number. If I pass it in, this is what it does now. I'll run it now. So I'll turn this off. Build it. Oh, it's still open. Now it should build. Okay, now built. So right now, it prints this. It's just rotating bit, or rolling the bit. So now, after the operation, instead of this, if it's working, the routine that I made, it might not work. I don't know. I didn't try it yet. I wouldn't be surprised if it doesn't work. It's probably not going to work. But if it does, it does. So results should be now after I run it and test whatever. It's taking way too long to type this up. So now, if the routine below works, it should print this here. So instead of this, that does now. If it's working, it'll look like this. And then after this, I'll turn this back on if it's working. And then it will look like this again. And the reason it has to do this is because the bit that's set is not known. So it sets all the bits to the right, it folds the number. So if the number looks like this, so it's like 0010, it makes sure that it looks like this pattern where it's anything above is off, everything below is on, like binary, true or false. Only the top bit is the top bit, everything higher is off, everything lower is set on by folding the number. And then it does an XOR whatever, or an AND, however, it doesn't matter how it's done, whatever, it's just done. It does another operation that takes this result, shifts it to the right one, and then XORs it or ANDs it. It doesn't matter. But the operation then, since it can cancel out whatever, it converts it to like only one bit being set because everything below it is part of their operation done to undo itself or whatever. So that way, when the number's not just one bit set as other bits set, it turns into this, which turns back into this. So the only way to know if this part's working is if it does this first, then it's like, oh, it works. Then turn on the next part, turn it back to this, to turn it back to this. And I just gotta test the second part of the routine. And if everything's good, I can speed test it now. Let's leave this up here. So I'm turning this on. I had it set up to use R15. It's what's being passed in. But now I'm using R13. So I'm going to take R13, the bit that's being set, rolled or whatever. This computer's so laggy. And instead of 15, I'm going to pass it in here. So now, I guess here. So that's that. this last instruction here, I said CX to AX. So I guess CX, I'm going to destroy D, B, and A. And then, I don't know, this is to print it, so I'll just pass it in, possibly with R13. Not R13, I'll go to like R12. Because R13 is used to rotate. I don't want to destroy it. So I'm going to leave it. I'll just use another register. So double check I'm not using R12. And I'm not. So I'm going to set R12 equal to AX. So boom. R12. I should probably, I'm not going to optimize, I'll just leave it. So I'll turn that off, whatever. So like, AX holds the result. So I'll move R12 right here. So now at this point, R13, the bit being tested, whatever, that's being rotated left. It's assigned, the operation is carried out. The results in AX. That's being moved to R12. So now R12, I'm going to pass it down here to here. So there's no point in commenting this out, because this is just to print it, so I'll just leave it. If I comment it out, I'm at risk of deleting it later. So if I just leave it, it'll just be there. But right here it's going to be holding R12. So I'm going to set R12 to 0 outside of the loop, so when it enters, it will at least be 0 instead of like garbage, but I would assume it's 0, but it might not be always. So now it's going to enter here, assigned R12 here, set to 0 up here, just in case I have its old garbage. So now it's not going to hold a garbage value. in C, when you do XOR, they replace it always with the move 0, and that pisses me off. You can't even, they do it on purpose. They don't want you to try to optimize code or use XOR to break register dependencies, because the compiler is like, oh, we're in control. And then they like create tons of register dependencies. I don't know. Compiler sucks. So since this isn't C, I'm finally able to do XOR to set to 0. It feels amazing. This is great. I hate doing XOR in C, and it's like they just switch it to move. It kills me. It makes me feel dead inside. The least they could do is just XOR it when I say XOR in C, but they don't. So it's real nice to be able to like type XOR. Anyways, to clear the whole register. I guess I can run it now and see what the result is. If it doesn't work, I said it doesn't work. This is an error. Dang it. Oh, I forgot to make it wide. And then build. I'm hoping it worked. And it didn't work. That's great. So now I gotta make it work. So I'm gonna just comment out the whole thing and I'll rewrite it, but I'm not gonna optimize it. I'll just write it to make it work. So what do I need to do? Let's do this. I need to zoom out. I can't see anything. Zoomed in that close. I'm like, rewrite or whatever. And test if this works. Dang it. Oh, I typed or. That's closer. No, it's not. I think it's the same thing. I'm just gonna literally type it up the same. Nope. Well, that worked. Not make the operation. Huh. Okay, now it works. That's why you don't prematurely optimize code. So I'm gonna not optimize this. I just wanna get it running. I don't think I have enough time. Dang it. If it would have worked the first time. There's not enough time. I'll just try the second part of the routine, whatever. It's probably not gonna work. And this isn't optimal. I can technically use the last shift instead of doing what I just did. But this works, so whatever. I think this would work too. I'll just try it really quick. So turn this one off. So this one adds, no it doesn't add, it's the same instructions. So I can speed test this whatever, because this one does shift right AX, or BX AX, or AX BX, but it does it, so it does BA, BA, B, BA, BA, A2, BA, I don't know. This one switches it around. This might be more optimal, but not, because a move is generally faster. So I'm gonna try this, see if this does the same thing, whatever. And there's like 30 different ways I could write this. I could also carry the register like I was trying to do up here, but I don't know. I totally messed it up. So I'll run this really quick. I think AX, it does hold the result. And this works too. So that's two different ways to do the same thing. So like this is like two different ways to do the same thing, whatever. So I could speed test both of these, pick the best. I could even make a different, if I like test it on AMD and I test it on Intel, if I wanted to. If it's worth it, it might be. I could make, like let's say like this happens to run faster on Intel. Maybe Intel does better with move instructions because this one has a move, a shift, an OR, a move, a shift, an OR. This one is a move, shift, OR, shift, OR. So like let's say like this is better on Intel, this is better on AMD. There's also the SAMD instructions. So like the MMX registers. That's a whole other thing. But if I write an assembly, if I can beat the compiler, whatever the compiler makes, like Visual Studio, this is GCC, GNU, whatever it is. If I can beat the compiler, which I'm pretty sure I can, I could like make a separate executable for like Intel processors and AMD processors. Did they ever add 3D Now back to AMD CPUs? I'm gonna Google that really quick. How long is the stream? The stream's at 11:41, so I have 10 minutes before I gotta start another stream. Okay, so since I'm doing this by hand, whatever, if it's worth it, which I think it is, it should be. For the JavaScript engine, whenever I get to the standard, and I'm going through the standard, I would like theoretically be able to control the assembly, and I could compile it for all various kinds of CPUs. So like SSSC or SSE4, AVX, 128-bit registers, FMA, whatever, all these like extra registers added. I don't know if 3D Now is still saying MX. I'm gonna Google if they added these back to AMD. It says obsolete. I don't know. It's probably still obsolete then. I could like make, after I meet this standard, make an executable for like this generation of processors. Or maybe just for these. Or just for these. It doesn't matter. I could like actually control the build and like write the code, test the code, and have like a higher quality and finer tuned code and stuff. Like obviously, I don't know, that's the whole point. So like there's like two ways to write this. There's more, there's tons of ways. So like these two both work though, whatever. I think this one could possibly be faster because it goes BA, kind of alternates more. This one, it relies on the value being carried each time. There's less out of order execution available. But it might not be slower because move might actually be quicker than an OR, even though the OR, in this case, saves on a dependency. So I don't know. I'll just keep the second one. No, I'm not. Yes, I will. So move. Looks like 11131. And OR is 111. Alright, the OR might be faster. No, this is OR XOR. No, it's and OR. It's all three. It's and then OR, and then XOR. Not and or XOR. They're three separate ones. Okay, yeah. But this is like 0.323. Now the move is like the same. They're probably both the same speed. So, I don't know. It doesn't matter. I'll just keep the second one. And it looks like something isn't working. Okay, so this one did work. So this one works. This one might not work. Maybe I looked at it too quick. Okay, maybe this one wasn't working. And I looked really quick and I assumed it was working. I'm gonna paste it again. Oh, that's what happened. I forgot to set it to 13. So this here, whatever, it's not even being set to the value. It's like the register that it's being set to here every iteration. This one, whatever, it's being set for this one, but I forgot to set it here, so it has like a garbage value. So now it should work. Which means that this one is now one instruction longer. Which means it might be slower. So I'll go with the first one. So I'll like run this again, whatever. And it works. It's way too easy to accidentally mess it up. Okay, so instruction-wise, count-wise. Dang it. Okay, so now I know they both work. I checked it. So they are. Okay, so they are. Okay, yeah. This one is the bottom one. This one here is one more instruction. So this one is probably going to be slower. So I'll go with the first one. Or I'll pick the first one for the speed test. So now I gotta like check the second part of the routine. But I think the stream is end now. Dang it. Alright. The stream like ended already. It's already at 12 hours. Or 11 hours, 54 minutes.